data science and any data-inspired and data-driven science is so critical right now. More and more decisions are made based on data. The amount of data that we gather every day and the insights that data can provide us is just growing exponentially, and that is no exaggeration.
The market for data science and related areas like AI is booming.
It is so important to have women in artificial intelligence in the area of data science and also in leadership roles. It's being able to use data to solve issues and understand bigger problems. It's critical. And we need women in these roles. Every individual brings their own perspective. And so we need to make sure the entire workforce is represented.
And the good news is there's so many jobs and many different ways to combine their passion area and their skills in data science and get involved.
I would like you to say, what are the problems in the world that absolutely have to be changed? And, can you individually, given all the amazing background that you've had so far and all the education that you've got so far, what are the unique things that you can do to change the world towards that mission? And then think of the technology.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have your say.
If you're not looking at the data from all sorts of different angles, then you could introduce a lot of bias. So it's really, really important that we have around the table all genders, all races, all backgrounds.
We can't ignore social and structural problems. We can't just go in a corner and write some code and read math and then that's the solution, right? Can't do that. So we have to think about who is being affected by these algorithms.
Welcome to WIN!
When we first started this conference, we never would have imagined that we'd be sitting here today with over 200 regional events. We've got over 500 WIDS ambassadors worldwide. Many of them are women, but we've also got a lot of men. And these are people who are just passionate about inspiring others within their community. We're in over 60 countries, and year after year, we're blown away.
Let's make this next decade the Women in the Data Science decade.
What I love about it is that growth is viral. That people will attend one event in one city and then they'll want to bring it to their cohort or colleagues the next year.
This type of industry can be done everywhere, so it should be accessible to everybody. And this is one of the reasons why I love that we are global with WIDS.
So we wanted to create opportunities for women to inspire, educate, and support women at many different times throughout the year. And one way that we decided we could do that was through a datathon every year, which is a predictive analytics challenge using real-world data. We have over 900 teams from 85 countries, and that's in every continent except Antarctica.
When we started WIDS in 2015, we had no idea this was going to be a global movement with tons of international events and a datathon and a podcast show and now outreach to middle school and high school. It's just been such a ride.
Our latest endeavor is to work on some materials that we can hand off to teachers in schools around the world.
This has provided a platform for literally hundreds of women, if not thousands of women, to have an opportunity to be heard.
But the truth is, these are really simple experiments, but they had profound impact because they empowered someone else to be able to do their job better or to be able to take that message.
5 years ago, when we were sitting around a coffee table thinking about what WIDS could be, I never in my wildest dreams thought it would grow so far and so wide around the world in just 5 years. What I'm most excited about is the next 5 years, because I think this is really just the start.
A very good morning to one and all present here. Hope you all are doing really well. So this was a video of Conference of Women in Data Science in Stanford University, and here we are today organizing Women in Data Science Mysuru, an independent event to coincide with Women in Data Science conference held at Stanford University and an estimated 150 plus locations worldwide.
Hey Arya, I think you need to unmute yourself.
So very good morning to one and all. Hope you all are doing well. This was a video of Conference of Women in Data Science in Stanford University, and here we are today organizing the Women in Data Science Mysuru, an independent event to coincide with Women in Data Science conference held at Stanford, and estimated of 150 plus locations worldwide. All the genders are invited to be here and attend the Women in Data Science events to celebrate, appreciate, and glorify outstanding women doing extraordinary work across the globe. So this is the Women in Data Science Mysuru event, which is organized by Usha Rangaraju. She is India's first woman Kaggle Grandmaster, and she takes a strong lead to organize and conduct talks and events that you see by us. So you can get in touch with her on Twitter at Usha Rangaraju, and she leads 8 communities in Bangalore as well as Mysuru. So she plays an avid and important role for making these successful events a dream come true. Women in Data Science Mysuru is organized in collaboration with 4 universities, namely NI Mysuru, VVCE, JSS, and GSSS. So the organizers of these teams at respective universities have extended immense support and played a vital role. So this year is the organizing team of JSS and followed by NIE, VVCE, and GSSS. So we would take this opportunity to appreciate their efforts and continued support with us. Next up, here we have the core team of WiMLDS Mysuru, a huge team which works with immense coordination and dedication towards making all the events a huge success. From marketing to designing to anchoring, they have worked unanimously under the guidance of Usha Rangaraju. So our team is organizing consistent such events throughout. To keep yourselves updated, you can stay tuned and catch us up on our upcoming plans on our meetup platforms and pages. So here are all the links. So don't miss out on anything. So before we move ahead, I would like to also take the opportunity to introduce Ms. Dr. M.P. Pushpalata, who is currently a professor in the Department of Computer Science and Engineering with nearly 3 decades of teaching experience. She's a very passionate and committed teacher to inspiring students to pursue academic and personal excellence. She is driven by the motto, anything worth doing is worth doing well, to create a challenging and engaging learning environment for students and herself. So her research focuses mainly on machine learning and healthcare informatics, with a particular emphasis on the applications of healthcare technology to socially relevant issues. She currently is guiding 4 PhD research scholars as well. So, on this note, I would like to welcome Dr. Pushpalata ma'am to render the welcome note on behalf of GSS.
Thank you, ma'am. Thank you so much for the warm introduction. On behalf of JSS Science and Technology University and Computer Science Department, I wholeheartedly welcome all the upcoming speakers of this event. And it's a great opportunity to all of us to have this kind of a platform to share, especially in data science and machine learning. So it's a great opportunity to learn and expose a lot of advantages which are coming ahead. So we at JSS Science and Technology University have adopted the motto of science and technology for a better living. And in achieving this, active participation of women is essential. Increasing the number of role of women in technology has been a relentless effort for decades. However, at JSSSTU, gender equality and most importantly, gender neutrality has been thoroughly practiced. Building a gender diverse workforce significantly leads to more dynamic work culture and increased creativity as well. So in this connection, fortunately, we are associated with Usha ma'am in collaboration with WiDS, Mysuru. Our university and our students, very committed students of computer science department, initiated this DSC JSSSTU and conducted lot of events, more of technical events and social promoting aspects, and a datathon workshop which was wonderfully done under the guidance of Usha ma'am on 19 February 2020 with 2 batches in the Department of Computer Science. The workshop was led by Usha Rangaraju, a principal data scientist, polymath and the lead ambassador of WiDS Mysuru, gave the students a hands-on experience on Causal platform and also mentioned the vast opportunities that the Causal platform holds for all the budding data scientists and how they can take the steps into deep learning as well. It was exclusively conducted for those who were interested and well-versed in Python, and a lot of experiments were conducted which gave the deeper aspects of Causal platform. And the various data structure aspects were also discussed. Overall, the students found the workshop very resourceful and the feedbacks were excellent in this workshop too. Madam made certain visualization aspects related to data sets using various visualization tools such as Matplotlib and Pandas. It was great to see someone who was experienced and knowledgeable as her to bring in so much enthusiasm and keep the students engaged for more than 6 hours in that day. So far, our DSC JSSSTU has coordinated with WIMLTS, that is Women in Machine Learning and Data Science Group, and BGP, that is Google Developer Group, and TensorFlow User Group, have organized more than 50 to 60 events in 2020. Unfortunately, due to this pandemic scene, we were not able to physically meet and then do a lot of activities. But webinars were conducted, and in the upcoming months, we are planning for more events to do on this. And we have totally core team with 20 members. Supporting to this, other students would also work in this team as a team effort. And this We also have an initiative towards Women Tech Maker. Approval is awaiting. And we have done certain outreach programs. In that situation, we have trained certain students and workshop with tutorials. Certain counseling aspects were there. And we are also planning for visiting rural schools to meet all their demands and discuss with them, and certain counseling mainly with the kind of exposure to those students and how exactly we can bring them up in a better manner. And there is a project Reach Out NGO. For them, our students have worked for a mobile application development for Android OS, and how exactly the complete management that can be done with that particular organization. And added to that, students were work for differently able students. We have a polytechnic institute associated in our organization, and we have conducted certain workshops for them, especially in Python and other computer science subjects, and conducted one workshop how exactly a mobile app can be developed for an Android OS. And these were the issues related to the club and the head plan. And they're also associated to the Karnataka government K-Tech organization in terms of startup projects. All these were the activities done from our students through this DSC organization. And basically also we have IEEE JSSSU has taken an initiative to encourage women participation in the field of technology by introducing women in engineering in college. It is one of the world's leaders in changing the face of engineering. The global network connects nearly 20,000 members in over 100 countries to advance women in technology at all points in their life and career. WIE strives to advocate women in leadership roles in IEEE governance and clear advancement for women in their profession. So we have planned certain activities in association with Usha ma'am. Probably we should be able to take it further after we meet our students physically in the college. So lastly, I would like to add certain issues related to this, how we can promote certain capacity building workshops to promote our women leadership, because women have always been instrumental in technology development. Yet, according to the report by the National Center for Women and Information Technology, the amount of women in computing occupations has steadily declined since 1991, when it peaked at 36 for various reasons. Number of factors have contributed to this, probably the workplace culture, confidence level, lack of interest, and inherent bias, etc. So few reports and interviews even say that the growing awareness is slowly bringing more women into the field. And there is one report which I had seen regarding about half of the women who left the science and technology positions continued in the field. Probably, let's say 45% in this moved into a self-employed, and 35% moved to government or non-profit jobs, or 20% shifted their occupation to startups and so on. So what I would like to propose in this is, in association with this WIE here, and with the help of WIDL Mysuru, along with Shaman to Confidence, we can promote certain capacity building workshops and all the components which for women to facilitate better opportunities and well-being. So with this note, I would like to thank for an opportunity given to me to state certain activities which are rendered from our students. I must really congratulate the team of DSC of JSSSU. They are doing an enormous, putting a lot of efforts in conducting various activities and reaching to the students. So for all this, I really thank the Mysuru WIDL support, especially Usha Rangarajan. She's taken an immense support in conducting the activities at our institution. Thank you so much. Thank you so much for the opportunity given to me. Thank you so much.
Thank you, ma'am. It's our pleasure to have had you here today, and we are glad to see the amount of efforts you are putting in for the students. So we thank you for your efforts as well.
Thank you so much, ma'am. Thank you.
So, on this note, let's commemorate our event by introducing our first speaker. I would like to call upon Harshita, my co-team member, to be taking over from here.
Thank you, Arya. Starting off, we have Bhuvaneswari Subramani ma'am, Director, Engineering Operations at Infor, to talk on application and infrastructure monitoring in AWS.
Hello everyone. We welcome you all to the online workshop and talk series brought to you by Women in Data Science Mysuru. Today's topic is around application and infrastructure monitoring in AWS. A little about me. This is Bhuvaneswari Subramani here. I work for Infor and I'm also an AWS community hero from India. Over and about the work I do, I'm really passionate about training and technical writing. And here you go with my blog. Today's agenda is going to be around application and infrastructure monitoring, a brief overview around it. We will also look into the Amazon CloudWatch in detail and some practical usage of CloudWatch with pricing example. Let's get started. Application and infrastructure monitoring is our first section. So AWS is a big container housing huge list of varied services, right? EC2 and S3 bucket were the initial set of services. And CloudWatch is a metric monitoring system that allows you to ingest data. If we consider EC2 as a service, then we will see data that get ingested into CloudWatch. It's all about the system information that can be monitored from outside the instance. If you take EC2 instance, these are the metrics that gets monitored. Our all-time favorite is the CPU utilization, based on which we generally scale up the EC2 instance or scale down, right? And you can install CloudWatch agent within the EC2 instance to collect both system metrics and log files. This applies to on-premise servers as well, using which you can send application log files or system log files to the CloudWatch. Let's get started looking into the CloudWatch. In a nutshell, Amazon CloudWatch is a monitoring service to monitor AWS cloud resources, that is infrastructure perspective, and the applications you run on AWS or on-premise. So here are some use cases of how do you use CloudWatch to collect and track metrics, to collect and monitor log files, set alarms, and of course to automatically react to changes in your AWS resources. How do you access CloudWatch? It's by usual means: AWS Management Console, AWS command line tools, AWS SDKs, and CloudWatch APIs. How does the CloudWatch works? Amazon CloudWatch is basically a metrics repository. An AWS service, such as an Amazon EC2, can put the metrics into the repository, and you can retrieve the statics based on your need. That apart, you can install CloudWatch agent either on EC2 instance or on-premise servers, from which you can send the system log files or the application log files to the CloudWatch, which can be later used for your thorough or in-depth analysis. You can use metrics to calculate statistics and then present the data graphically in the CloudWatch console. You can also configure alarms to start, stop, and terminate EC2 instances after a specific time if they are non-production workloads. In addition to that, you can also create an alarm that can initiate EC2 instance scaling if the demand increases or scale down if there is no demand for your application at that point in time. Here are the key concepts of CloudWatch. So you need to be familiar with the metrics, dashboards, alarms, logs, and events, which are the fundamental concepts of CloudWatch. We'll get started with metrics. Metrics are data about the performance of your systems. So for example, the CPU usage of a particular EC2 instance is one of the metric provided by EC2. So this metrics cannot be deleted. It retires automatically after 15 months if no new data is published to them. So wondering, what if new data keep coming in? The old data gets deleted on a rolling basis. So metrics exist only in the region where you have created them, but you can use CloudWatch cross-region functionality to aggregate statistics from different regions. And you can view from CloudWatch console as well as the respective service consoles. You can go to this particular link, supported metrics link, to see what are all the AWS services CloudWatch metrics supports. So if you consider logging into your AWS account, if at all you have a free tier account, just go and see what are the AWS resources that you have created. For all those resources, you will find the metrics here. At this point in time, some EBS volumes are there for the EC2 instance which I've created. So S3 buckets, I have some Lambda functions and events. So that's why I'm seeing the metrics for these AWS services only. Okay. So if you take EBS volume and EC2 instance, here are the 7 metrics which is available by default, or rather 9 metrics for EBS volumes and 17 metrics, default metrics available for EC2 instance. CPU utilization, network packets out, network packets in, all that. Remember, anything that is used to monitor your system, it will be available by default. If informations like memory, which is within the system, AWS do not get into the system and see what's happening. So for us, we'll have to run the custom scripts to send those custom metrics to CloudWatch, which can be later used to scale up or scale down your EC2 instance as needed as well. So that's about metrics. So here is some information about data retention for metrics. So you have 4 variants: high resolution custom metrics, detailed metrics, standard metrics, and extended retention. These are basically on the data points for which the information is collected in relation to the number of hours this data is going to be lost. If you're going to have data for 1 hour data point, you can have the information for 15 months. Or if you're looking for more accurate information where you want to aggregate less than 60 seconds of data, it's available only for 3 hours. Okay? So that's the data retention for each of the metrics. So next we will move on to CloudWatch dashboards. CloudWatch dashboards are highly customizable home pages to monitor resources spread across different regions. So you can create dashboards either through console, AWS command line, or using Put Dashboard APIs. You can also create cross-region, cross-account dashboards, which can be used to display graphs and widgets from multiple AWS accounts and multiple regions. There is a new release which got out in September 2020. So where you can share the dashboard as an individual publicly shared dashboard without credentials as well. So that's a good thing where you can create one dashboard and publicly share it for people to use it. So there are key attributes to it. Automated dashboards can be pre-built, or it is available as pre-built with AWS service. You can share dashboards, and the dashboards are auto-refresh by default. Here is the dashboard, which you can see for monitoring DynamoDB depicting your account's read capacity units and write capacity units. Next, we will move on to CloudWatch alarms. You can create an alarm to monitor any Amazon CloudWatch metric in your account. The default states that you get are okay, you're going to get an alarm for it, or it's in an alarming state, and insufficient data. Only in the alarming state, that data matches or the condition matches and you'll get an alarm. So some of the examples of alarms are like watch CPU utilization of web servers and send an alarm to auto scaling group if the CPU percentage exceeds the threshold, say 80%. Another example is watch out the SQS, your simple queuing service length of the queue. If it is growing, you may want to add additional consumers which will consume the queue, the messages from the queue. Okay. And another important thing is you can set up billing alert. Say when you create an AWS account, first thing you would do is configuring an SMS notification to alert if the bill amount exceeds $10. So here is the example of the billing alarm that you can set. We'll move on to CloudWatch logs. CloudWatch logs basically lets you to monitor and troubleshoot your systems and applications using your existing system, application, and custom log files. So for example, you can create one group as CI/CD group, which will house the logs from your build logs as well as deployment logs. So to house within one group, you would create something called log groups for focused monitoring, the entire CI/CD logs. Now within that log group, you wanted to differentiate between your build and deployment logs. That's where the log stream comes into picture. Stream is nothing but a sequence of log events from the same source. So log categories, we have three types of categories: vendor logs, logs published by AWS services, and custom logs. So vendor logs, you have the custom metrics that cannot be deleted, but it expires based on the retention policy. And the logs published by AWS services could be from your EC2 instance, AWS Lambda functions, AWS CloudTrail, or any of the AWS services. And custom logs, they are the logs from your own application and on-premise resources. Here is a screen print of a CI/CD pipelines logs that are stored. So I have consolidated my build and deployment logs under log group named CI/CD log group, and the stream is code build log stream. So the build log that you see is for the build log. Okay. So next one is events. CloudWatch events, how it's going to be helpful. So Amazon CloudWatch events is a stream of system events describing changes in your AWS resources. You can define rules with events to take automated actions. So basically, CloudWatch events helps to respond to the state changes. You can even schedule events at a fixed schedule using cron syntax. So you take an example. You have a bunch of teams working in both IST and PST time zones. Their respective dev workloads, that is non-production workloads, it can be turned off by end of their day. So you can write a Lambda function. What you see here is a shutdown EC2 instance Lambda function that can be scheduled to be invoked at a fixed rate. What is once in 12 hours? So based on the tag, if you have set auto of equal to true, so based on the tag, the respective time zones EC2 instance or non-production workloads can be turned off. This is one of the simplest example, but very effective in terms of usage of CloudWatch events. Okay. So in a nutshell, how do you monitor AWS resources and applications hosted on EC2 instance or on-premise servers is all about Amazon CloudWatch. So if you come back to practical usage of CloudWatch, in terms of application log, you can send the application log either from CloudWatch agent EC2 instance or from the on-premise server. Either of that, you have to install the CloudWatch agent and configure which are the application log files. It could be your Tomcat log file, Apache log files, or the log file specific to your application. You can configure to send to S3 bucket. So once you send these logs to S3 bucket, later that can be visualized through Splunk or Sumo Logic. And the logs beyond a certain time period can be sent to Glacier for archival purpose. And then you can define retire policy also, that the information stored in Glacier can be deleted after 6 months or 1 year down the line. So this could be one of the usage. And the other usages, you can have default metric from EC2 instance, which can be sent to CloudWatch. And also you can write custom metrics like memory to be sent to the CloudWatch, which can be later analyzed through Elasticsearch. So that's about the simplest usage of CloudWatch. It's not limited by this. The usage is really vast. Anything and everything that you do with an AWS cloud, CloudWatch comes into a picture. So knowing this service forms a base for what we do. As far as pricing is concerned, basic monitoring at 5-minute interval is free, whether it's your free tier account or after that free tier 1 year period is over, or any account, if it's a 5-minute interval, it's free. Only if you enable detailed monitoring at 1 minute interval, it's chargeable. And here is the examples of how you'll be charged for the metrics. And the next one is, if you take tiered pricing for 7 metrics, assuming $0.30 per metric, it's going to be 2.1 USD for the entire month when I'm going to use 7 metrics for a specific EC2 instance. That's how you would calculate the pricing. You can also look at the CloudWatch pricing for more details. Here are some of the reference links. A CloudWatch mind map from one of my blogs to see how you can map yourself to the understanding of CloudWatch. And here is the official user guide for CloudWatch and a link to the pricing calculator. Thank you so much for being part of the session today. Here is my Twitter and LinkedIn handles. Wish you all the best in the journey. Happy learning. Thank you.
Thank you, ma'am, for such an enlightening session. And now we have Niharika Krishnan, machine learning engineer at TCS Walmart, to speak on data apps made easy with Streamlit. Hello, ma'am. We can't hear you. Yes, now.
Yes. Can you see my screen and can you hear me?
Yeah, perfect.
Okay, great. So thank you. Thanks for the introduction, and thanks to Women in Data Science team Mysuru for having me here. So today we'll be talking about data apps made easy with Streamlit. So before we get started, a little bit about me. I am Niharika Krishnan. I currently work as a machine learning engineer at TCS, where I build natural language processing based solutions for Walmart. So I truly believe in leveraging AI to help people lead better lives, and working on one such research project for Python for Autism is where I went and presented my research work at PyCon Canada conference in 2019. So when not at work, I contribute to the Python tech community as a speaker, mentor, and as an organizer. So I also founded the PyLadies Chennai chapter back in the year 2018 when I was in my final year of college, which is basically a community to promote women to contribute actively to the Python open source community. So that's about me, and with that, I think we can get started. But just before that, just wanted to also tell all of you that I'm just another curious machine learning engineer. I am in nowhere associated with Streamlit or an ambassador of Streamlit. So I came across this particular tool, I think a few months back, and I completely fell in love with it and what it offers. So I just thought of sharing the same thing to the community, right? So with that, before we understand what is Streamlit and what really where it fits in, just want to give a brief overview as to what is the entire data science life cycle, right? So it's complete. It's basically 4 to 5 stages. You have to understand the business. You need to talk to your clients. You need to understand the objective of your project. Once you do that, you then get the relevant data. You pre-process it. You handle inconsistencies. So here you have to actually visualize the data. You need to see what kind of data you have, what are the hypotheses which you can bring out of it. What are the different aspects of the data which you have, and that will actually help you have better insights as to what kind of a data science problem or what kind of a machine learning model which you need to implement on this particular data. So there's a lot of exploratory data analysis which happens in the first stage, which is data pre-processing stage. Once that is done, at every part of this, you need to actually give insights, share insights in terms of visualizations, or share insights to your shareholders to show them that this is the data which you're working on. Once you do that, you then move on to the next part, which is your model training and feature extraction and getting the right hyperparameters, tuning it, and coming up with your predictions. So even after that, once you have a complete application ready, you need to deploy your models, you need to productionize them. So this is the complete life cycle where you start with an idea, you move to training, you move to data, and then you move to machine learning model training, and then you move to deployment. So if you actually see in this entire pipeline, understanding your data, visualizing and sharing insights of your data to the other person is very integral in every aspect of this pipeline. And that's exactly where Streamlit comes in, right? We as machine learning engineers and data scientists, this is our life. We can visualize it when it is in terms of plots, graphs, charts. That's when we understand what's happening when you have thousands and thousands of rows of data set. So how do you currently share insights? How do you run, and let's say you have matplotlib charts or you have plotly charts. How do you actually show what project you have done either in college or in work or in a hackathon to somebody outside? You need to deploy it somewhere, right? So currently, how it works is you either show it in a Jupyter notebook, or you can probably go and use Kaggle, and you can run through each of your cell and show what you do, or you can what happens in the industry is you build a complete web development. You bring in those technologies. You develop a front end using HTML, CSS, Flash, JavaScript. So there's a lot of web development knowledge which is required. Although it is definitely more robust when you deploy your machine learning models or anything through these, but it does take a considerable amount of time and more complex. So you also have Dash, which will help you to show your plotly graphs. But is there a way where I can just use Python? So as data scientists, as machine learning engineers, we are experts in Python. Can I use Python to build a data app? Can I use only Python and show what HTML and CSS is doing? Right? This is, I think, the idea which the founders wanted to, or this is the challenge which I think the founders wanted to solve. And then last year we had something called Streamlit, which is purely building data apps using Python. So with that, so the whole next part of the talk is going to be just a brief introduction about Streamlit, how you can get started with Streamlit, and what are the functionalities which Streamlit offers. And I can just show you a brief, like a web app built by me, where you can see how convenient it is to interact and share insights. Right. So like I said, Streamlit is basically, it lets data scientists create their own applications. It is completely in Python, so you do not need to learn any other language. And it's similar to your Python script. It takes a top-to-down approach, and it runs your, and it creates a web applications. So there are a lot of widgets which we will be discussing in the future, like you can add text, you can add markdown, you can add buttons, radio buttons. So it's very visually appealing to give it to your shareholder and present your project. And it's also compatible with majority of the machine learning, deep learning libraries and frameworks which are currently present. So there shouldn't be any issue integrating your ML application. And what happens is every time there is a change, you make a source code, it automatically reloads and shows it in your browser. So you can get simultaneously, you can see how your code, how you're able to visualize it and see it. So if you want to get started, you can just pip install it using Streamlit, and there is already a demo for if you want to have a look how that is done. So you can just do Streamlit hello. But if you're building your own Python script and integrating your own models in that, so all you need to do after you write your script is do Streamlit run filename.py, right? So here's just a small video. This is taken from the Streamlit site where it shows how the Python code on the left and how it actually shows visualizes on the right. So you can use it for your hyperparameter tuning. You can see how your model predicts all with a click of a button, right? So what you saw there in the video is what I'm going to be explaining to you step by step, widget by widget. So the first one is Streamlit text. So similarly, like the way you have HTML, you have your headers, you have H1, H2 tags. Same way in Streamlit, you have 2 or 3 major functions, which is st.title, st.write, st.markdown. So one major big advantage is Streamlit also supports all functionalities of Markdown. So what you see here, all you need to do is give your title. You can use title, you can use write wherever you want to add some some statements. And what you see is that it takes a top-down approach, right? So that's why the title gets printed first, then the write, and then the markdown statement. So next up, what we have is widgets. So this is something which will really help you when you want to, let's say, add epoch, or you want to add your learning rate, and you want to give the functionality and the this to the user. If you want to give them the option to change these parameters and see how your model is predicting, widgets are really helpful. So what you see here are 3 different types of widgets, which is like radio, which is radio buttons where you use gender, male, female. You have a multi-select option where we will have multiple options which you can select, like filters. And you also have a slider option. So all these are pre-built widgets which you can use, and all it requires is 1 line of code per widget, right? So next up is when you have sidebar widgets. So what happens, like I mentioned, you have a top-down approach, right? Streamlit, that's how it performs. So what if you need all your hyperparameters on the left side of your web app? For example, something like this, so that you can show your how your model behaves on the main screen. So for that, you have something which is called as a sidebar widget, which is pretty much the same, but all you need to do is add an st.sidebar and then your widget name. So it gives you a very neat, compact customization thing on the left where you can add all your options, and then you can see how your model behaves on the right. So next up, what you see is what we have something called as a placeholders and see your progress. So placeholders is what you saw here in this previous. There is already a default image which I have added. So this is just a simple project where it will recommend similar t-shirts. So based on the image which we have uploaded. So when you want to show recommendations, you can replace that placeholder. You can when you have multiple recommendations to do, you can run a machine learning model and replace the images or replace a particular thing. So that's what a placeholder does. And it's very easy to initialize it just using st.empty and then give the image. And you also have a button functionality. So let's say you want to invoke your ML model script. So you can have your st.button and you can invoke your machine learning model over here, and which is followed by a spinner. So you want to check your progress. If you want to see, okay, 10%, 20%, 30%, you can also add a few visually appealing tools like spinners. So Streamlit also supports what we have like charts. If you want to visualize, like I said, if you want to visualize your data, you have line charts, you have maps. So it can taken as a data frame, pandas data frame as an input, and then give you this output, right? So let me just show you what we saw right now, which is this. This is the live demo which we saw. So if you actually see, if I click on female, I can drag it down. I can say small if I want also a medium. So every time this happens, your site reloads. If I want to change, let's say the price, and then I say something like, I want to get recommendations. So this is the spinner widget which we just discussed, and these are the results which you can see it's recommending here. So what you see here is pretty much a Python script or a Jupyter notebook which we were working on. But imagine showing this to your client, or let's say you are participating in a hackathon and you want to present what you've built, and this is how you do that. So what you also have is there are multiple options here. You can clear your cache, you can rerun, you can screen record this whole application. So it provides a very convenient, easy way to display what you've been working on and display all your machine learning models. So there are also multiple options like file upload. Let's say I have to upload an image file and then I need to generate recommendations. So I can do that also, right? So let me just get back to the charts. So now that you saw the different widgets and now that you saw how it actually shows in my local host and how you can see it in the browser, let's bring it all together, right? So you have a run the script, you have a complete Python script which is runs line by line from a top to bottom. So that renders the browser which you just saw. And every time you make a change or anytime you add a new parameter or you change a parameter, the whole script runs again. So when I'm talking about the whole script runs again, you must be thinking then, what if I have a data set which is an enormous data set, or what if there are some functionalities which I don't need for it to get repeated again and again? So that will actually create a lag, right? That will make sure that will actually delay the time it takes to load your browser. So Streamlit has come up with this really amazing concept which is called caching. So what caching does is, like I said, you do it top to bottom. You have multiple functionalities. You have your ST title, you bring in a widget, you bring in your models. But like I said, there are some aspects of your entire Python script which don't change. The parameters don't change. The body doesn't change. You don't have to basically do anything. So why do we need to reload that again? So when you have such a situation, what you need to do is you can add a decorator which is here, which is st.cache. So what it does is it checks for four major things. It checks whether your input parameters, let's say A and B. So if your input parameters, have they changed? Has the value of the input parameters changed? And if there is any external variable which you have used, have you changed any of that in your new code? Or has your body of your function changed? Or let's say your function calls another function and you have made some changes in the second function. So has any of these dependencies in that particular function changed? So if the answer is, let's say no to all of these, then what it happens is it doesn't reload that. It stores it in the cache and it takes it from the cache. So this really helps in reducing the amount of time and basically the lag which takes especially when you are manipulating really large data sets, or when you're having expensive computation which takes a long time and you don't want it to repeat every time you make a hyperparameter change. So there are a lot more functionalities in caching. You also have advanced caching which you can explore, but this is something which really helps, especially since we are all data scientists and we all work with really large data sets. So some of the other functionalities which you can explore is grids, like I mentioned, file upload. If you have images which you want to upload, if you have CSV files which you want to upload, you can do all of that. And also the one more major part is this components. So I would definitely say that Streamlit is not as robust or as customizable like how you have HTML and CSS, because those are obviously web development frameworks which have much more functionalities. But if you want to invoke some HTML script into your Streamlit app, you can do that. So that functionality is enabled using components. So if you have something which, let's say if you have layouts, so currently at the moment, if you see the recommendations which came out, it came out one below the other. So currently there might not be a way where you can horizontally stack your recommendations or provide a grid layout kind of thing, like the way you have it in HTML and CSS. So those are the things you can get it directly. You can invoke or basically embed your HTML component, and you can bring in animations, you can do screencast. So these are all the things which you can explore. You can also bring in all latex functionalities, and make sure that your Streamlit web app, does justice to your ML model. So just to conclude, what really happens finally is you have a Python script, and whatever Python script you run, it converts it and shows it to you in a browser. And the major thing where it solves problem is, since it is all in Python, completely in Python, there is no dependency on a third person to develop the front end and make sure that you deploy it. It's completely open source, and you can build data apps within a few minutes. So where exactly can you use this is definitely when you have a hackathon and you have a time constraint of 24 hours, or if you have a 12-hour hackathon and you want to just, your major part is your ML model and your predictions or your deep learning model. So you can always use this to demonstrate your in your final pitch, your project. Or if you want to do any college projects, do it yourself projects at home, and you want to share your insights to people and basically send it to people. So instead of sharing your Jupyter notebook and sending them the link and making sure they run cell by cell, you can do something like this. Or if you have if you have to show it to your shareholders or your clients, at in between every stage, as in, this is the progress I've done, this is how my model behaves, this is how the model changes when I change my hyperparameter tuning. So if you have these use cases, and if you want to do this, then I would definitely suggest you to explore Streamlit. And with that, I hope you, for those who did not know about this, I hope this was a good introduction for you to explore. And you can definitely go through the docs, which are self-explanatory, and they will really help you to get started. Also, if you have any questions, you can always reach out to me either on LinkedIn or Twitter. I go by the username of Niharika with 3 A's. And you can also find the slide deck at my GitHub repository, which is Niharika Krishnan/talks. Thank you.
Thank you so much, Niharika. That was such an energetic talk, and it was equally insightful.
Thank you.
Thank
Thank you
you
for
so
having
much.
me.
Thank you for joining us. All right. So I love how the day is going. And next up, we have Tanmayee Narendra, a PhD student at the University of Tübingen, to speak on Beyond Correlation, a practical introduction to causality. Sorry guys, there has been a technical glitch. We're just there.
Two parts. The first part, I hope to motivate the need for causality and what kind of questions that we can answer through this theory. And towards the end, I have a short sort of practical example in Python where perhaps you can formulate questions for the kind of data sets that you work with and use these causal methods to answer questions that is more relevant for you. And before I forget, if you have any questions, reach out to me on Twitter because I'm not sure how well we can answer it, answer questions through YouTube. Okay, and let's get started. So we've always heard this line, right? Correlation does not imply causation. And I think this comic shows it really well. It's from a webcomic called XKCD. And in this case, in the first panel, Cue Ball is telling Megan, I used to think correlation implied causation. Then I took a statistics class. Now I don't. And Megan says, sounds like the class helped. And Cue Ball replies, well, maybe. So you already see that, see the problem here, I hope. So he used to think something, then he took a class and he doesn't think that anymore. But how can you be sure that it's the class that made him change his mind? So this is the very well-known conundrum that correlation does not imply causation. But we're almost always tempted to draw this causal conclusion just from correlations. So I have a second example, and here Cue Ball is saying that another huge study found no evidence that cell phones cause cancer. What was the WHO thinking? And Black Hat says, I think they just got it backward. And he's so confused because if you see the graph, you see a spike of the total cancer incidence, and a few years later, the number of cell phone users increases. And I think Black Hat is trying to imply that cancer causes more cell phone usage. And Cue Ball is very confused. He says, you're not, there are so many problems with that. But Black Hat is just going to say, just to be safe, until I see more data, I'm going to assume cancer causes cell phones. So this is a common mistake that maybe we are tempted to make because just because something happened before an event that we are interested in, we are tempted to draw a conclusion that this is the cause of the effect, but that may not always be true. I hope these comics just kind of illustrate the challenges that we have in establishing causation. So now let's go on to a more concrete and maybe data-centric example. So it's taken from a textbook on causal inference. It's called Elements of Causal Inference, and it's freely available if you're interested to read it. So let's get right into the example. Suppose you have data about two genes, and in this case, you're measuring the activity of a gene, and you can measure this in several ways. Let's not get into the details. And on the y-axis, you are plotting a phenotype. So for those of you who are not familiar with what a phenotype is, you can think of it as some kind of observable characteristic of an organism. So for simplicity's sake, let's consider that we are measuring some gene in a plant, and we are plotting the plant height on the y-axis. So as you can see in both these graphs, they're quite similar. So if you wanted, for example, to predict the plant height given a certain activity of the gene, so say for gene A, you are interested to know what would be the plant height if the activity was 4. You could, I mean, this problem is fairly well studied in statistics. So you could fit, say, a linear model, and if you observe the activity of gene to be 4, the linear model would predict that you would have a phenotype of the value 10. and similarly for gene B. However, if you were interested in a slightly different question of what would happen if you deleted the gene A or gene B, and in genomics, this is commonly called a knockout. So in that case, you would remove the gene. And what would you do if that happens? So it's important to observe that this is a different question from just asking, what would I see if I observed activity of gene A? Here you're changing something in the underlying system, and technically you don't have data for the case when the gene is completely removed. So now you want to know what would happen. And in this case, what would happen would depend on the underlying mechanics of the system. So if, for example, let's assume for gene A, it directly affects the plant height. So in one way, there's a direct causal relationship from gene A to the plant height. So in that case, if you were to delete gene A, then probably you would observe the plant height to be in this range because there's a direct effect. However, if there is some kind of hidden variable that causes both the activity of gene B and the plant height, say something like soil moisture. So if you assume that there is a hidden variable called soil moisture, which affects both the plant height and the activity of a gene, if you were to delete this gene, there would be no effect on the plant height. I think it's fairly easy and kind of simple to see that when these kind of assumptions are made explicit in the form of a graph, but without making these assumptions explicit, it kind of becomes difficult to answer these questions. So I hope I've convinced you a little bit about that. And also another common thing is that a lot of people say we don't believe in causality, or causality is something just about philosophy and it can't be quantified. And even if you don't want to get into a philosophical discussion, the point I would like to make is that without assuming an underlying model such as this or this, if you wanted to answer a question that what would happen if you deleted a gene, with just observational data, it wouldn't be possible. So that's why a causal model can help you quantify these kind of questions. All right. So hopefully you are convinced about why there is a need for causality. And now let's move on to the ladder of causation. So this came recently from Judea Pearl, who is one of the developers of this theory, and it's also now called the Pearl's causal hierarchy, and it basically divides every question that you want answered from your data into 3 categories, and association, intervention, and counterfactuals. And I'll just go over the slide and explain the differences between these rungs of the ladder of causation. So at the lowest level, we have association, and it's the easiest question that we can answer with data. And the typical activity associated with this level is seeing or observing. And a typical question would be, how would seeing X change my belief in Y? And something like an example is, what does a symptom tell me about a disease? So Pearl would argue that most methods in statistics, even the most complicated of deep learning models, would fit in this first rung of the causal hierarchy, which is association. And however, if we want slightly different questions to be answered, we have to move on to the second layer, which is intervention. And in this second rung of the causal hierarchy, the activity that we involve is doing. So if you go back to the previous example with the genes, when we delete a gene in the genome, we are actively changing something in the system for which we don't necessarily have the data to predict from. And that is the difference between association and intervention. So a typical question in this would be, what if I do Y or do X, and there is this action of doing associated with this rung? And an example would be, what if I take aspirin? Will my headache be cured? So I think it's important to notice the difference. In this case, you already have a headache and you want to know if you take an aspirin, whether it will be cured or not. All right. Let's move on to the last and hardest level in the ladder of causation, which is the counterfactual. And this activity is typically associated with imagining or retrospection, where you are looking back at the past and thinking, if I had done something differently, would something have changed? And that is the kind of typical question that you would want answered. And an example would be, was it the aspirin that stopped my headache? So in this case, it's the case that you had a headache, you took an aspirin, and now you don't have a headache anymore. And you want to know whether it was this aspirin that stopped the headache or was it something else. So there is a kind of retrospection involved in this kind of question, because it is physically impossible to go back in time and not take the pill and see whether you still have the headache or not. So it doesn't even make sense if I say it out loud like that. So maybe another more practical example would be that, suppose you are working for a marketing company and you just spent a lot of money on a marketing campaign and you did see some change in your sales, but you want to know how much of that change is because of your of this marketing campaign that you did. And practically speaking, you cannot go back in time and not do the marketing campaign and see what would happen, and then you could always take the difference to estimate this improvement or decrease, which is the effect of your marketing campaign. But it's not physically possible to go back in time and do this experiment. And there can also be a lot of legal questions that can be framed in this way. For example, if you had maybe a more serious disease and you took some kind of medicine, and you ended up with a very serious condition, but you want to know whether it was exactly the medicine that made you end up in this state or not. So this aspect of imagination or retrospection is what we call counterfactuals. Okay, so coming to the broad field of causality, there are mainly two big questions that two big problems in the field of causality. One of them is discovery, where there is data and we want to understand what are the causal relationships among the data. And the second part is inference, where we kind of already assume how the different variables interact with each other, and we just want to know the cause and the effect of it. So in this talk, I will not be focusing on the problem of discovery, because it's a really hard problem and it is an active research area. There's still a lot of open questions in that area. But instead, I will be focusing on inference, where you kind of already have a mental picture of your causal model, and you want to estimate, say, a causal effect or a treatment effect on whatever variable that you are interested in. Also, maybe now is the right time to mention that there are several formulations of causality. So on one hand, you have causal Bayesian networks, and which is very similar to the typical Bayesian networks that we see in or graphical models. And on the other hand, there is another formulation called the structural equation model or the structural causal model. And both of them are sort of equivalent, but because of the interest of time, I won't be getting into this. But if you are interested, I have some posts on my blog where you can read up, and there's a lot of, I've also posted a lot of reading resources if you are interested in knowing more about this stuff. Okay, so coming back, now I just want to give you an overview of what are the components that constitute a causal inference engine. So for example, you wanted to answer this. Let's take the previous question, that how much effect of my marketing campaign did it have on my sales. So if you wanted to answer that kind of question, what are the building blocks that you need to do that? So I will be sharing this image from the book of Why. So let's get started. So in the beginning, you have to you have knowledge about how this works, and you have to encode it in and you have, which leads to some assumptions about this whole system. And using that, you would have to construct a causal model, and this causal model is usually encoded in the form of a graph, and usually it is directed and acyclic, and that is, acyclicity is usually needed so that the math works out fine. And you would typically draw edges from cause to effect, and that is how you would encode your assumptions. Once this graph has already been formulated, this would imply some testable implications that you can test using the data that you have. And once you have all this, the next question to ask is, can your query be answered with this causal model? Because in a lot of times, sometimes it can't be answered. Maybe you don't have data for this particular variable that you think affects your outcome, or maybe the graph is not well specified enough. So it's important to check whether this query can be answered, and if it can't be answered, you will have to go and change your assumptions so that it can be. And this entire layer depends on the query or the question that you want to answer. And lastly, we have the data. So once, if the question that you thought of before can be answered, using the testable implications, you can estimate, you can form something called the estimand. And what an estimand is mostly like a mathematical formula that you can use to use your data to answer the question that you want to be answered. And that's exactly what you would do. So once you have data, you can use some kind of statistical estimation to use the estimand and estimate the answer to your query. And of course, if you think that this estimate agrees with what you already know, you could feed that back into your knowledge, and this kind of loop continues. Okay, so maybe this has been too much theory, and you might be thinking to yourself, this is all too much talk in the air. I want to see real code. So let's get into a tutorial. I'll be using the Python library called DoWhy. It was developed by Microsoft, and it kind of embodies these building blocks that I just spoke about in this causal inference engine. And I hope it's clearer to you about how this whole process would work after you see some code. So let's just get into it. All right, let's get into it. So this is an example that I adapted from DoWhy's official documentation, and I highly encourage you to go ahead and change the code and adapt it to your own data and your own use case. As you'll see in the next few minutes, it's quite straightforward to use the library itself. And in this example, we'll be using the data set from the Infant Health and Development Program, which collected data on premature infants in the US in the 80s. So the question that they wanted to answer is that if you give medical treatment to a baby that was prematurely born, how much does it affect its chance of survival? So that is the question that they were trying to answer. And it's important to keep this question at the back of the mind, because the rest of the analysis is based on this question. Okay, so let's get into it. In this first cell, I'm just importing the library. It's called DoWhy, and the causal model class, and just also importing pandas so that we can read the data, and NumPy. Okay, so let's read in the data here. I'm reading it from this from an online resource, and also naming the columns here. And there are 25 other confounding variables that's present in this data set, which I'm naming here. And then I'm setting the names of the columns. I'm encoding the treatment to be a Boolean variable so that it's either true or false, because you're encoding whether the premature baby gets treatment or not as a true or false variable. And then I'm dropping these three columns, Y counterfactual, MU0 and MU1. And this is because it's not relevant for the example that I'll be showing you now. So this data set comes from a paper that the authors wrote, and they also computed additional things like the counterfactual and mean of some other two variables. But let's not get into it now because it's not relevant for what we're going to do. So I just dropped it. So this is how the data looks like. We have the treatment variable, which is Boolean, the outcome variable, which is whether the chance of the baby surviving or not. And then we have 25 other confounding variables. So maybe I didn't clarify what a confounder is. So a confounder is a hidden common cause. So like we saw in the presentation with the gene B, where there was this variable called soil moisture, which affected both the plant height and the activity of gene B. So in this case, we have 25 such hidden common causes. Okay. Now the next step is to construct the causal model. If you remember the sort of flow chart that I showed you, this is also the next step in that flow chart. So in this step, it's basically to encode whatever knowledge that you already know about the process into the graph. So in this case, since we don't know exactly what these variables mean, we're just going to assume they're confounders. However, if you already know a little more detailed kind of knowledge about how the variables interact, you could also encode it and pass it as a variable to the causal model so that you can include this knowledge in your analysis. So in that case, you would have to construct a graph object and pass it here. But in this case, we're not doing that. And I guess this would be useful in some cases where you know that there is no direct causal effect, but the effect of one variable only passes through another or things like that. So you can encode all that in a directed acyclic graph and pass it as an object. So let's see. And here we see it's a little bit not so pretty to look at, but basically there are two arrows going from every confounder to the treatment and the outcome variable Y. I guess it's not very easy to see it, but if you want, you could inspect the object and check for yourself. Okay, and the next step is to identify the causal effect. And identification is the mathematical, if you remember from the previous graph that I showed, is the step where we find the mathematical formula to answer the question that we're interested in. It doesn't use the data. It just checks if we can find a formula from the assumptions that we made so that we can answer the question we want to answer. So in this case, it's a nice thing about DoWhy that it asks you whether you want to continue by ignoring any unobserved confounders. So this is another question. So in a lot of times, there are so many variables that perhaps you have not included in your analysis. By explicitly asking you whether you want to continue by ignoring them, it just makes you aware of this assumption that you make. So I'm going to say yes here. And in this case, it uses the non-parametric average treatment effect, and it's called the backdoor. And if you can see here, you have the mathematical formula. So it's the expectation of this conditional probability here. So I won't be going into too much of the details. And this second part about the estimate 2 and it says no such variable found, we don't have to check that one, because estimate 2 is for finding if for finding the whether some variable is a cause or not, but we are not doing that because we already inputted the causal graph. So IV stands for instrumental variable. For just lack of time, I will not be going into what it means. For just this example, we can ignore estimate 2. So if you remember, the next step is to use this mathematical formula and the data that we have to get a metric, an estimate of what is the effect of the treatment on the outcome. So if you recall, what now we are going to check is if a baby after premature birth is given treatment, what is the causal effect of that treatment on the chance of survival of the premature baby. So this is the code that helps you do that, and it's a very simple function. You just have to call estimate effect, and you have to pass the estimate, and there are several methods that you can use to estimate the effect, and the choice of the method usually depends on the kind of data that you have. And here I'm just printing the causal estimate, and I also print the average treatment effect just to compare it with the estimate. So in this case, like you can see, it does a lot. It prints a lot of information. So since we're using linear regression, it gives you the statistics of the ordinary least squares regression results, and you have lots of information there: statistics, the AIC, the BIC, and then we have the identified estimate, and then the estimate. So the mean value is 3.9 with a p-value of 1.58 to the power 10 power minus 156. So I guess it's quite significant. And the average treatment effect is 4.02, which is quite close to the causal estimate that we estimated. So just for this for information, so in this case we used backdoor linear regression, but that's not the only method that we have. And some other methods that you could possibly use are propensity score matching, propensity score stratification, propensity score inverse weighting, linear regression, which we used, instrumental variables, and regression discontinuity. So these are the different methods you can use, and it kind of depends on the data set that you have and the nature of the causal model to see which one works the best. All right. So the last step of the whole procedure is refuting. So I guess you, as data scientists, you always know that you can always get some kind of answer from any kind of model, but especially in the case of causal inference, how can we know that this is a true causal value and it's not just some garbage that some estimator just threw back at you? So how do you check for the correctness or the validity of a causal estimate? And in several cases, of course, the best case scenario would be that you actually do this, and then you could check what happens. But in a lot of cases, it's impractical to exactly conduct this experiment, or maybe it's even unethical. So for example, if you wanted to find out the effect of whether smoking causes lung cancer, the best way would be that you find a group of people and you toss a coin, you decide whether they should smoke or not, you follow their lives for say 20 years and you see whether they get lung cancer or not. But just saying it out loud, it's unethical, and it's no one is going to be able to do this experiment. So in cases where it's impractical, unethical, or just plain impossible to do these experiments, how, and even if you use these causal methods, how do you know whether an estimate is correct or not? And that's where you would use methods of refuting. So even in this case, there are in the do-while library, there are, I think, 3 or 4 methods for refuting. Here we'll be using the random common cause. So in this case, you should just attach a random variable as a common cause to both the treatment and the effect and see how it changes the results. So let's see what happens. And it runs the regression again. And as you can see, after adding a random common cause, the estimated effect is 3.93, and the new effect is also 3.93. So it's very, very close. So it probably is an indication that the causal effect that you estimated previously is a good estimate. So just for information's sake, I just want to show you that there is more than one way to refute in do why. So you have the method that we used was the random common cause, but there's also several other methods where you add an unobserved common cause or a placebo treatment refuter, or you only use a subset of the data set. So for more information, I encourage you to look at the documentation of the do-while library. So that's it for the tutorial. As you can see, there's only 4 steps. It's quite simple to understand, but it's powerful because it gives you a way to quantify causal effects and make your assumptions about the data explicit. Okay, let's go back to the slides. So we are done with this. And so that's it for my talk. And before I end, I want to end with this quote from one of Julia Pearl's papers. And it says, data alone are hardly a science, regardless how big they get and how skillfully they are manipulated. And I think it's a very important point of view to have, because in a lot of times people think that you can just keep throwing data at a particular question and eventually you will be able to answer it. But I think the point that Pearl is trying to make is that no matter how much data you put, sometimes a few questions will not be just be answered from just data. So you need to have a sort of you need to codify your assumptions. You need to have a model so that you can answer these questions. And I think it points back to the second and third rungs of the ladder of causation, where we have interventions and counterfactuals. And the point he's trying to say is that with just observational data, it's not possible to answer questions about interventions or observations if there is no model that is assumed, which is assumed to be the underlying process. Okay. So I would like to end with this. And thank you very much for your attention. If you have any questions, you can reach out to me on my Twitter. And if you are interested to know more about causality, and if you are interested to read up or just find out more, I do have a couple of blog posts on my website, which you can check out. So thank you, WiDS, for this opportunity, and thank you very much for your attention.
Thank you, Tanmayee. That was such a wonderful session. I loved it. And next up, we have Nikita Gandhi, Community Manager at Google Developers, to speak on community building. Hello, ma'am.
Hi, how are you?
I'm great. How are you?
I'm doing great. And I'm really excited to talk to all of you today. This is an amazing series of talks that's going on, and really excited and thankful to be a part of this session today. Okay,
Great.
so let's get started. I'm not here to talk about any technical stuff because I'm sure you have a lot of interesting talks going on around that. So this is just a small break from all the tech talks that are going. So today I'm going to talk to you about communities and the power of communities and how they are playing a role, an important role in this pandemic situation. So let's get started. Let me introduce myself. My name is Nikita. I work with the developer relations team at Google. Um, Before joining developer relations team, I was working with Google AI team building content around machine learning. I have been associated with communities since 2014, so more than 6 years with communities now, and I can completely acknowledge that communities have shaped me to a better professional. In case you'd like to be in touch with me, Twitter handle is shared. That's Nikita Gandhi, Nikita with a double K. And also sharing my Medium account where I usually write blogs around Flutter. So feel free to check out them as well in case you are interested in Flutter. Well, today I'm going to share a story about a community and how they have been driving change. So this is about 2020, a year where things have changed a lot. So let's acknowledge the fact that the way we communicate with each other, the way we are working now, the way we are talking to our friends, everything has changed all of a sudden. And this also created an impact with the communities. So those cool meetups with some pizza conversations or coffees are no more happening. It's all about events that are going on online, and things have changed a lot. But that was the thing that every GDG in India wanted to do a single Dev Fest. So, while every chapter was thinking about DevFest, there were two small cities which were like far from each other, but there were organizers who were like really good friends with each other. So, as these cities were like very far, and they had no opportunity to create a single offline event because of the current pandemic situation and because of the geographies, they were like far away from Bangalore, Delhi, Pune, so there was no common point where they could even do an offline event, even if it was a regular year. But one thing that was common amongst the communities was they were strong yet powerful. So what I mean with that is these communities were established a long ago. They had a really strong interest from the developers in their ecosystem to come together and learn new technologies, discuss about it, build some interesting solutions around that. So yeah, when these two communities were talking to each other hypothetically about doing a dev fest together, although they were like separated with geographies, one thing that they found in common was the interest from the developers who wanted to learn something new. These communities had interest from different product areas. So a particular community had strong interest in cloud and TensorFlow, while the other had interest in Flutter and Android. So given that the developers had a variety of interest, even if both the communities thought of doing an event together, there were like different interests coming in. So the organizers were thinking that they don't lie in the same geography, they don't have a common point where they can bring in collaboration. The developer interest in different product areas is also different. So while they were thinking of doing one single dev fest, there were different challenges that were coming in. But both of them had similar ambition that they wanted to help the developers in the country, because at this point of the year, a lot of people have lost jobs, a lot of them have lost hopes, a lot of them are struggling to learn new things because they are not comfortable with this online format, or they are not comfortable learning in this given situation where there is a lot of disturbance at home. So given all these factors, the organizers wanted to give a break to the monotonous life that has come in this pandemic situation. So the ambition of coming together to solve a single problem, that is helping developers, still remains the same. But what was the problem? So even if these two small communities thought of doing a combined event, they knew that the communities are small, so they were afraid, like how can they help the developers? Do they have enough of helping hands to do this event?
They were not sure if they would have enough of speakers coming to their events, given that there are so many online events going on. They were not sure how can they gather attendees at the same place at the same time, because again, there are so many events happening in parallel. So a lot of challenges while both the chapters were thinking about collaborating together. But one day, two organizers were like discussing over WhatsApp that they wanted to host a single dev fest. And what they were thinking is, what are the different ideas and ways to collaborate together to solve the problem of coming together, having amazing set of speakers, helping developers across different interests and different geographies. So this is a story of DevFest India, wherein the organizers, 50 GDG community organizers, have come together. They have built a strong organizing team for the bigger communities. So right from Bangalore, Pune, Ranchi, Hubli, Hyderabad, Delhi, Jalandhar, all of them have come together and have created a strong identity about DevFest. So with this, what the organizers thought was, why just two cities come together? Why not all of them come together to do a single event? So combining those efforts to make a larger momentum, to create a larger momentum, the organizers thought of coming together and hosting a single DevFest. So with this, there were again the same questions in mind, the problems that they were discussing. Where do they host the event? What kind of people are expected to be invited to the event? How many people will be joining the event? How do we cater those? So is it a small meet, Google Meet event with 250 people and they are like shortlisted attendees, or is it open for all? What kind of product areas they would like to target, because if the event just gets longer, the momentum will get lost. So what is the exact date when they can host the event? Because it's again a season of festivals, there are exams going on, developers are busy from Monday to Friday, so they just have weekends to cover the event. So there were like a lot of thoughts when this idea was just bought in. So as interesting the idea was to do one single dev fest for all over India, which could probably bring in thousands of developers together to learn code, there were a lot of challenges the organizers saw. And again, working with a large team, so there are like more than 200 organizers in India, and it's difficult to coordinate. So coordination really matters in this bigger team, because everybody needs to be subscribed to the communications that are being sent, that are being rolled. Everyone have their own expertise and thoughts and biases, individual biases. So in this, trust is the key. There is a single sense of ownership for each of the teams who are taking the ownership to execute different portions of the event, and everyone does their bit. So right from someone who's helping to build an amazing website while someone is contributing to the design, there are folks who are just spending their time to create a cheerful moment with the organizing team, so that folks who are working day in and night don't get bored or frustrated, because of course this is like a voluntary stuff. It takes a lot of efforts as well, and then everybody have priorities to take care of. So the most important thing that DevFest India is looking at is to make this event accessible to everyone, which means people sitting in small towns who are not able to attend DevFest till last year because the events were offline. Not everybody was able to travel. There were not enough of seats available in the auditorium. This time, the event will be accessible to everyone, given that they have internet connection. So sitting at home, everybody can be a part of this event. Everybody can attend the different initiatives and activities that are planned with DevFest India. So I'm so excited to share that DevFest India is happening on 16th, 17th, and 18th of October with a line of 24 amazing speakers from all across India. So far, 12,000 plus people have registered with DevFest India, and all of these talks are available on YouTube, which means you just need to turn on your internet, you just need to log on to YouTube, come to DevFest India YouTube channel, and learn with the help of experts on how to build apps from scratch, how to design different machine learning models, how to deploy your products on GCP, how to build an amazing website from scratch using Angular, PWA, how can Flutter be used for cross-platform development and stuff like that. So there are 5 amazing tracks with 24 plus amazing speakers, a few panel discussions, amazing set of icebreaker activities that are planned, and all of this is going to happen on YouTube. And I stress on this point. So this is an event which is inclusive of all. There are experts who are chiming in their expertise to build some amazing content that can help developers enhance their profiles, their portfolios. This event is inclusive of both men and women who can sit at their home in a safe space and attend the event. This event is inclusive of organizers who are doing their DevFest for the first time, as well as organizers who have been doing DevFest every year. This DevFest is inclusive of organizers with having equal ratio of men and women who are helping to make this event better. So yeah, this is a big momentum, and this is going to be a different kind of experience for all the developers in the ecosystem of GDG communities. In case you haven't heard about this before, I highly encourage you to go to devfestindia.com and register yourselves. While there is this is a snapshot of the social media team that I frequently interact with and I enjoy working with the most. Sharing an example on how they are like remotely located, they hardly have met each other, but they have amazing conversations day and night. But that doesn't stop them from working at their workplace. That doesn't stop them from contributing. So they know how to make an amazing balance of everything. What's more important over here is everybody have their own expertise. So there is Karthik, who's a DSC lead, and he's built a Twitter bot. There is Eamon, who's helping with the designs. We have Varsha, Vrij, Priyal, who are helping with some amazing website designs. We have Arshia, Taiba, Harsh, Mansi, who are helping with the social media aspect of things. We have Pranay, who's cheering up the team with some amazing memes and fun part to it. So this event is just not about a couple of organizers who are making it happen, but there are a lot more folks who are still not in the picture but are contributing, and you too can be a part of this organizing team. And how can you help is basically I encourage all of you to join the momentum where thousands of developers are coming together to learn code. Imagine at the same time thousands of people are going to build Android apps together, deploy their models on TensorFlow and GCP. Thousands of developers are going to build websites from scratch. Thousands of developers are going to try Flutter for web for the first time. So this is going to be an amazing momentum for the developers around the country. And you can contribute to this by doing your bit. That is, go to devfestindia.com, register, share, and join this event, and share it with your friends, relatives, your colleagues, and everywhere in your network that's possible to share. And let's make India proud with the efforts of all the GDG organizers who have planned to help the developers in India, especially at this point of time. Let's try to add some hope to lives of people who have felt terrible this year, and we all can join this mega effort. With this, thank you so much for listening. I tried keeping it really short and simple. In case you'd like to know more about me or you would like to stay in touch with me after the event, my Twitter handle is Nikita Gandhi, and my Medium blog is Nikita Gandhi again, the same thing. Thanks so much.
Thank you, Nikita. That was such a wonderful session. And being a part of the WITS community, I could totally relate to all that you spoke about, bonding with the people that we never met personally and yet being able to pull off everything really well. So thank you so much. This was so inspiring. And moving ahead, we now have Mamta Jha, a co-founder of Tech Scalable, to speak on orchestrating machine learning pipelines with Kubernetes.
Hello and welcome to this session. Hope you people are enjoying the various buffet sessions for the entire day. So in this session, we would be discussing about Azure Machine Learning and Azure Kubernetes Service. We would be using Azure ML Designer, and we would be deploying our model in Azure Kubernetes Service. So let's first start with understanding what is Azure ML. Azure ML is a cloud-based service for creating and managing machine learning solutions. It's designed to help data scientists and ML engineers to leverage their existing data processing and model development knowledge, skills, and framework. So it helps them to scale, distribute, deploy their workload on the cloud. So we would be first creating an Azure ML workspace. So let's understand what exactly is a workspace. Workspace is a logical container for all Azure ML assets. Like I can have compute, it can have storage, it can have data stored in it can have various scripts, notebooks, I can conduct various experiments, I can create several pipelines and models as well. So it helps us segregate all the things into a single box, and that is called as a workspace. You can think that as a logical container to hold all the assets together. So now we would be using Azure ML Designer to develop our entire pipeline. So ML Designer lets us visually connect data sets along with modules in an interactive canvas. So we can create our ML models on that canvas and we can visualize it in that canvas itself. So we can design using various stuffs, like we can do drag and drop of data sets and modules onto the canvas, and we can connect various modules to create a pipeline. And as and when you're making changes, the pipeline is getting saved as a draft. And finally, when you're happy with your entire pipeline, you can go ahead and submit that pipeline for a run execution. When you're running the pipeline, it would be using the compute resources within the workspace, whichever is created, and it will go ahead and execute our pipeline. So we are converting our training pipelines to inferences pipeline. We can even publish our pipelines to a REST pipeline endpoint so that we can submit new pipelines that run from various parameters and data sets as well. So there are various ways to deploy, like we would be using AKS as our compute resource, wherein we would be deploying our inference pipeline. So let's first understand what exactly is a pipeline. When we see these boxes like the flow charts which are showing up in the screen, the pipeline actually consists of the data sets, the various type of analytical modules, like we can have a regression module or we can have any other module for cleansing the data, and we would be connecting them to each other. And these pipeline can be used for various purposes. Like I can make a pipeline to train a single model or maybe to train multiple models. I can create a pipeline to make predictions in real time, or I can make a pipeline only to cleanse the data as well. So it's my choice what all tasks I want to do within the pipeline. I can pick and choose such items or such modules in my pipeline and create the entire flow. And finally, when I'm happy with the entire draft, I can go ahead and submit that for the execution. So we would be doing a run for the pipeline, the configuration of the pipeline, and the results that would get saved in the workspace where the pipeline runs. We can always go back and we can inspect, or we want to troubleshoot, or we want to do any audit. We can do with the different various runs which we have conducted on that pipeline. If you want to clone the pipeline, you can go ahead and clone a new pipeline from that pipeline as well. So it gives us various advantages. And here, if you look, the data set is an important part, no doubt in it. Without data, ML and AI doesn't make sense. So machine learning data sets becomes very easy to access. We would be storing it in the cloud, and we can access it here in the models altogether. So we would be using these data sets in the designer, and we can use them in various experiments. We would include them in the designer and we would be using them. And we would be using various modules. Module is nothing but that algorithm which would help us perform the task on our data, right? What we want to do. Like I want to train my data, I want to score my data, I want to evaluate or validate my entire process. All those stuffs can be done by various modules. So modules are small algorithms which are specified to do a certain task. Like I can cleanse my data using the clean data module. So we can modify the parameters and all that, and we can say what exactly is being expected in the output. Suppose I want to split my data into 70% for the train and the test. So I can go ahead and do that. I want to remove all the columns which are having null values or which are not having the proper values. I can go ahead and remove those columns as well. So these modules help us attain a certain task. And once we have done that, and I want to deploy my model, or I want to try out my pipeline, what I would do, I would need some compute resources. Normally what we do that in our local machine itself. Rather than that, we can have compute resources inside our Azure workspace, the ML workspace, which we create in the beginning, and we can run pipelines and we can host our deployed models in real time as well. And we can publish them for accessing from the outside as well. So here we would be using various compute targets, like we can use virtual machines, we can use Azure Container Instance, we can use Azure Kubernetes Service. Various type of deployment models can be used for deploying our ML models here. We would be using AKS as our backend. We would be doing a real-time endpoint deployment into our AKS cluster. So let's understand how exactly we do that. First, we would be starting with training our regression model. We would create a new pipeline. We would import the data. We would prepare the data. We would cleanse it so that we have good data. And then we would pick up the model which we want to train. And we would be scoring that model as well so that we can evaluate our machine learning model, how well it is performing. That would be the first task, which would be the training of the regression model. And once we have trained our model, we will go ahead and deploy our model. We would be creating an inference cluster in Azure Kubernetes Service, and we would be deploying it as a real-time endpoint. And later, if we wish, we can even go and test that real-time endpoint. So let's go to the portal.azure.com and start with our workspace creation. So we would first start with a subscription. We should have a valid subscription. if we have a valid subscription, on the search bar, we can type machine learning. And the first option we can select, that is the Azure Machine Learning Service. Let's click on that. And it would route us to this particular portal page. We would click on Add and create a new workspace. I will create a new resource group. Resource group is for grouping all the linked resources in Azure. So I'm just creating a resource group for my all ML services. I have named it as ML-demo. I will name the workspace. So let me name it as workspace. Let me write it 2 because I think I have already my workspace created. I'll go to the next. I'll create a public endpoint for this particular workspace. And I go to the advanced section. I live with Microsoft Managed Keys. I'll hit on review and create. And this will take a while for validating. Yes, validation has passed. I'll hit on create. And workspace creation will take a while. So it has validated all the parameters. Now I'm going and hitting on the create option. So this will take a while. It is submitting the deployment request. All the parameters which we have given, dependent on that, it will create a resource group. It will create a workspace in the specified region. So this would take a while. If we don't have a workspace, we can't go ahead with a ML designer. That's the first prerequisite so that we can go ahead and create our pipeline. So pipeline will help us organize various multiple machine learning and data processing steps into a single resource. Workspace is created. Let's click on launch now. And this would take us to the Azure Machine Learning page altogether, which is ml.azure.com. It's taking a while to get populated. On the left-hand side, if you see, there is an author section in which you have notebooks, you have automated ML and designer. We are more focused on the designer way of doing. And here on the first option, you see easy to build and easy to use pre-built models. I'll be checking on that. And on the left-hand side, we get some 94 assets. There are pre-created modules which can be used. On the right-hand side, we have the target where we plan to deploy our, not deploy, rather, we want to run our pipeline. So I'm giving the name as ML Demo 1, and I'm clicking it on save. This will take a while to get created. It is creating a virtual machine of that particular configuration. Let's click on save and let it create at the backend. Let's start with our pipeline creation. And once we have started with the pipeline creation, first we would look for the data. I'm picking up a sample data, automobile price data, in which various parameters are mentioned, and we are asked to predict the value of the automobile. That data set I'm picking. This is my sample data set. Let's visualize that. And you can see there are a lot of data associated to the automobile. You have the make, the fuel type, the number of doors, body style, drive fields. You have n number of stuffs related to which the data's, the automobile's price can be predicted. If you look into the parameters, there are n number of parameters, 205 rows and 26 columns in total. So this is the entire data set. Let me close this quickly. And let's move on to the second module in which we would be preparing our data. So we would be using data transformation section in this. We can use the search bar on the top and search for select columns in data set. So using this, we would be selecting few columns in the data set, and we would be doing a set of action on that. Let me quickly place this here, and I can connect the above data set as an input to this particular module. On the right-hand side, you see the edit column button. Let's click on that. And let's say include what all? Let's say include all the columns in it. Plus, I want to exclude something. And what would that be? I want to exclude the normalized losses because I saw there are a lot of null values in that. So I have selected the normalized losses column name from here. Say save. And this is the first module which we have used. Now I want to cleanse my data. Before to that, let me put a comment over here stating that I have excluded the normalized losses. I have excluded that particular column. So let me quickly write that. Cool. Later, if I come to the pipeline, at least I get the complete information about it. So I'll pick up the next module and I'll go to the search bar and I'll write, I want to clean the data which we have, the entire data set. And we have some missing values, what we have after the normalized losses column. Still, we have some missing values. So we would use this missing data module and we'll try to clean our data. We will go ahead and connect the inputs. Before to that, let me quickly go ahead and edit the column. In the edit column section, I'm saying include all the, I can specify all columns. And here I can click on save. What I would do, I would go ahead and here I need to remove the entire row under the cleaning mode. I want to do that. So here in the cleaning modes option, I can go ahead and select in the drop down and I'll say remove entire row for the missing values. Let me select that. I'll write the comment and I'll say I have removed the missing values rows over here. Let me quickly type that. And I'll be connecting the input of the clean missing data from the set column in data set. Let me quickly go and look for the next module we would use. We would like to split the data into two parts. And we can define a percentage over here, like I want to split 70-30 or I want to split 50-50 for the train and the test data set. I would quickly first connect the input from the cleaning missing data to the split data. And here I can write the percentage as 0.7 so that I'm taking up 70-30 percentage. 70% of the data is for training and 30% data is for testing. The 70% data set would be accessible from the left port. That's the reason I've kept that. And on the right-hand side, I would have the 30% data. So I've put a comment as well. Let's quickly pick a machine learning algorithm using which I want to train my model. So I'll be choosing a regression algorithm, which is linear regression. I'll drag and drop that to the canvas and picking up the train module over here. And I'll be connecting the split data to the train model and putting the 70% of data to the train model and applying the algorithm to it. And I can go ahead and select the edit column. In that, I'll give the column name, which would be used for the labeling. So my label column would be the price. I expect to predict the price of the automobile. Now I have the training model. Let's go ahead and have the score model and the evaluate model as well. So I have dragged the score model over here. And I would use the train model's output, plus I would use the 30% of data which we have kept for testing, and we would provide that as well to the input of the score model. So with this, we have the split data module as the right input port for the score model. Now let me pull in the evaluate model so that we would be able to evaluate our model, how well our model has scored on the data set. And the input from the score model would be going to the evaluate model. So this is how my entire pipeline is looking like. Time to time, it gets saved as well. Autosave is on. You can even go ahead, you want to zoom in, you want to see the ratio, reset the zoom, or you want to auto layout it. It will auto layout that entire pipeline for us. So let me quickly select the submit button, and here I'll select the target. The compute target is already deployed, so I'm selecting that and I have executed. So let me click on submit again and give the name of the experiment. I would create a new experiment over here. Each run is like an experiment over here. I'm creating it as name experiment 1. The compute target on which this experiment will run is ML demo 1. I'm clicking on submit, and this experiment will take some time for the execution. It may take up to 20 minutes of the time to run the entire pipeline. And it depends on the size of the machine as well. But we have taken a medium-sized machine, so it would be taking around 20 minutes for the execution. Here you can look into the overview about the run as well. And there are some pipeline parameters. We have not supplied any parameters. You see here, now this particular task has got queued. So here it is selecting the columns in the data set. Whatever task we have mentioned in each of the module, that would get executed. We will have to wait a while for the entire pipeline to finish. So what I would do, I have already created this pipeline and executed one in one of my other workspaces. So let me take you there. Till the time this is running in the backend, I'll take you to the pipeline, which is already executed. So this is the other workspace on which my pipeline is already executed. We can go and view the score labels over here. I'm visualizing the score module. And here you can see the predicted prices and the actual prices for the testing data. And from this, you can judge how good is my model's prediction over here. And we can also visualize the evaluate model. So let me close this and show you the visualization of the evaluate model. Here you will get following statistics like mean absolute error you have root mean squared error, you have relative absolute error, you have coefficient of determination. All these values are there. Smaller the better, the error statistics. And these smaller values would indicate that the prediction is as closer as the actual value. So we always look for the coefficient of determination to be very close to 1. And that's the better prediction. So this is about the training of the model. Let's see how do we deploy this model in our AKS cluster. So we will go ahead and create a real-time inference pipeline out of this. On the right-hand side, we can see create inference pipeline. And here in the second option, it has that real-time inference pipeline creation. So when we create a real-time inference pipeline, what would happen to this pipeline which we have generated is the trained model which was there, that would get saved as a data set, and it would be available in the My Data Sets. And the train model which we have, plus the split data modules, those training modules are removed entirely. And we can have the web service input and web service output model added to these. So let me go ahead and hit on this. It will take a while to execute this and convert this to a inference pipeline. So I have done that over here and kept it. Once that execution is done, you should have this web service input and web service output modules added. These help us show where the data can be entered by the users, to the pipeline and where the data is returned from. And if you see, we have removed the strain and the split and all that stuff. We just have the data set and we have the model evaluation modules, the score modules, and few other stuffs. So once this inference pipeline is created, we can go ahead and click on submit. Once we click on submit, it will ask us to choose a compute where we want to execute this. So we can use the same compute target we have used to run our training experiment, which we did. So I can go ahead and say create a new experiment, and I can give experiment say 10, and I would choose the default one. This is the default compute target which I had used for training. I'm using the same one, and I'll click on submit. So it would execute this. It will take around 20 minutes and the entire pipeline will finish running. Once this running is completed, then only we can go ahead and deploy our model in our cluster. So meanwhile, we can get our AKS cluster ready as well. So for that, we can go ahead and click on the compute tab over here. In this compute section, you would see there are multiple options. You can deploy using compute instances. You can deploy using compute cluster. And the third one is inference cluster. This is the one. If you have any existing AKS cluster, that would get listed over here. We don't have any AKS cluster. So let's go ahead and create an AKS cluster. So I'll hit on create. It is asking me for the compute name. Let me give it as AKS ML compute. And here I have to give the region where I want to deploy. Let me take Central US. It will automatically load the size of the virtual machine. 4 virtual cores and 14 GB RAM is the size of the machine. I'm choosing the cluster purpose as production. You can also choose it as dev test. And here you can see there is a 3-node cluster which is there. So as soon as I hit on create, I'm living with normal network settings and all that. I'm not enabling the SSL configuration and all that, keeping it pretty simple. And I can just hit on create. This cluster creation will take around 10 to 15 minutes because it has to entirely bring up the AKS cluster from scratch. In Azure Kubernetes service, even though we don't manage the master nodes, we just manage the worker nodes, still then it will bring up a high available master node as well. There would be multiple master nodes, minimum 3 for the high availability. And once this is ready, we can go ahead and hit on deploy. So I've already created a AKS cluster and kept. If I show you in the other workspace, I already have a AKS cluster. Let me go to my other workspace. I should have a AKS cluster here. This is the AKS cluster, which is already up and running. I want to deploy my inference pipeline, which I have created the real-time endpoint to this AKS cluster. Let me quickly take that real-time endpoint 1 and let me hit on deploy. If I click on deploy, it will go ahead and deploy a real-time endpoint. It is saying me that do I want to deploy a newer real-time endpoint? I want to replace an existing real-time endpoint. So when we do several runs that time, you can go ahead and replace that. But first time we are doing, so I'm living with this. I'm not changing on the endpoint name. If you want to give any descriptions, you can give that. Here you can choose on which AKS cluster you want to deploy. And we can go ahead and deploy this. On choosing the deployment of this, what would happen? It will go ahead and deploy this on our AKS cluster. I have already deployed this. So let me just not click on deploy. Let me click on cancel, but you would go ahead and deploy. Once it is deployed, you can find that as an endpoint listed over here. And here you see there is a deployment getting listed. We would go ahead and click on this deployment, and we can even run tests using this real-time endpoint. So real-time endpoint provides us this test option. it provides us the consume option. It gives us the REST endpoint using which we can consume this particular model. We are more interested to test this model. These are the parameters, input parameters supplied. And if I hit on test, it will go ahead and submit this to the portal. It will submit this to the REST endpoint, what we have created. And on the right-hand side, you can see the results. This is the scored label. This is the expected price of that particular one. And this is the prediction which it has done using that model. And if you see over here, here it says web service input, and here it says web service output. So when we generated the inference endpoints, that time we got these two modules added. And using these two modules, you can go ahead and test, or you can go ahead and consume your real-time endpoint which you have deployed. So this is the way we go ahead and deploy our ML model which we have created using the designer in our AKS cluster. If I'm very much interested to see that using my cloud console, I can go ahead and do that as well. I should have the AKS cluster listed over here. If you go to here and click on Kubernetes services, it should list you the Kubernetes services over here. This is the cluster which it has created. And in this cluster, it has deployed that model. So I can go ahead and list the nodes in the cluster using kubectl get nodes command. Before to that, I'll have to get the Kubernetes cluster configuration file so that I can interact with that cluster. And that can happen with this command. I can fetch the credentials of my AKS cluster belonging to this resource group having this specific name. As soon as you execute this command, it copies the configuration file to my home directory. And with this, it understands to which cluster I want to execute or send my commands to. kubectl or kubelet is a command line interface to interact to the Kubernetes cluster. And if I say get nodes, it will list the nodes which are existing in the cluster. We had created a 3-node cluster. So let's see that. Yes, there is a 3-node cluster. In managed Kubernetes services, it always lists only the worker nodes. We don't see the master nodes here because it's a managed Kubernetes, which is Azure Kubernetes service. If you want to list all the resources or you want to list the pods which are created for our machine learning model, you can go ahead and create that. You have some front end, you have back end, you have some block storage installer. A lot of things got created over here when we deployed our model to our cluster. If you want to get a more descriptive view about all of the resources as well, you can go ahead and execute this command called as kubectl get all. And using this command, you can list the pods, you can list the service, you can list if any daemon sets are running, any deployments are running, whatever what we created. We have created a highly scalable, highly healable type of environment for our ML model when we have deployed. That is the reason we have create kind deployment. This gives us a high availability or high scalability, self-healability for our ML model. So if you see, I'm running 3 replicas from my front end and 1 replica for my backend of my Azure model over here. And these are the pods with respect to that deployment, the front end and the back end. And then I'm running some daemon set type of application, which can help me use the storage options which are present, the blob storage. And for them, I have some daemon sets running so that in each node in the cluster, I have them as a storage daemon up and running. Same way, I have some volume monitor pods running, which is created as a daemon set. And this is the entire set which gets deployed for my inference endpoint. I can go ahead and test my inference endpoint using this deployment. You can go ahead and click on that deployment and I can test that. I showed you how to test it. So we can try out these things. And this is how we use our Azure ML designer and we go ahead and deploy our inference pipeline, which is a real-time pipeline into our AKS cluster. So that was all about how do we work with machine learning models in cloud, in our cloud-based environment, which was our Azure ML. So Azure is providing a lot of services which like simplifies our life. Like you saw a designer, it's like a no-code type of ML model designing method. I didn't have to write a single line of code, but yes, I need to know what I'm doing inside that model, or else I can't drag and drop those modules. So knowledge is needed, skills are needed, but yes, the life is simplified with a drag and drop option. And to create a highly available, highly scalable type of cluster, we have used our Azure Kubernetes service. We have integrated both the services and we have made them work together. So that's all from my side. Hope you people enjoyed the session, and thanks for providing me the opportunity to speak in such an amazing platform.
Thank you, ma'am. Such a wonderful session it was. And now we have Ranjani Mani, who is an analytics leader at VMware, to speak on how analytics and data science teams can balance innovation along with driving value to business. Lessons from Pixar.
Hello, everyone. Hope you guys are doing well in these unprecedented times. Thank you for joining in. I am happy to be here today as part of the Women in Data Science Mysore to talk about this very relevant topic. This is a problem that you would have come across multiple times in the past if you are in the analytics space. Why do a majority of AI projects fail? Based on both personal learnings as well as research in the space, I have narrowed it down to 4 specific areas, and I hope to give you pointers that you can take away back to your organizations or to yourselves as individuals, irrespective of whether you are a data science practitioner or a leader in the space. I am Ranjani. I lead a global advanced analytics and data sciences team whose charter is to drive measurable business value with data across business analytics and data sciences, especially in the customer experience space. And my interests primarily lie in how you can enable decision-making with analytics, strategy, leadership, and I'm highly passionate about bringing in more women into STEM, especially in the analytics space. So without much further ado, let's maybe get started. So first of all, who is this for, right? And what will you take away at the end of these 20 minutes? If you are an individual contributor working in the space or looking at breaking into data sciences, you can learn what is the type of role you can play and how you can position yourself to become a linchpin. You'll also learn what it takes to drive value with AI beyond model building. If you happen to be a leader managing analysts and data scientists, we'll look at what you need to enable for your AI talent to drive success and most important questions that leaders in this space face. How do you balance innovation while keeping the team motivated along with driving and delivering business value? So moving on, this slide, I think, speaks for itself, right? Gartner recently predicted that around 80% of analytics insights will not deliver business outcomes. Just think about that number, right? That's a huge number, especially for a sector which is touted as the sexiest job in the 21st century by HBR. And this is not like a singular metric, right? There are many more such metrics that reiterate this narrative. There was this fabulous report published by BCG along with MIT's Lewin School of Management on winning with AI. It talks about the conundrum which companies face around the hype that surrounds the field, right? Like you can see here, 9 out of 10 respondents agree that AI represents a huge business opportunity for the company. But only 7 out of 10 companies reported any impact from AI based on the investments done so far. Now, why is this the case, right? where is there the perception, as Gartner puts it, that AI is thought of as this alchemy, which is run by wizards, and there's a lack of this actual value being delivered. So there's this case study which I've kind of listed out here, and it's a solid example of the gap which exists between business and data science, right? And you might be surprised to see how common this is than you could imagine, especially if you're working on NLP problems, right? So I do have links for all of this research in the reference section in case you're interested. Now, getting back to this case study, right? It talks about this company. They opted for this recommender system for use by its customer service representatives. And the idea was to use this recommender to suggest solutions to common customer issues, right? And this project was touted to be this huge cost saver for the company as such, because you're kind of recommending, kind of cutting down on the number of tickets, and it would probably also help in terms of the time taken for resolution, right? But then after a few months, the company realized that the agents weren't even using it, right? And then it took them another few months to figure out why. This actual case study, right? They then realized that it wasn't necessarily a problem with the ML algorithm, rather the data on which the models were trained. So it was trained on an ideal set of techniques.
The viewers to hold on for like 5 minutes due to network issues. There has been an issue, so we'll be setting it right in a while.
I'm sorry for the uninterrupted pause. There is some technical issue. We are looking into it. Please stay tuned.
And there's a lack of this actual value being delivered. So there's this case study which I've kind of listed out here, and it's a solid example of the gap which exists between business and data science, right? And you might be surprised to see how common this this is than you could imagine, especially if you're working on NLP problems, right? So I do have links for all of this research in the reference section in case you're interested. Now, getting back to this case study, right? It talks about this company. They opted for this recommender system for use by its customer service representatives. And the idea was to use this recommender to suggest solutions to common customer issues, right? And this project was touted to be this huge cost saver for the company as such, because you're kind of recommending, kind of cutting down on the number of tickets, and it would probably also help in terms of the time taken for resolution, right? But then after a few months, the company realized that the agents weren't even using it, right? And then it took them another few months to figure out why. This actual case study, right? They then realized that it wasn't necessarily a problem with the ML algorithm, rather the data on which the models were trained. So it was trained on an ideal set of technical descriptions versus what the customer actually entered, right? Describing the problem. So apart from this, they also realized that there was a lot of overlapping categories in the data, which wasn't really taken into consideration when they were training the model. So this kind of highlights a very critical point, right? That most data scientists seem to miss. How you can use design thinking and think from the perspective of the user when developing these models, right? And not miss out in the business context. So why are we doing what are we doing, right? That kind of provides a good segue to the next slide here. So let's talk about the 4 reasons I called out earlier around why AI projects fail. We'll also delve into each of these in more detail, right? So let's start with these different areas. To quote this very famous title, start with why, right? So that's a strategy pillar. So is the AI strategy driven from the business problem, or is AI an afterthought? The second one is talent, right? How do you hire? Whom do you hire? If you're, are you actually in the business of baking? Should you be hiring a baker or the one who makes an oven, right? And the third one, also very critical, is leadership. And I cannot stress on the significance of this enough, right? Are you a leader who enables your AI talent to succeed? That's very critical, right? And finally, lessons from Pixar on what they call the ugly baby and the beast, right? And I'll talk a bit more about this when we get to that section. But the key point over here is how do you need to balance? Why do you need to balance rather innovation with driving business value? Okay, with that high-level overview, let's consider each in more detail. Strategy, right? Now, this can be a deal breaker in deciding the success of your projects. So BCG recently called out a research that highlighted the need to integrate the AI strategy with business strategy. Are you starting with the business problem? And the fact that AI cannot exist in vacuum without business context, something which we just saw in the case study that we reviewed earlier. Related to that quest is the second point, right? Is the question around when does AI come into the picture? In the case of a product where you eventually anticipate that the data which will be generated is going to be used for analytics, are we ensuring that this is the product in itself is capturing and processing and rendering the data to drive the ML capabilities? Or if you're helping drive decisions with ML, is this driven top down as a priority from the leadership? Or is it just like, let's try it out as a good to have? There's this quote which I remember reading, let's build it and they will come. This is so outdated right now that no longer works, right? The third point related to this again is the fact that AI is a team sport, right? And you guys who have worked in this space will absolutely agree. To succeed, we need to build collaboratively, right? It doesn't take only data scientists to come up with a solution. people across teams like product management, engineering, technical teams, data science teams, all of them need to come together to work on the solution. As BCG highlighted in the report I spoke about earlier, AI is less about technology and more about business transformation. For example, if you're building a recommender that ideally needs to be integrated into, say, Salesforce, right? Now, that requires a process change. It's not just the ML algorithms that need to be successful. Finally, this is the step which I think is so underrated. How will this information be consumed, right? Now, the consumption of AI is given relatively lesser importance compared to the production. Now, which probably explains why 87% of the models never even make it to production, right? Have you considered who are the users? How will they adopt this? Is this going to be exposed as an API, a visual, an application? How will this be used, right? And most importantly, what is your success outcome, right? Successful outcome. For example, when you're having some edge case prediction problems, right? It's very, very important to understand and align on what you visualize as the outcome versus what the business visualizes, right? And also, again, because ML in itself is an iterative process, what is good enough for it to be useful to the business, beyond which the ROI of the effort reduces. So focus on the fact that is my understanding of the outcome as a data scientist, same as what the business's understanding is, right? Now, I have this post, it's a snap from LinkedIn. It's a very relatable thing, right? This space in itself is such a dynamically changing environment, and it requires you to be comfortable with ambiguity. It is easy to get into a constantly changing scope or a scope creep if you are not diligent, right? As a team in itself. And finally, the need to temper our expectations or align our expectations on what out-of-box solutions can, or more importantly, cannot do, all right? Okay, so with that, moving on, this is one of my favorite parts. How do you set up a high-performance team? So Pixar's founder, Ed Catmull, was once asked this question, apparently, right? Is it important to have great people or great ideas? Think about that and pick a choice, pick an option, right? So what he says is, if you give a good idea to a mediocre team, they will screw it up, yeah? But if you give a mediocre idea to a brilliant team, that they will either fix it or throw it away and come up with something better, yeah? So the key, therefore, is to hire a team that delivers. All right, so that is the higher rights, right? If you're a builder, you should understand that people don't care what kind of hammer or nails or tools or wood that you use. They just want a well-constructed house that's an outcome, right? Similarly, in the analytics space, for business stakeholders, the focus is on results it delivers, whether you used R or Python, it doesn't matter, right? So I believe in hiring for attitude and training for skills. Again, second point here, hire diverse, right? And this is so relevant, especially in data sciences. Data scientist in itself is such an overloaded term. There are different types of roles that make a team, a data scientist and analytics team, right? Across data engineers, business analysts, data scientists, etc. So I have a snippet here, which kind of shows like the different core skills and the different roles which is required, right? So are you hiring a complementary skill set team? And most importantly, do you have a data translator who can do the storytelling? And like this quote calls out, humans are storytelling animals. It's just not important to call out the insights, right? It's pretty much useless if we cannot convince the leaders of to act upon the insights. So storytelling is absolutely important. There was this article earlier in HBR around how data sciences requires persuasion. So do hire storytellers as well. And finally, hire smart. This is not just in data sciences, right? This is just good leadership practice. Mediocrity is over, right? You cannot be average and succeed and excel rather as a group. So one thing I feel very strongly about is how little people tend to use a job description for. Most of these are very generic, right? If you look at JDs. And if you're a hiring manager, it would help to spend time to be more specific on what you actually need the profile to support. This actually would help you because it will weed out the profiles that are very irrelevant, right? And like I said, mediocrity in this space will definitely deem your team irrelevant as well. So ensure that you hire folks smarter than yourself, right? That's the only way to increase the average intellectual capital of the team. I want to call out this anecdote I came across recently. This is by this person called Cassie, who is the chief decision intelligence engineer at Google. He uses this analogy, right? He says, imagine hiring a chef to build you an oven or an electrical engineer to bake bread for you. So when it comes to machine learning, that's the kind of mistake that I see businesses make over and over. So if you're opening a bakery, right, it's great to hire an experienced baker who's well-versed in the nuances of making a delicious bread, right? You also want an oven, right? So while that's a critical tool, you won't charge your top pastry chef with the task of knowing how to build an oven, right? So why is the company focused on the same thing in the equivalent of machine learning? So identify, right? Are you in the business of making bread or making ovens? So while the tool and technology is important, you also need to make sure that you're actually delivering value with those tools, right? You're in the business of baking bread. All right, with that, let's move on to the next topic, right? Leadership. This again is a very critical one. Are you as a leader enabling your AI talent to drive value? And what does it even mean to say enabling, right? I'm going to start with the one which most of you guys, again, might relate with, data and more data. Data is a double-edged sword, right? It's a prerequisite for us to build out analytics capabilities. But if you kind of see across enterprises, this is a very highly siloed entity. There are multiple owners, multiple formats. It's present at different places. It has different privacy options. There's a lot of GDPR compliance. And there's no way of ever being able to join one with another sometimes, right? I once came across this post of how a customer location, I think it was Philadelphia, it was spelled out in like hundreds of different ways, right? And it's not even funny for the analyst who's actually pulling out this information. So before we embark on this fancy new AI project, can we take a step back to consider the data question? Is the data collected, cleaned, and accessible in a consistent and reliable manner? That is so critical, right? And related to the first point, how do we enable a robust and reliable environment? Do we have access to compute? Are there data engineering capabilities required for building, say, reusable pipelines? Is there infrastructure available across the end-to-end value chain, from data capture to how you're disseminating the results? Also, are we building reusable intelligence, right? For example, my team works on a lot of NLP problems, which requires a ton of pre-processing, right? Imagine having to start all of this from scratch. So one thing we try to do is, can this be standardized and streamlined so that we don't have to start from state zero each time? And the third point is to reiterate that ML is not magic. Yeah, if you throw in garbage, it's going to give you garbage as the output. We have at times tried out Western-class NLP algorithms, right? But we have still struggled with interpreting the outcome into something which is useful for the business because we didn't integrate the business context, right? The key, therefore, is to keep it simple. Yeah, and set clear expectations on what can and cannot be accomplished with the data available. So one of the biggest opportunities for us all today especially if you're a leader, is to figure out how we can educate the business leaders across the organization. Finally, and I cannot stress the significance of this enough, being able to communicate to the business stakeholders. So having the leadership support to help connect the dots and drive decisions from the insights is crucial, right? Around the topic which we just discussed, I have this very funny tweet which I came across, which a lot of you guys may relate to. Clean data is close to a myth, right? And this shows how pristine data doesn't directly exist. Data prep is still a majority of time taken by the data scientists. Something a lot of you guys, again, may relate to. Now, the final section of our presentation today, and one of my favorite analogies, which again applies across industries, the story of the ugly baby and the beast. You guys must have heard about this company Pixar, right? We all know its very famous founder, Steve Jobs, but we might not have heard of the co-founder. His name is Ed Catmull, and he authored this really brilliant book on how Pixar fosters creativity. It's called Creativity Inc., in case you would like to pick it up. So among the different recommendations and frameworks he proposes on how one can overcome this unseen forces that stand in the way of true inspiration is the story of the ugly baby and the beast, right? Tying back to why it's relevant to the topic here, this kind of reiterates the need to balance between driving value and innovation. So he says, right, early on, all of our movies suck. Pixar films are not good at first. So therefore, they're like ugly babies. And our job is to make them so, make them better, right? And to go from suck to not suck. So he describes how companies often don't spend enough time nurturing and improving an initial idea, which doesn't probably look fascinating, or it's probably not delivering value immediately. But you ought to do that, right? Because there's this pressure to feed the hungry beast all the time. And that's our reality, that new ideas are very fragile. They don't look good. They take protection. They need protection. And you cannot judge them at that point. You can maybe see how well the team is working together, but you cannot judge the ideas per se. So we have to go from that stage to somehow engaging with the beast. And this is a long process, right? But the normal thing that happens is that people screw up the front end. And of course, he talks about how you cannot protect the baby forever. And at some point in time, it has to grow up and change into something. Because, if you were to leave it, the ugly baby would rather play in the sandbox forever. Now, I think this is a great analogy to the work which we do, especially in the analytics space. There's this constant need to innovate, right? And you need to innovate and you need to be creative. And because there's a lot of learnings in this process. And if you're leading a team of data scientists, it is a huge motivator for people looking to learn and try out new algorithms. So that is also what makes us better over time, right? But then they need to be cognizant of the fact that innovative ideas are like ugly babies and they need people to champion and protect them. In the meantime, though, one ought to feed the beast, right? That is the one which drives business value. All right, with that, I'll probably wrap up this session today. And I once again thank WiDS for this fabulous opportunity. I hope this has been helpful to you guys. Feel free to reach out to me on either my website, ranjanimoney.com, or on my LinkedIn page. I'm going to close here with this brilliant quote. Yeah. This is from this author called Michio Kaku. He is he's a futurist. He's written a bunch of books in this space, and I highly recommend picking it up if you haven't read him. He talks about in this book, How Science Will Shape Human Destiny and Our Daily Lives by year 2100. He talks about how by 2100, our destiny is to become like gods we once worshipped and feared, but our tools will not be magic wands and potions, but the science of computers, nanotechnology, artificial intelligence, biotechnology, and most of all, quantum theory. Yeah. I think it's a fascinating time to, and a dangerous time to be alive. I hope this has been helpful to you guys. Thank you. Take care, all of you guys. Talk to you soon. Bye.
Thank you so much, ma'am. It was indeed very informative. I hope everyone is having a good time. Last week, I told everyone to stay tuned for our event lineup for this weekend. I do not my requests. Next one, we have Miss Neelam Batra. She is staff engineer at VMware. She'll be telling us she'll demystify neural networks for us. Neural networks is basically very complicated. As an ML enthusiast, we fear neural networks, but I hope this video will help you going at it.
Hello everyone, myself Neelam, and today I'll be talking on neural network. So I'll start this session with a brief intro about me, then some use cases of neural network, then what is neural network, then different components of neural network, how neural network works, and different types of neural network. So let me start with a brief intro. So I'm working as a staff engineer in VMware. Prior to VMware, I've worked with TeleMC and Sasken Communications. I'm an alumni of MN and IIT, Allahabad. I have recently completed PhD in Machine Learning and Artificial Intelligence from IIITB. I'm an active member of Women Who Code, and I have presented multiple papers in GHCI, Corathons, MLP, and radio. You can reach me at batra.neelam@gmail.com, or you can message me in my LinkedIn. Okay, so with this, let's start with the use cases of neural network. So we have seen some voice assistants, the facial recognition applications, the customer support queries, some chatbots, email filtering, some fraud detection application. So these all applications, if you see, are using neural networks in their backend. So as we know that neural networks is progressing, the applications of neural networks are also increasing. So with this, let's start with some basics, that what is artificial intelligence, what is machine learning, and what is neural network. So artificial intelligence is basically a term which is used for machines that interpret the data and learn from it. So then machine learning is a branch of artificial intelligence that focuses on training the machines. And again, then neural network comes inside. It's again a subset of machine learning where we use multiple layers to train the machines. So with this, in the diagram, you can see clearly that the neural network is the subset of machine learning, and it sits inside the machine learning and artificial intelligence. So now let's see what is the difference between the traditional programming and machine learning. So if you see the traditional programming, what we do is we create a program and then we input some data and it gives you some results. But in case of machine learning, it's different. So in machine learning, we have the data, so which is nothing but some examples, or we usually call them the training data. We have the expected output, that what we are expecting out of that. And then we create a model, or we create a program which will be trained, right? So in this case, the output is not the results, but the model itself or the program itself. So this model is later used to for prediction or for image classification, for other things will be used. Now let's say what is neural network. Okay, so then from the name itself, you can see that neural network is originated from a neuroscience. Right? So neuroscience is nothing but the study of brain. So if you see a brain, it's very complicated and it has billions of neurons which are interconnected and makes trillions of connections. And it's very complicated and very intelligent. If you see some number which is written inverted, or which is written in slant way, still you will be able to identify this is this number. The same thing scientists are trying to replicate, where they want the machines to learn the same kind of program. I mean, they want to program the machines in such a way they also identify the same thing, or they work similar to the brain. Okay, so let's understand what is a biological neuron. One neuron consists of. So if you see the neuron, there are three main components of neuron. First is a dendrite, which collects the input to the neuron. Then there's a cell body, which processes the information and gives the output. And then there's a third component, axon, which senses or that connects this output to the dendrites of other neurons. Okay, so with this, let's go to the artificial neuron. It's because scientists are trying to replicate the same brain cells. So that's why it is called the artificial neuron. So in this case also, we have the same three things. We have the input, we have cell, the main component where the processing happens, which is this triangular box, and then we have the output. So the all information is processed in the triangular space. So if we see that there's input A1, A2, A3, A4, and there's some weights associated with this inputs, which tells you that what is the strength or what is the importance of this input. So, and the input to this cell or this triangular part is a weighted sum of these inputs. So it becomes A1W1 plus A2W2 plus A3W3 and so on. Now this weighted input is passed through activation function. Based on this activation function is decided whether this information will be passed to the next neuron or not. Or in other words, we can say that whether this neuron will activate or not. So we will see that there are different types of activation functions that I'll cover later. And based on that, every activation function has their own criteria that in which case this neuron will be activated. So now we understand that what is one neuron. So let's go to the neural network. So neural network is nothing but it's a collection of large number of these neurons or artificial neurons. Okay, so in this diagram, you can see that the neurons are collectively put as a layer. So neural network is nothing but it is a combination of multiple layers of neurons. So the first layer is called input layer, and the last layer is called output layer, and the middle layers are called hidden layer. So if you see the input layer, this input layer gets the input picks the input signals and passes that to the next layer. The output layer is the one which delivers the final result. And the hidden layers are the ones which does all the calculations and feature extraction. So these neurons are connected, all are interconnected. It's from one layer to the other layer. You can see all neurons are connected to each other. So there are multiple, or there are a lot of connections between them. And these, as we discussed earlier also, these connections again have weights. So based on the weights, the input is passed to the other layer. And based on that function output, it is decided whether this information will be passed to the next layer or not. Okay. So let's see, we just discovered the different types of activation functions. So first is the sigmoid function. This is when we predict the probability. So as in when we pass some pictures or some images to a neural network, so it will not tell you that this picture is a cat. What it gives is the probability of this picture being a cat. So then we use the sigmoid function. The other function is the threshold function. The threshold function doesn't care about the variation or uncertainty in the middle. It just tells you that if the output is greater than 0, then it is 1, and if it is less than 0, then it is 0. So the third activation function, which is mostly used nowadays, is the ReLU function, rectified linear unit function. So in this case also, output lies between 0 and 1. If it is less than 0, then it is 0. And if it is greater than 0, then it is the same value. It is being used most frequently because it's the simplest one. So now the fourth one, we have the hyperbolic tangent function. This is similar to the sigmoid function. The only difference being the output lies between -1 to 1 instead of lying between 0 and 1. Okay, so let's see now we understand basic components and the layers. So let's see that how neural network works with a simple example where I have taken an example of an image of number being passed to the neural network, and we are trying to predict that which number it is. So as I told you earlier, that the first layer is the input layer and the last layer is called the output layer. The number of neurons in the input layer is equivalent to the features or the data points which you're passing. So as in this case, because we are passing a number or image of 28 cross 28 pixels, the input layer will have 28 into 28 equal to 784, the 784 neurons. So each neuron will have a grayscale value. So grayscale, because I've taken a gray image here, black and white image. So it will have only the grayscale number. If it is a colored image, again, it will have the RGB values. So it will be different. So 3 channels will be there. So in this case, we can see the grayscale means if it is 1, the value is 1, it is the brightest or it is the whitest. Or if it is a 0, then it is a black spot. If something is the grayish kind of thing, or it lies between, or other values can lie between 0 and 1. So these values are passed to the input layer, and then again this input layer is connected to the hidden layers. These hidden layers have shown here in this example. We have seen that each hidden layer has 16 neurons. So this number of neurons again depends upon or hyperparameter, which while learning or while training the model, you can vary. So depending upon the accuracy, or if the accuracy is coming less, you can increase or decrease the number of neurons in the hidden layers. So each connection will have the weights associated with that, and the weighted input is passed to the next layer, and then there is an activation function which is applied on this on the weighted input, which decides whether the particular neuron will fire or will get activated or not. And if it is activated, then only the information is passed to the next layer. So next layer again will have the same connections and the weights, and depending upon it's again the output, or it will decide whether which neurons will be activated. So there's one more concept here, the bias. So as I told you, the activation function will tell you whether this will activate it or not. So why we need an activation function? So if you see this weighted input, means when we calculate in previous example A1W18 plus A2W2, this can lie between any range. So to limit this range, we pass it through the activation function so that it lies between 0 and 1 or -1 to 1, as we saw in the activation functions. Now, if we want to control that also, that not only if it is greater than 1, then it should be active, but I want it to get activated when it is greater than 10. Then we use bias. So we add or subtract a parameter or number there, which is called the bias. So then these are the hidden layers. So all the processing or the activation functions are applied here. Then the output layer will have the number of neurons equivalent to the output classes or output number we are expecting. Right? So in this case, because we are trying to identify a number, handwritten number. So the number can be 0, 1, 2, 3, 4 till 9. So there are 10 possible values. So that's why this output layer will have 10 neurons. Okay. So now why we have multi-layered structure, right? Well, means what we want to achieve using the hidden layers. So to explain this, we can see that 9 can be written as some circular section plus a vertical section. So I can divide 9 into 2 parts. Then 8 can be divided into 2 parts, 0 and means the circular section and the other circular section. 4 I can divide in 3 parts, a vertical, a horizontal, and then a vertical, a bigger one and smaller one. Now, if I go ahead and I can divide this other smaller sections. Now, if this concept I apply to the neural network, I can say the first hidden layer, what it will do is it will identify the smaller sections, the low level features. Then the next hidden layer will identify the high level features. So assume that in this example, we can see that the first hidden layer has identified the smaller sections of circular section or the horizontal or vertical section, and it has fired only the neurons which has the information about these sections. So information will be passed from only from those neurons which are fired, and this information goes to the next hidden layer. In next hidden layer, only those neurons will be fired which has the information about the circular section and the vertical section. And then the last layer comes where it will identify the number. The same thing is applied to the, is if I take one more example of an image, means where you're passing a cat image or a face, then in that case, what will happen is the first hidden layer will identify or will extract the low level features, which are edges or black spots. Then the next layer, hidden layer, will identify middle layer features, which are ears, eyes, nose. The next layer, if we add one more layer, then one more layer, the other layer can identify the high level features, which are the facial features. And finally, the output layer comes where it is identified which picture it is belong to. So there also it will give you the probability that 0, 1, 2, 3. So this number being a 9 is having a 0.5 probability, or this being, the number being 8 is 0.2 probability. Okay, so this based on, we take the highest probability, and this probability which we are getting, again it becomes the accuracy. So if your model is too accurate, or if you've trained your model very well, then the accuracy of, or the probability of getting 9 increases. So it may be 0.9 or 0.8. So depending on the your neural network architecture and the training part which you have done. Okay, so if we see, means we were talking about the connections between multiple layers, right? So we saw that all the layers, all the neurons in one layer are connected to the neurons in the other layer. So first, the input layer has 784 neurons. The second layer has 16. So it becomes 784 into 16 connections, plus then we have 16, and then third layer also has a 16 neurons. So plus 16 into 16, then plus 16 into 10 neuron in the output layer. So total, if you see the weights, we have 784 into 16 plus 16 into 16 plus 16 into 10. Plus each layer, we put some bias, right? So the first hidden layer will have 16 biases, and 16 neurons being in third layer, that will also have a 16 biases, and the output layer will have 10 biases. So the total bias will be 16 plus 16 plus 10. Usually we don't add the bias in the input layer. So the total number of parameters for this simple network becomes 13,002. So when we say that we are training our model, or the model is, the neural network is learning, it means we are trying to find out these many parameters, mean the right biases and the weights, which will give us the accuracy. So you can think about the complexity which on which this neural networks work. There's a simple example, and if we add more layers and more neurons, that how complicated or it becomes, or how the complexity increases, how the running time, the execution time increases. Okay, so now there's something called cost function. We have seen that that we give the input to the input layer, and then we get some output where the probability of that number is given. So now assume we have passed 3 as a input, and we got the some probability at the output, where the number being 3 has 0.7 probability, and number 2 has 0.12 probability. Some probabilities will be there. So now there's a difference between the expected output and the observed output, the output which we got. So if the cost function is nothing, we call it a loss function or error function also. So what we do is we calculate the difference between the expected output and the observed output. And we, in this case, we will have the mean square error. So we calculate the error function or error, and then we try to reduce that error so that the accuracy increases. So this is the cost, and that error is given back to the network. I'll show you that. So what happens is the error is given back to the network, and then it is called the back propagation. So if we see this network where we have inputted some information and we got the output, this is called the feed forward. And next, when when we are learning or when we are training the model, that time we have feeded the error to the network in backward then it becomes it is called a back propagation. So this one feed forward and the one back propagation is called one epoch. Epoch is again a hyperparameter, and which you can control, or which you can try increasing or decreasing. Okay, so with this, as we saw that the parameters of neural networks are weights and biases. When we say that we are training the neural network, we try to find the right set of weights and biases. There are some hyperparameters, the number of layers, number of neurons in input and hidden layers, then activation function, number of epochs, and many others. So these are the hyperparameters which we try with. Means we try increasing the number of layers and see that what happens to the accuracy. If we increase the number of neurons, how it impacts the accuracy. So that we calculate. And there are different types of neural networks. So one is a feed-forward neural network. This we saw that it's you give the input and one output is given. So there's a feed-forward, as we explained. Then there's a CNN, it's a convolution neural network. So in this case, we input the features in batches, and then we allow the network to remember the parts of the image. So this is mainly used for the facial recognition or the image processing. Then we have the RNN. So in cases where the sequence of the data matters, as you see the language translation or text to speech conversion or video. So in those cases, we use the RNN neural network. So with this, I'll come to the references. So these are the references we have put. And if you want to get more details on this, then you can go through these references. Okay, thank you. I hope I have given you some overview, and you can go in detail later and read more on this. Thanks again.
Thank you, ma'am. I hope neural networks will not be as intimidating as it used to be to the audience. Next up, we have Miss Harini. She'll be talking to us about her journey as WiDS ambassador. So, welcome, ma'am.
Hi everyone, I'm here to speak about my journey as WiDS ambassador. I'm thankful to WiDS Mysuru for this opportunity to share my experiences. As we all know, data science continues to revolutionize every industry. The need to play a strong role in building tomorrow's economy becomes evident, and this is irrespective of the gender. We see that the role of data science is evident in almost every aspect of life, be it entertainment, shopping, weather, logistics. And every domain generates data sources with the ability to turn them into knowledge, growing exponentially, knowledge for the betterment of economy and humanity, reflecting our future. That being said, that passionated me to learn more on AI and data science, and I discovered a wide opportunity and transformational impact on humanity, and also realized the potential of the opportunity of oneself. So, in the process of my passion drawing into potential sustainability of the knowledge, grew when I got associated myself with its community. I see that the community events had a lot of role models and inspirational women speakers who use their talent to impact lives of many, one being me. And speakers in the community are being extraordinary women leaders with subject matter expertise and achievers in their own fields. The annual technical conference provides an opportunity to hear the latest scientific researches and applications in a wide, broad area of domains. And this motivated me to support women to connect to this platform to lead them forward and make the best in their careers, and also to contribute to the communities and support other women. WITS basically aims to inspire and educate the data scientists worldwide and to support the women in this field. I am associated with WITS Bengaluru, and this opportunity is given to me by my organization, PayPal, where I represent from PayPal as WITS ambassador in collaboration with IAM. In the event of hosting with Bengaluru, we had series of events in this year where we had main conference and datathon hosted by IIM, and we had accomplished women data leads talking on various topics covering the healthcare, retail, finance, technology. And it was amazing to coordinate with each of those women leads when, as ambassadors, we are bringing in and signing them off to share the knowledge of their domains, which could help a lot of young data scientists to crave their paths forward for their careers, for their knowledge growth, and use those experiences of this event in their daily lives or at their workplaces. And the Datathon workshop, wherein the Datathon challenge was given by the main bits or on the realistic problems, we had various corporates participating as mentors and coaching them and supporting them, even though you came with no background of data science. We had a lot of participations here, and we ultimately had regional winners as well. In the event of this, we also had a pre-conference hosted at PayPal, partnering with WITS Bengaluru at PayPal campus. It was amazing to see so many people participating and visiting our campus in participation of this pre-conference event. And as our leaders at PayPal say, there's a human story behind every transaction. And PayPal combines data analytics and human story to protect customers. There we go. And let's apply technology for good and change the world. Women participation in data science will grow, and global communities like WITS are bringing this momentum closer every day. Wish you all the best, and thanks to WITS Mysuru.
Thank you, ma'am. It was indeed very inspiring, and I hope more and more women will step up and take up roles at organizations such as WITS or any other organization. Next, we have Miss Garima Bansal. Sorry, she's a data science enthusiast and a fresh graduate in bioinformatics. She did her MSc there. She'll tell us about personalized medicine. Welcome, ma'am.
Hello, good evening everyone. I hope you all are doing good. I am Garima Bansal. I have just completed my master's in bioinformatics from Jamia Millia Islamia, and I am looking for opportunities in data science. Before I start, I would like to thank the organizing members of WITS Mysuru for giving me this wonderful opportunity. Today, I will be talking about personalized medicine. I will explain in brief the background concepts, the need, and the successes achieved by it. So let us see why we need personalized medicine. We're all the same and yet very different. But when we get sick, we're likely to receive the same medical treatment. What we have is a one-size-fits-all approach to medicine that is based on broad population averages. This traditional practice often fails because different people could have the same disease due to different reasons. Of course, physicians tailor their prescriptions or treatment methods based on individual factors like gender, age, mobility levels, pre-existing conditions. But what is relatively new to their toolkit is the genetic data. Tailoring healthcare to each person's unique genetic makeup, that's the promising idea behind personalized medicine. Let us first see how successful the existing medicinal system is. As we can see, for each of these diseases, the standard drug treatment provides benefit to only a limited percentage of patients. Diabetes and asthma are such common problems and have been here for a very long time, and yet the treatment is effective only for 55 to 60% of people. And the numbers are even smaller for cancer and Alzheimer's. I think this makes it clear that we need another system of medicine which targets and benefits a larger number of people. Let us look at the concepts underlying personalized medicine. What are genes? Genes are nothing but a part of DNA which can perform an independent function. They are made up of 4 chemical bases or nucleotides, namely adenine, thymine, cytosine, and guanine. A group of genes form a chromosome, and 23 pairs of chromosome make up the entire DNA of humans, also known as the human genome. Now, some genes act as instructions to make proteins, while others have regulatory functions. Humans have a total of around 20 to 25,000 genes, and 99.9% of DNA is same for all humans. It is just that 0.1% of variation in our DNA that makes us all so different. The process of determining the nucleic acid sequence, that is the order in which these 4 bases occur in our DNA, is called genetic sequencing. The first method for determining a DNA sequence came in 1970, and at that time we could not sequence the whole genome at once. It took 13 long years to complete a human genome sequencing, and it was done as a part of Human Genome Project. Sequencing techniques have advanced majorly since then, and it is due to the low prices of high throughput techniques like next generation sequencing that personalized medicine is now becoming a reality, and it is not just an idea anymore. Next generation sequencing is now routinely used to identify genetic mutations that drive specific cancers and biomarkers that predict disease risk or how well a person will respond to a drug or treatment method. And with the ever-growing genetic data of diverse patient groups available to us, we can draw comparisons between healthy and diseased individuals' DNA using analytics, and we can utilize these to diagnose and treat others in future. Researchers have barely begun to scratch the surface of what revolutionary insights are likely to be hidden in the human genetic code. And we can already see the growth in number of personalized drugs approved by FDA from 5% in 2005 to 42% in 2018. This number could grow even faster in coming future. Now, this way of diagnostics is more effective as by identifying the factors that predispose a person to a particular disease. We can tailor the treatment and prevention strategies for each individual. What we currently have is a reactive approach in diagnostics and healthcare, but with advancements in these technologies, we could be looking towards a predictive and preventive approach. Let us now look at some of the examples where personalized medicine is already benefiting healthcare. Warfarin is an anticoagulant drug which has been used for more than 50 years now. It is also called as a blood thinner in layman language. Now, getting its dose right is an extremely important task because too much of it can lead to bleeding, and too less of it will not prevent those dangerous clots. And even though it has been used for such a long period of time, getting its dosage right is still a very challenging task, probably because it has such a high range of possible dosage. Factors such as weight, race, body surface area, age, and vitamin K intake collectively account only for 10 to 27% of the variability in how patients respond to the drug. Scientists determined that variations in two genes, CYP and VKORC1, account for roughly 45% of the variability in patient response to warfarin. Diagnostic tests for these gene variations were developed in around 2002. And using these tests and this knowledge, we can personalize the dosage of warfarin for each individual. And in this way, we could be preventing thousands of strokes and emergency room visits every year. A personalized medicine is also being used very commonly in very broadly in cancer research. For some cancers, diagnostic tests can help a doctor determine the aggressiveness of a tumor, and ultimately that helps to decide whether we're going to go forward with the surgery or use lesser invasive treatments. Now, in the case of prostate cancer, clinical studies have shown that there is a specific mutation in the gene that causes the tumor to take an aggressive form. So if a person having prostate cancer lacks that particular mutation, the cancer may remain stable within the gland for decades, and that rules out the need for radical surgeries, radiation, and chemotherapy. Without gene tests, it would have been difficult or rather impossible to detect such cases, and the patient would have to undergo otherwise avoidable chemotherapy. Another good example is non-small cell lung cancer. The standard first-line treatment for NSCLC is chemotherapy. FDA has approved Tarceva, a tyrosine kinase inhibitor drug, in 2004 as a second-line therapy for the disease. However, there is evidence that the TKIs are more effective than chemotherapy in treating these patients, in treating a subgroup of these patients who have a mutation in the gene known as EGFR. It has made scientists and doctors move from non-selective cytotoxic chemotherapy to personalized medicine. And now the core guidelines to treat non-small cell lung cancer are based on the identification of targetable driver mutations and immune checkpoints. Well, this brings us to the end of my session. Here, these are some references that I have used. You may go through them for more insights. Thanks a lot for attending my talk. I hope the session was informative, and feel free to connect with me on LinkedIn. Have a great day.
Thank you so much, ma'am. It was very informative. Next we have Miss Archana Rao. She is a freelance data science mentor and research consultant. She will be telling us about ML that helps us in preserving our privacy. So over to you, ma'am. There might be some lag. I do apologize for that. This is due to some network issues.
Hello everyone. I hope you all doing great, staying safe and healthy. I'm Archana. Well, first of all, I would like to thank and appreciate all the organizers and volunteers of its Mysuru for giving me this opportunity to present a talk at this event. And also, I would like to congratulate the whole community and all the speakers for your efforts in making the series of event grand success. Well, today's talk is about privacy preserving machine learning. Through this presentation, I hope to motivate you all to gain some insights about ethical AI and some of the data privacy policies, legal regulations, and techniques around private AI. And also, I would like to convey the protect privacy and promote AI innovation. Well, this is a bit about me. I'm a freelance data science mentor and research consultant, having a huge passion for applied AI researching and open source contributions. So yeah, feel free to reach out to me in case you're interested in AI research and up for some of the data science collaborations. You're always welcome. Well, as I did mention there, let's try to quickly gain some insights about scope and significance of PPML and gain some motivation. So let's see what data privacy is. Basically, data privacy is a branch of data security, which is a lot concerned with proper handling of data consent, notice, and regulatory obligations. In general, practical data privacy concerns often revolve around points like whether or how users' data is shared with third parties, from to an organizations through applications and all, and also how data is legally collected from the users and stored in an organizations, and also whether these companies or organizations are following up some of the regulatory restrictions such as GDPR, HIPAA, which is for health sector, and GLBA for finance sector, and the most recent one is CCPA called California Consumer Protection Act, which is for consumer data protection. Right. These are some data privacy laws that are available across the globe. Through this particular slide, I would like to stress upon the point there is, we as a data scientist got to take extreme care while working with one's personal and sensitive data, personal data revealing one's racial or ethnic origin and political opinion, some of the religious or philosophical beliefs, genetic data, biometric data, and there are a lot many. Right? As of now, over 80 countries and independent territories have now adopted comprehensive data protection laws, which is great. Well, we all know the AI consumes huge data, and the data is so much protected with so many data privacy policies, legal regulations, and all, which causing so much difficulties for data scientists while having access to huge databases and all in order to build ethical AI, which is bias free and fair enough. In fact, most of the researchers, professors, and authors also talking about topics around ethical AI, challenges by having access to huge databases, ensuring users' data is private and secure, and all. These are the two quotes said by MIT's professor of robotics, Rodney Brooks, and the Roth, co-author of book Ethical Algorithm. Even they show some concern about challenges that are involved while having access to huge databases and also have robust, fair enough, bias-free AI systems could be built if you have enough access to huge databases. Well, AI solutionism. This is something very much interesting and hot topic that everyone within the field and outside the field discussing about. There is this increasingly popular belief, right? Given enough data, ML algorithms can solve all of the humanity's problem. Also, in the other hand, there's this discussion happening that this is not something so easily possible due to ethical issues, data privacy policies, no access for sensitive data, and all, as we discussed. However, this challenge could be addressed by some of the technologies like differential privacy, and federated learning, which we'll be discussing through further slides. Well, I also just wanted to put up some of the points around data protection and AI strategy policies that are available in India. If we know that in December 2019, Indian government introduced this act called Personal Data Protection Bill, which is yet to come into actual force though. Also, we do have this AI strategy that is called Niti Aayog paper. Basically, this paper identifies some of the barriers and challenges that has to be addressed while building AI system. I've picked one among them, that is lack of regulations around privacy and security, which is a key point for our today's presentation as well. Well, this is one of the most recent initiatives from National Digital Health Mission, whereas they're trying to build a management mechanism in order to process huge digital health data and facilitate a seamless exchange in all and office and telemedicine services. I think there's a lot of scope for implementation of differential privacy and federated learning in order to make the system more secure and privacy compliant. And also, it has opened up a lot of opportunities for policymakers, AI researchers, developers to have some good collaborations. Well, here you go, differential privacy. We say that DP is for sensitive data, data curators, and adversaries as well. DP was introduced by researcher called Cynthia Dvock and her team from Microsoft Research. Basically, DP describes a promise, made by a data holder or curator, particularly to a data subject. The promise is something like this, a data holder making a promise to data subject saying that they'll be not affected adversarially or otherwise by allowing their data to be used in any study or analysis, no matter what other studies, data sets, and related information sources are available. And this way, DP enables us to quantify the level of privacy of a database as well. Well, the core technique of DP to protect individual privacy is to add noise in the data, right? Basically, these algorithms rely on incorporating random noise into the mix, so that everything an adversary receives becomes so much noisy and absolutely imprecise, right? And so it is much more difficult to breach privacy as well. They say that we have two identical databases, one with your information on it and another one without it, whereas DP ensures the probability that a statistical query, whenever you perform a query over database, it's conducted on the first database or the second one. Well, we have two main differential privacy methods. One is local differential privacy, and the one is global differential privacy. Whereas code technique, that is adding noise to a data, remains same. What differs is, in case of local DP, data is the noise. Basically, noise is added to each individual data point in the data set, either by a data set curator once the data set is formed, or by the data individuals itself before making the data available to curator. In case of global DP, the noise is added at the output of the query of the data set. Let's say you have performed the query over database and you have fetched the result output, and you add noise to the output. That way you ensure that your data is private. Researchers say the global DP can lead to more accurate results compared to local DP while keeping the same privacy level. Hence, global DP is something widely used across the field in most of the applications. Well, you can see this is the DP mechanism. If you can see, this is a table of a sensitive database of a credit ratings. Let's assume the task is for an adversary.
adversary wants to know the number of people who have bad credit rating, that is free from the stable, which is sensitive and personal, right? And we know that in order to avoid privacy breaching, we could use this technique DP, whereas technique is to add random noise to the ground truth. So we choose random number L, that is a noise from a zero-centered Laplacian distribution with some standard deviation. Whereas this algorithm called noisy counting will return the output, which is a combination of ground truth and noise added to it. Please don't feel panicked if you don't get this. You understand better as you explore. Well, we know that adding noise to data is something called DP, but what type of noise to add and how much to add is something could be inferred from this particular slide. Typically, there are two types of noises that can be used while implementing differential privacy. One is Gaussian, another one is Laplacian. You can see the a noise distribution from this figure. And also when it comes to how much noise to add to a data set, that's something could be analyzed with the help of this equation that I've put. You can see the A represents the randomized algorithm that takes dataset as an input, and dataset D1 and D2 differ by just one element. And if you can see this epsilon, this is a main parameter to determine the amount of noise that is necessary to add to a database. Right, by tuning this epsilon, we control the noisiness of our noisy counting as well. Hence, we call this as epsilon differential privacy. Well, this is one of the more challenging aspects of DP, that is a trade-off between privacy and accuracy. Well, it manifests in two basic ways. Please read through these points. Well, these are some of the applications of differential privacy, and we have given references to these. Please make sure that you go check it out. Well, this is the second technique that we were talking so far, federated learning, right? Basically, machine learning models which make use of a large amount of data that are traditionally trained using online servers, right? Companies like Google and Apple used to take a lot of user data and data records and activity of the users and all from their mobile devices, and then they store them in their cloud services to create a centralized machine learning model which was able to improve the performance of their mobile services, right? Whereas in case of FL, they train a centralized ML model on decentralized data. Basically, FL is the technique for training ML models on data to which we don't have absolute access. The data set we use to train a model is distributed among large number of resources. Well, we could also say the FL is for personalized experience. If you can see, there's something called local app optimization happens. Local optimization happens locally in your mobile devices, and also local update sharing happens. Hence, these steps are happening locally. In your mobile devices, you feel more personalized, way of using your phone or the technology. If you have ever wondered that your applications like WhatsApp and other chat services will have, if you using Gboard on your Android mobiles, you get some word recommendations and all that you have most often used, right? These are happening because of FL running under the hood. Well, basically, your phone participates in federated learning only when your phone is charging and has enough Wi-Fi connection, and it's not been used by a user,
and all. This way, the overall performance of the device is not affected, and also it won't negatively impact users' experience. As I did mention that Gboard on Android phones is one of the FL applications, and also there are some other applications like Gmail Smart Prediction, and also your Google search engine as FL in it, and also some of the recommender systems, the applications having a recommender system in it. Well, if in case my presentation excited you guys and you have this question in your mind that how to get started with private AI or privacy preserving machine learning, I've given some of the links to get started with it. Make sure that you go check it out. There's course from Udacity called Secure and Private AI, which is absolutely free. This introduces you to field of private and secure AI, and also it introduces you to community called Open Mind, which I'm part of. I'm contributing as a mentor and research assistant, which is the community is incredibly supportive, and also they have some of the learning initiatives for beginners in order to help them to get started with their private AI stuff. Well, these are some of the references that I've used. Make sure that you go read them and gain better insights. Well, thank you all beautiful people for listening off my presentation. Yeah, feel free to connect with me over LinkedIn, and in case you have any queries related to presentation and everything, I'm always available. Thank you so much.
Thank you, ma'am. It was indeed enlightening. I love how the day is going. And now we have Sukanya Mandal, Insights and Data at Capgemini, to speak on Towards UN 2030 SDG, how AI and IoT contributes.
Hello.
Hello, ma'am. Good afternoon.
Good afternoon. Hello, everyone. Thank you for joining my session. Yeah, is my screen visible? Presentation?
Yes, it's visible.
Okay. So the topic for my presentation is towards UN 2030 SDG, how AI and IoT contributes. To talk about this topic a little bit, UN stands for United Nations, and United Nations has come up with Sustainable Development Goals SDGs, 17 Sustainable Development Goals SDGs as a 2030 agenda. And my presentation would talk about the goals, where does it start from, and how basically AI and IoT projects are contributing currently and will continue to contribute. So the flow of the presentation would be, I'll start with Millennium Development Goals, and because built on Millennium Development Goals, SDG was built, and then from there I'll connect SDG to IoT, and then IoT and AI, how basically each of these work together, and then I'll show you a couple of open source projects currently available on GitHub that are contributing to the same. So let's begin. Starting with Millennium Development Goals. So what are Millennium Development Goals? So in back in 2000, leaders across 189 countries agreed on a vision for the new Millennium Development Goals. This was basically to eradicate hunger,
universal primary education, gender equality and empowerment of women, reduced child mortality, improved maternal health, eradications of HIV, AIDS, malaria, and other diseases, environmental sustainability, and global partnership for development. With these 8 goals, MDG started journey on, and they had a target of 15 years. So once this goal started, let's see what were the achievements after 15 years. So more than 1 billion people have were lifted out of poverty since 1990, and then child mortality also dropped by more than half since 1990. The number of out-of-school children has also dropped since 1990, and HIV/AIDS infection fell by almost 40% since 2000. Right, but that's not enough. There is still a lot more to achieve, and a lot more to achieve in the future. So some of the areas still required to achieve back in 2015, after MDG was almost coming to an end, where to put some statistics up, over 800 million people were living on less than $1.25 a day. 1/9 of the people in our planet goes to sleep hungry each night. Deforestation remains high in many countries. Oceans are becoming more acidic, threatening food security and marine ecosystems. 1/6 adults in the world are still illiterate. 2/3 of them are women. Communicable disease and gender or income inequality still persists. This is where you see the roadmap for SDG entering into 2015. SDG was basically designed keeping the evolution of emerging technologies in mind and how could they help. And SDG was an enhanced agenda of MDG based on the previous MDG. And then the agenda of SDG ends at 2030. From there on, future goal starts, not yet decided. Couple of differences between SDGs and MDGs before moving on to walking through the goals of MDG. So MDGs were basically determined by a small team of technical experts at the headquarters of United Nations, whereas SDGs were agreed upon by open working group composed of 30 members who collectively represented 70 different countries. And also the fact that SDGs are regarded as drastic improvements to MDGs, which in retrospect fail to consider the root cause of poverty and fall short of considering the holistic nature of MDGs. The SDGs also cover topics from consumption to global trade and are considered to be equipped to handle coming challenges as well as those currently. So SDGs came up with 17 different goals where they mainly talk about, if you can see, no poverty, zero hunger. Goal one is end of poverty, knowledge from everywhere, no poverty. Goal 2 is zero hunger, which is basically to end hunger, achieve food security, and improve nutrition, and promote sustainable agriculture. Goal 3 is good health, which ensures healthy lives and promotes well-being for all ages. Goal 4 is about quality education, which ensures inclusive and equitable equality education and promote lifelong learning opportunities for all. Goal 5 is gender equality, which aims to achieve gender equality and empower all women and girls. Goal 6 is clean water and sanitation, which ensures availability and sustainable management of water and sanitation for all. Goal 7 is about affordable and clean energy, which is to ensure the availability of affordable, reliable, sustainable, and modern energy for one and all. Goal 8 is about decent work and economic growth, which promotes sustained, inclusive, and sustainable economic growth, full and productive employment, and decent work for one and all. Goal 9 is about industry, innovation, and infrastructure, which is basically focused on building resilient infrastructure, promote inclusive and sustainable industrialization, and to foster innovation. Goal 10 is about reduced inequalities, which uh, inequalities within and among countries, not just gender and income, but also within it amongst borders, right? And goal 11 is about sustainable cities and communities, which aims to make cities and human settlements inclusive, safe, resilient, and sustainable. Goal 12 is about responsible consumption, which ensures sustainable consumption and production patterns. Goal 13 is about climate action, which was made to take urgent action to combat climate change and its impact. Goal 14 is about life below water, which aims to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. Goal 15 is about life on land, which aims to protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, and halt and reverse land degradation and halt biodiversity loss. Goal 16 is about peace and justice, which aims to promote peaceful and inclusive societies for sustainable development, provide access to justice for all, and build effective, accountable, and inclusive institutions at all levels. And the last goal is about partnership for the goals, which basically aims to strengthen the means of implementation and revitalize the goal partnership for sustainable development. So as you can see, a lot has been achieved with MDG and a lot more can be achieved in the coming years. We are almost here at 5 years down the line at SDGs. We have 10 years to go and a lot more still remains to do. SDGs aim to make those a success. But SDG is, again, an agenda. It requires inclusive contribution from one and all as humans with technology and of course biodiversity as well, right? So today the world is more connected by technology. 95% of people are now connected by mobile signal. Balancing these three pillars of sustainable development, social progress, and economic growth and environmental protection, SDG was basically formed. However, our climate is changing and our planet is transforming and there are more people on earth than ever. Hence, the 2030 goals comes into picture. Why 2030? Because by then, if we don't curb the greenhouse gas emission, then we'll pass a crucial tipping point that we can't come back from. Some other projections from 2030 for 2030 are as follows. The world will need at least 50% more food, 45% more energy, 30% more water than it originally did in 2012. And according to United Nations High-Level Panel on Global Sustainability estimates, these are the statistics derived. Then India will surpass China as the most populous country this year or maybe even earlier. Then according to the projections made by United Nations, the world populations of humans is estimated to be between approximately 7.8 billion and 8.5 billion people. Another study estimates that due to continued economic growth in Africa, most impoverished sub-Saharan African countries will graduate from low to middle income status by 2030. It is also estimated that global middle class will number about 4.9 billion people, about 66% of whom will live in Asia and 80% of whom living in what in 2015 is considered by the developing world. Overall, middle class will be most important economic and social sector, and a majority of the world's population will be out of poverty. Also, of the world's population, 60% will live in urban areas due to rapid urbanization. It is also estimated that 41 megacities will collectively contain 9% of the world's population, which will collectively contain 9% of the world's population will be built. All but one will be in Asia or Africa due to rapid urbanizations on those continents. Also, another report by all 16 US intelligence agencies suggests that the European Union and 14 individual countries, the unipolar world order in which the United Nations dominates, will have declined as China will have surpassed the United States economically and regional powers will have grown in strength, although the United States will probably remain a first among equals. Desalinations will have greatly increased in use. Also, tidal power may provide 15% of the United States electricity. These statistics were collected from Wikipedia. Some of these projections actually can be directly related to the SDG goals, and SDG goals are a way to make or break these projections possible. SDGs and IoTs. So why IoT? How is IoT coming into the picture of SDG? So IoT is considered as one of the most impactful technological advancements that we'll see before 2030. Amongst a few others, this was suggested by a report made by McKinsey. Most current IoT projects can contribute to achieving both the SDGs and the UN 2030 missions. An analysis conducted by World Economic Forum in collaboration with IoT research firm IoT Analytics showed that 84% of the existing IoT deployments can address SDGs. Some of the examples where IoT and SDGs are making IoT is making impact to make SDG a success. Let's focus on SDG goal 2. In the next few slides, I'll show you exactly a couple of use case examples. But to put it on a high level, now we have IoT is contributing from zero hunger, good health and well-being, clean water and sanitation, industry innovation and infrastructure, sustainable cities, climate actions, life below water, life on land, and a lot more. To basically walk down the examples, let's see some use cases that are possible under the Zero Hunger SDG, which is the SDG Goal 2. So basically, an estimated of 821 million people were undernourished in 2017. Annual cereal production will need to rise to about 3 billion tons, and annual meat production will need to rise by over 200 million tons to reach 470 million tons to feed 9.1 billion people by 2050. Some of the use cases, costs, improving the agri-food productivity by reducing production cost and increasing product quality can be contributed and controlled through IoT projects. Measuring impact and also reducing impact. So reducing the impact of agricultural activity on the consumptions of natural resources. Again, we could use IoT sensors to collect data and accordingly take measures. Production, multiplying the production and income of small producers. How can we do that? Using intelligent systems. That can definitely be done. Instead of one human working throughout, we can have some help from technology. Diversity, maintaining and improving genetic diversity in food products. Of course, IoT can be used to monitor the quality of food products, and also intelligence inbuilt with IoT could be used to suggest what can be the future steps taken to improve the diversity and quality of the products. Sustainability, achieving a sustainable and resilient agricultural production. again, could be achieved through IoT and AI. But when I'm saying this, the focus of this presentation is mainly on SDG, IoT, and AI. There will definitely be general softwares coming into picture, making all this happen. Food market, achieving a stable, sustainable, and accessible food market for everyone. Allocations, preventing market distortion, too much food for too few people, and vice versa, can maybe tackled with data and the data collected and generated by the sensors. Moving on, goal 3, good health and well-being. 3 billion people worldwide lack access to basic sanitation. Non-communicable disease alone will cost low and middle income countries more than 7 trillion in the next 15 years. Access, provide online access to healthcare services, aiding monitoring of basic health parameters for chronic disease patients, education, educating the population in health, self-management to streamline primary healthcare system, information, promoting cloud access systems to clinical histories to facilitate the medical information of patients from any geography. Clean water and sanitation. Around 700 million people in 43 countries suffer today from water scarcity. By 2025, 1.8 billion people will be living in countries or regions with absolute water scarcity, and 2/3 of the world's population could be living under water-stressed conditions. What can we do? What can IoT and AI do to help control water quality for both human and animal consumptions, as well as for irrigation use? Reducing water wastage with intelligent management of supply networks. Clean water can be saved. Also, prevention of floods in rural and urban areas due to river overflows could be taken care by proper IoT and AI systems. And in industry, innovation, and infrastructure, how could that help? For the lower income countries, the existing constraints regarding infrastructure affect farm productivity by 40%. How can IoT and AI help? Prevention, monitoring production process to optimize and prevent failures. Detecting the structural health of the facilities. Storage, controlling storage spaces. Security, improving security and surveillance systems. Transport, tracing goods and controlling their condition for animal transport, feeding, frozen, etc. Parking, controlling traffic and parking infrastructure, and in traffic, managing the flow of people in places of great affluence. IoT and AI certainly have use cases in all these arenas to help make SDG reach its goal. Sustainable cities, again, what can be the use case areas? Before that, we know that half of humanity, 3.5 billion people, live in cities today, and 5 billion people are projected to live in cities by 2030. The world's cities occupy just 3% of the Earth's land, but account for 60 to 80% of energy consumption and 75% of carbon emissions. Some of the use case areas where IoT and AI systems could be useful are controlling environmental pollution, monitoring water sanitation systems, optimizing energy consumption, improving waste management, encouraging development of spaces that are more livable, greener, less polluting, and more welcoming to its citizens. Resources, improving management of natural resources in public spaces. Also, boosting tourist attractions of visitors to sustainable destinations. Climate action. Given current climate concentrations and ongoing emissions of greenhouse gases, it is likely that by the end of this century, the increase in global temperature will exceed 1.5 degrees centigrade. The global emissions of carbon dioxide have increased by almost 50% since 1990. How can AI and IoT help? Intelligent systems can definitely help in managing natural resources to get the most out of the least environmental impact. Also, increasing plant production for consumptions and environmental care. European Union has come up with a regulatory on regulating CO2 emissions from vehicle manufacturers, and a lot of manufacturing automobile manufacturing companies in Europe, actually all will have to follow that regulation, and they are working on projects under UN SDG Goal 13 to regulate their emissions of the newly as well as the on-road vehicles that they have manufactured. Life below water, over 3 billion people depend on marine and coastal biodiversity for their livelihoods. Globally, the market value of marine and coastal resources and industries is estimated at 3 trillion per year, or about 5% of global GDP. Again, how can intelligent systems help? It can help in improving water quality in fish farming activities for food consumption, monitoring toxic spills into rivers and seas for species conservation. Life on land, around 1.6 billion people depend on forests for their livelihood. 74% of the poor are directly affected by land degradation globally. Again, how can intelligent systems help? Applying early fire detection system might just prevent fires. In developing systems for early detection of natural disasters could also help prevent calamities at certain level. But talking about IoT and its impact, so why is it so large? Because at its core, IoT is about measuring and remotely controlling previously unconnected things. It reaches people and things to places that older technology could not possibly go. But IoT, just the technology or the systems, is not alone. Together with human beings working in unison with these intelligent systems could actually make the 2030 goals a possibility. As you can see in the definition, IoT is all about connecting and measuring and remotely controlling those things that were previously unconnected. And it also could reach to places that older technology or even human nowadays could not reach. Going by the definition of IoT, what is the IoT basically? So IoT, or Internet of Things, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers. This point is important. Everything, be it an object, be it a system, be it devices, be it human beings, are provided with unique identifiers, and they have the ability to transfer data over a network without requiring human to human or human to computer interaction. It all happens in a seamless fashion wirelessly. How now, coming to the technological endpoints, how does an IoT lifecycle look like? So it all starts with IoT devices, sensors, actuators, and sensor systems, sensor network mounted at various places, from which are responsible for gathering and collecting data. From there on, through connectivity, it is sent to IoT infrastructures, which in turn acts as a storage and also as a gateway, which basically is responsible for transferring data to the IoT cloud, IoT cloud acts as a centralized repository for analysis and storage of data, which then further pushes data for data processing and analysis. A portion of the analysis of the data can be visualized in the form of dashboards and can be shown to users and clients. And another portion is again used for automatic control, and the loop continues that way. So it's all a synchronicity of all these phases that basically makes IoT possible. Focusing on this part a little, IoT data processing, how does the IoT information or the data lifecycle looks like? It starts from data emitted from sensors, control panels, actuators, human interface, etc. Then from there, we perform data analytics and we obtain information, data analyzed to drive tactical actions. Once we derive this information are used to trigger predefined business rules or intelligence, action driven from information. And once the intelligence is derived, we get a summary, or the summarized information is sent to back office for deep analysis, which in turn generates knowledge. Information stored in database and analyzed. Analysis yields optimized tactical tools. And here the process continues in loop. If necessary, based on the knowledge, if new rules are then new rules are created and pushed to business rules engine. Also, based on the knowledge obtained, we can decide whether to perform or add new rules for data analysis as well. This is an overview of how the information or the data lifecycle in IoT flows. Now, once we are aware of the information lifecycle, the next part comes in as IoT information value loop. So it starts from create, then you communicate, then you aggregate, then you analyze and act on it. So create is basically the use of sensors to generate information about physical event or stages. Then you communicate, the transmission of information from one place to another. Aggregation, the gathering together of information created at different times or from different sources. After this, you analyze, which is the discernment of patterns or relationships among phenomena that leads to descriptions, predictions, or prescriptions of actions. And then you act on the patterns that got generated from this step. In the action stage, you initiate, maintain, and change the physical event or stage. So this is an entire IoT information value loop, and IoT works in synchronicity with this value loop. Okay. Yeah. So now that we have information and we know what basically happens within the information lifecycle, let's look at the kinds of analytics that basically enables the information. You can see the value and the complexity. So first is at the very basic level, we have descriptive analytics, which tells us what is happening in my business or what is happening in the IoT system. So it gives us a comprehensive, accurate, and live data, and also effective visualization. Post descriptive analytics, we go into a mode of diagnostic analysis, which basically gives us the answer of why is it happening. So ability to drill down to the root cause and ability to isolate all confounding information. The visualization that is obtained from the descriptive analytics phase basically helps SMEs and product owners to read those data and understand why are things happening. After this, predictive analytics starts, which basically answers the question, what is likely to happen? So in that case, business strategies have remained fairly consistent over time. Historical patterns being used to predict specific outcomes using algorithms. Also, decisions are automated using algorithms and technology. Once predictive analytics is obtained, as in we could answer the question, what is likely to happen based on the data that we have, we move on to prescriptive analytics. which basically answers the question, what do I need to do? Now, this is where the AI part comes into picture, which basically talks about recommended actions and strategies based on champions, challenges, testing, strategy outcomes, also applying advanced analytical techniques to make specific recommendations, right? So these are the 4 stages of analytics from so descriptive analytics yields low business ROI and the complexity is also less. Then diagnostic analytics gives us certain more business ROI, more than descriptive analytics, and it's slightly more complex than the descriptive analytics. Predictive analytics gives good business ROI, and definitely prescriptive analytics will generate more business ROI in the future. Okay, now talking about how basically are these being possible. Now here in this section, I'll talk about a few examples that are slowly and steadily, step by step, making these actions a possibility. To start with, Plant CV is a project that is used to detect, that is used for plant phenotyping using computer vision. You can look into the project. This is the GitHub link. So it's an open source image analysis software, which basically targets for plant phenotyping. Plant CV also provides a common programming and documentation interface, which you can get the links of from this GitHub profile, to collect image analysis techniques that are integrated from a variety of source packages and algorithms. It utilizes a modular architecture that enables flexibility in the design of analysis workflows and rapid assimilation and integration of new methods. This is one example. Another such example is raster vision. The GitHub URL is here. Please go visit the GitHub URL. So it's an open source Python framework for building computer vision models on satellite, aerial, and other large imagery sets, including oblique drone imagery. How does it work? It allows users to quickly and repeatedly configure experiments that executes a machine learning pipeline, including analyzing training data, creating training chips, training models, creating predictions, evaluating models, and bundling the model files and configuration for easy deployment. There is a built-in support for chip classification, object detection, and semantic segmentation with backend using PyTorch. Experiments can also be executed on CPUs and GPUs with built-in support for running in the cloud using AWS Batch. The framework is extensible to new data sources, tasks, example, instance segmentation, also backends, example, Litetron 2, and cloud providers. Another such example is Sentinel-2. This basically is to sense agricultural system. So the Sentinel-2 is for agricultural system, is designed to automatically generate key products for agricultural monitoring based on Sentinel-2 and Landsat 8 data. The system has been developed by Senti2 Agri Consortium, and it was developed through the Sentinel-2 for Agricultural project, which has been funded by European Space Agency in the frame of the DUE program. If you feel like, go have a look to this project and you will get further more URLs to visit and you can learn more about the project. Another such open source project is Awesome Vegetation Index, which basically lists the references, applications of common vegetation indices for multiple multispectral, hyperspectral, and UAV images. Another example is flood GANs, which basically uses GANs to simulate how a house would look like had it suffered from a flood. Zero Virus is another such project which uses zero shot vehicle route understanding system for intelligent transportation. This was created as a part of CVPR 2020 AI City Challenge Track 1. Boston Greenery. This is another project made by, it's a government project by the city of Boston, which which basically is used to map parks and other green spaces plus OSM building layers. It's an output looks something like this. Another such project is Intelligent Traffic Analysis Software Toolkit, iTask, which aims to tackle 3 challenging problems, which are vehicle flow counting, vehicle re-identification, and abnormal event detection. Experiments on the datasets of traffic flow analysis from AI City Challenge 2020, they have basically built this software on the datasets provided by AI City Challenge 2020, and they have benchmarked their results. Another such project is Plant Stress Ontology, which basically is to get the ontology which describes biotic and abiotic stress that a plant may encounter. Another project contributing to this is YearTrack, which basically uses an imaging library to detect and track future positions of years and maize plants. Structural uncertainty, this is on the domain of civil engineering, which basically is quantifying engineering structural uncertainty with deep learning. Bifacial radiance, this is based on the project of photovoltaic cells and solar panels. This project basically provides a toolkit for working with radiance for the ray trace modeling of bifacial photovoltaics. GitHub profile is here. You can have a look. Wind energy prediction is, of course, deep learning and other techniques can be used for wind energy prediction. So this project particularly uses the time series method and the patterns of wind speed to generate power prediction. LSTM here is used as one of the models. UK carbon intensity. This is another project officially backed. This officially backed Open API from Oxford University and the National Grid ESO, which gives a snapshot of how much carbon each unit of electricity consumed in the UK emits for every half hour. This project also carries forecast regional breakdowns with some great charts and reusable widgets. Water quality. Here is another project that tracks water quality. It's a package designed to detect and quantify water quality and cyanobacterial harmful algal bloom from remotely sensed imagery. Another project detecting algal bloom, quite similar to the previous one, but this is still under development, detecting algal bloom from satellite images. So using data sets from NASA and other sources, it's fed into a convolutional neural network that attempts to identify satellite images from ocean colors that have high probability of capturing algae blooms. Without conformity, sea sampling collected at the time and location of the satellite image, the network can also suggest the presence of algal bloom. That's all for my presentation today. If you have any questions or would like to know more about SDG and how can it be, how can you basically frame your projects under one of these categories, you can reach out to me via LinkedIn.
Thank you so much, ma'am. It was indeed very informative. As of now, I do not see any questions in the comment section. I think the audience will get in touch with you through the social media handles if there are any queries.
Sure, absolutely. Thank you so
Thank you
much
so
for
much.
having.
Yes. Thank you. There will be a brief pause. Our next speaker will join us very soon. Please stay tuned. This is almost the half of the event. We have concluded with, so we started at 11:15 in the morning. Right now it's 3:51. We have traveled throughout traveled throughout a diversity of topics ranging from data science to personal experiences of people working in different fields at different companies, people who have started their own companies, people holding important roles and designations at reputed companies, as well as people who are volunteering for such important organizations and promoting and inspiring people so much. We will move on to our next speaker. We'll wait a little bit. I do apologize for this brief pause, but this is how it works. Thank you. Please stay tuned. We'll be back. I would like to introduce my co-anchor Isha. She'll be taking on the session from here. Isha will introduce the next speaker and will be there with you all for the next lineup. Over to you, Isha.
Hello everyone. So I am Isha. So our next speaker is Shubha ma'am. She's a senior data scientist at Swiggy Bangalore. Please, ma'am, you can start with your talk.
Sure.
Can you guys see my screen?
Yes, sir. It's visible.
Yes.
Shall we begin?
Yes, ma'am.
Yes.
Okay, cool guys. Thanks for joining me here today. I am Shubha Shedthikere, a senior data scientist at Swiggy, and I work on ads recommendation systems. And well, super excited to be here. Thanks Usha and WDS for this opportunity. Today, I'll be taking you through some of the recent works that we have done for multi-objective optimization in recommendation systems at Swiggy. Yeah, let's just start off, okay? So, okay, the overall outline of this is, let's take up the problem setting itself, like where do we even come across or where do we need to do this multi-objective recommendations? And then the different solution techniques, we'll review that. And then I will take you through two particular techniques. One is multi-objective optimization for gradient boosting trees. And the other one is labels, stochastic label aggregation. Okay, I mean, like it may seem like a lot of words here, but I'll make it super intuitive. And the beauty is the algorithms themselves are so intuitive, okay? Okay, so Swiggy doesn't need any introduction, okay? Most of you would have used the app and but what you would not be aware probably is that behind that beautiful looking app is like at least 100, say, DL ML models running, and at each stage, like say when you start opening the app, let's say that we call it a session, there is a recommendation engine which is running to show you all the restaurants near you, which probably is relevant for you. There are ads personalization, there is offers going on. There is also a search bar where you can search for what you want to eat or which particular restaurants you want. And once you do that, there is also, once you enter the menu, there is so many more algorithms to show you the right items there. And once you make an order, there is ETA predictions. There are also optimizations on the payment methods itself. And there is lots more, assignment of the DE partner, batching, demand forecasting, tracking, and so on and so forth. But before actually, I mean, obviously I'm not going to dive into all these things. I'll just take one problem here today where we will look at the ads recommendation and just as an overview of what recommendation system that we are looking at, let's take a look at this. Say, for example, as soon as you open the app, okay, I think you would have seen the app, there are different, horizontal widgets on the app. And each of those widgets are actually powered by different recommender systems. Like one could be, as you say, the top picks for you. One could be like the best in safety. The other could be the top offers. So each of those are showing a different set of restaurants for you from among the restaurants which is close to you, because like say within some 4 to 8 kilometers, all the restaurants nearby would have been chosen. And then based on some objective, each of them are going to solve for a different objective or a different goal. Then those recommender systems will put these restaurants on the UI for you. Now, though each of these recommender systems had different objectives, but at a at a Uber level, what if you just think about the architecture of the system itself, it is more like there is a query. In our case, say it is the customer, and in our case, say the item corpus is the set of all the restaurants, which is like within the geographical area. There could be thousands of them. So among that, there is a candidate selection process. Like say, it will kind of filter it to a smaller subset, maybe based on serviceability and whatnot, other filters. And there could also be some algorithms running for candidate selection itself. We'll not get into the candidate selection part today. Let's say we have the list of candidates selected. Like say, there could be about say 200 or 500, so on and so forth. A subset of the overall set that were available for you. And then there is a ranking algorithm which kind of sorts these restaurants on the basis of relevance to you. So now, exactly as I said. So now we have a list of all the huge corpus of restaurants, and for a given user session, like as soon as you open an app, with respect to you, the customer, and with respect to the meal slot, there is a set of restaurants that gets selected. And that is what is done by the candidate selection algorithm. And based on this, it's just an array. Based on this, the ranking algorithm will actually sort it based on the relevance for you. Now, there are various types of ranking algorithms, but I think without loss of generality, we can call this ranking function as some function which will take the restaurant and the customer pair, and it will give out a number between 0 and 1. Once that is done, we can anyway sort it based on that, right? And this ranking algorithm itself, it would depend on the interaction data, like say, what are the impressions that you viewed, how many sessions that you did, what all the impressions that you clicked. And it could depend upon the transactional data, like what are the orders you made and what are the type of orders you made, like did you order North Indian, South Indian, the cuisine of the users. So all this data is again further inferred from the transactional data, and there's also a lot of context to it, like say for example if it's a meal slot and so on and so forth. So now based on all this data, the ranking algorithm for a given customer restaurant, and customer restaurant here I mean like a vector of all this information, of all the customer information, restaurant information, the interaction data, everything put together. So for a given customer restaurant, it will spit out a number between 0 and 1, and then we can sort it based on that and display it on the UI. Now coming to the ads recommendation itself, like what is the objective of an ads recommendation? I mean, this is more like a more generic question as to what is the objective of marketing itself. What do we do? So now why would the restaurant partners who are onboarded with us, why would they want to run ads? First of all, brand promotion, brand building. That is, I think these 4 aims are like what do you say, goals of marketing, generic, right? So then they want to improve the visibility, right? Like people want to know that these restaurants are there on Swiggy. So they would want to say start off, once they are onboarded, they would want to start running ads on the platform. Then there may be some new offers or some new dishes that they want to promote. Also, they want to again, start running ads so that people kind of remember, okay, this restaurant is there. You might have ordered some time back, but now that's the whole idea, right? People keep repeating the ads so as to remain in the people's mind. So ad partners keep running ads with us occasionally, so that for all these aims, for brand building, to increase the visibility, and maybe if they have some new offers and things like that. So now if we just look at what would be a good way, see, our aim now is to actually come up with this ranking function. Now let's think what would be a good way to come up with this ranking function. See, how would I measure whether this ranking function was good or not? What would I do? I would actually show some impressions to the customer, and if that ad was relevant to the customer, he would probably click and actually go inside the menu and see. That is kind of increasing the awareness about the restaurant to the customer, and that is like definitely the aim of running an ad. Ordering is secondary, that also we want, but first of all, we want the user to be aware that, okay, this restaurant even exists here. Okay, now what all has he put up, like is he giving the parota or is he giving biryani? Okay, this restaurant, creating that awareness. So first thing, what we at least want the customer to do is click on the impression, okay? Let him at least do that. So if we are at least seeing that among the impressions that we are giving on the app, is the user clicking it, then I'm like, okay, looks like my ranking algorithm is working decently well. So now what I'll do as a first step, let's say for this ranking algorithm, I will build a simple classification model, which will tell me, given this customer, this restaurant, is the customer going to click on the impression or not? I'm going to build such a classifier, okay? Now, say that basically click prediction, as in whether the user is going to click or not. So now I will, the usual ML techniques, I will apply, and I will find out this, I will get this probability whether the person shown that impression of that particular restaurant is going to click or not. Okay, I got that. And based on that particular probability, I have sorted, and based on that sorted array, those restaurants, I will show to the user, right? So now, this is like the super important point, okay? I've not put this real-time inferencing here just for the sake of putting it here. Note that all this is happening at real time, as in, what I mean by real-time inferencing is, when you actually open the app, there is a ping that is going to our data science platform, like basically where the models are running. And then the model actually is given this feature vector, and then the model spits out the score, that is probability of click given the impression. And then it is done for all the customer restaurant pairs, which we were supposed to rank. And then we sorted it out, and it came back to the UI, and then it is displayed, okay? This real-time inference, I mean, it's like, this slide is like the slide of this session, okay? I mean, I keep stressing this because this whole point of why we are actually having to do multi-objective inferencing inside the learning problem, the crux is right here in this slide, okay? I don't want to spoil it for you. Yeah, let's go ahead. But yeah, just keep in mind that this whole pipeline is happening real time, all right? Now, I want to take this example so that you will be able to appreciate when this multi-objectives come into picture. Let's say very hypothetical examples, okay? Don't believe the numbers here. Now, let's say in our app, for each session, we can, it's like a very chota app. For each session, we can display, also let's take a small widget also, that's also fine. So let's take that horizontal bar. For each session, when the customer opens it, in that horizontal bar, I should have put it horizontal there, okay, that's fine. Each in that horizontal bar, we can display at max 3 restaurants, okay? So that means to say I have like 3 chances, like 3 restaurants to display, I better do well in those. And let's say we have in the whole system 5 restaurants and we have 8 customers, okay? Very hypothetical situation. But I think this is good to understand what's happening, right? So we have 8 customers, 5 restaurants, 3 slots for displaying. And I have already built my prediction model, and also I have decided that I will go ahead, I will rank based on the probability of clicking. I mean, after all, I will show those restaurants where I can put my best bet, right? I will show those which has the highest probability of clicking. So now if I were to look at this, it says that for this say the model has already computed. Now say what I have is for a customer 1 and restaurant 1, the probability of clicking is 0.8, which means to say that if I show 100 impressions, 80 times he's going to click it. That's what this means, right? So now let's say in each session, if there are 100 sessions, there is only 1 chance for a restaurant to come. So it is equal to say making 100 impressions, right? So now what we do is for a given customer, let's say this data is for a particular session or a particular day. Say for example, this customer 1, these were the probabilities of the different restaurants, the user clicking given the impressions. Now, obviously, we've decided that at least we have to maximize the click. So now what we will do is, we will pick up this 0.8, or he's going to click 80 times if I show R1. Then we will pick this for R4 if I show, okay, looks like 60 times he's going to click. See, this is pretty hypothetical in the sense that I'm talking 100 sessions showing the same set of restaurants and then clicking, okay? I mean, this is like a more from a mathematical problem point of view to understand what's happening. So now what will happen? Okay, then R4 if we show 100 times, if we show, okay, 60 times he's going to click. Yeah, definitely I'm not going to show these 2 because they have lower probability of clicking. So now fine. So similarly, I have found out all the probabilities for all the customers now, for the customer restaurant pairs I have found out. And now I'm going to whenever, say for example, whenever customer 1 opens the app, then the model will actually, from among all the restaurants, let's say there is not much of a candidate selection to be done, we have only 5. So now among all these 5, we score all of them, and then we will pick these and show it on the app. Now similarly, if other customers are pinging, and let's say the day has passed or whatever, and then we see that these 8 guys, each of them had 100 sessions, and then the total number of clicks that we got from all of them is around 1,500 of the total impressions that we had made is this, okay? Out of 2,500, 2,400 impressions that we made, we had about 1,500 sessions, okay? Now what happens is, right now what we were really doing is optimizing just for the clicks, right? Now what happened, if you just take a look at this R4 restaurant is also a partner with us. doesn't look like he got a good share of the clicks. I mean, it doesn't look like we are doing a fair job for them, because see, the very fact that those guys are trying to advertise here is obviously that they may not be so popular and they want to become popular, right? And if they don't get a chance to do so, then they will remain unpopular. So now it doesn't look like there is some fairness here. So we would want to introduce some amount of fairness. Then also we can see that if we were to do this, then there isn't diversity also. The customers are going to see similar restaurants each time. There isn't enough diversity as well. Apart from that, say for example, this a marketplace like Swiggy, I mean, while at the heart and heart we want to give a super experience to the consumers, it is also important that we take care of the other stakeholders in the system, including the platform, right? I mean, we want to be able to provide this entire service in a very cost-effective way. We want the partners also grow their business, and same with the deal partners as well. So now what we have is this this way of having a single ranking function. See, also remember that this was not really a function that we took we took a CTR prediction as a ranking function. Whatever you took, basically what we did is we were trying to optimize one thing. Either say suppose we did another function, say we will optimize some kind of conversion, say orders. It is still like we are trying to optimize one thing, because of which other stakeholders may be losing out, right? So now the traditional recommendation system actually focuses on just the relevance part or just the accuracy part, like getting the clicks or getting the orders. Am I showing basically one objective, single objective recommendation systems? But what really the practical recommendation systems should do, particularly the ones which are serving like a three-sided marketplace or many more sided marketplace, because there are many stakeholders in the system, we actually have to consider the objectives of all the stakeholders. So now let's take a simple example. Let's say we have built this model, and then we realize that apart from, though we've been doing pretty well on getting the clicks that we wanted, what is happening is, if we just look at the time that we show on the app, this is SLA, that is service level agreement. This is like when you actually see the restaurant, there is also a number that is given there that tells you what is the service level agreement that we are giving if you order from this particular restaurant, right? So now, if you think from an operational perspective, if the service level agreement or the SLA is like say 50 minutes or 1 hour, definitely it increases the operational cost for the platform itself, and there is a possibility of reducing the customer experience itself, right? I mean, I don't think people would be also ready to wait for so long. So now what happens? Now if we just look at the same numbers, whatever I've done green is like that gets selected to be displayed. So if I just look at the SLA for each of these restaurants, this 40 is in minutes. So this looks like it is 40 minutes, okay? So now this is 50 minutes and this is 40 minutes. Then if I just look at just for customer one, I mean, there were other restaurants which were closer or which could do the service, and which maybe it was not as relevant, but it was from a SLA perspective, that would have been a better choice, right? So now if we take for this corresponding choices that we made based on the probability of clicking, the average SLA turns out to be about 35 minutes. Now say the business or the product guys comes and says, hey, I mean, you're doing pretty good on the getting the number of clicks that we want on the platform, but it looks like, from an SLA point of view, we're not doing so good. Your recommendation system is choosing really far off or really high SLA restaurants. I mean, can you do something about it? Now comes the second objective, right? So now, let's say, very dumb way, okay? Let's say, then I thought, okay, overnight I will fix this. I will pretty dumb way. What I'll do is, okay, he's talking about reducing SLA, right? See, after I wanted a ranking algorithm, some function which will give me a number and I will sort it according to it. So now what I will do, sort it according to SLA, big deal. I'll just do that, okay? Overnight, I just change some code. I'll get the SLA for each restaurant. I will just sort it according to SLA, and the next morning I'll like, dude, I've reduced the SLA. See, I've got an average SLA of 30 minutes now. And reducing 5 minutes at Swiggy scale is like huge, okay? So now, okay, so then the product guy is like super happy. Oh wow, miracle here. But then if we start selecting based on SLA, oh, what happened to our clicks? Now it's become from 1,500 clicks. I mean, we selected the guys who were giving higher probability of clicking. Those restaurants never got selected now, which basically means to say that we are actually compromising on the relevance. We are trying to give the restaurants which are lower SLAs, but it might not be relevant to the customer at all. I mean, you may show it, but he will never click it. What is the point? So now we have two problems, right? One, I wanted to get a lot of clicks. I optimized it with respect to the CTR. The other one, I wanted to have a lower SLA. I optimized it with respect to SLA. But now, yeah, and of course, the both ends of the spectrum are not going to satisfy our requirement, right? So now what do we do? Like, what do you think we should be doing? I think like the most intuitive way is big deal, combine them. That is the question here. How do we combine them? Now, if we just look at what happened to our original architecture is we just had until the ranking algorithm, right? So now what do we do is all these additional constraints, re-ranking, whatever we may want to do with the additional constraint. This SLA is one criterion. There could be others, like how I had already told you, they could be introducing fairness, introducing diversity, whatever it may be. So all these additional constraints, we will not touch the original ML model that we already have, the ranking algorithm that we already had. But what we will do is we'll put all these extras outside of it, do a re-ranking. Okay, seems, yeah, I think that's pretty intuitive. That's what you would do, like common sense, right? Okay, let's do that. But now the question is, yeah, as I said, how are we going to combine that, right? Now let's say we do this optimization algorithm. I'm just deep dive, like double down on this as a post-processing, right? So where this all the objectives and the secondary optimizations that we want to do is going to come as a post-processing step. But as you will see, this post-processing step could bring in some problems, okay? And this real-time inferencing is again on this slide to tell you that all these things are yet happening. Still, we want it to happen still in the real. As in, first there is a re-ranking. First there is a ranking algorithm which will rank it. Let's say it is a PCTR in our case, and then outside of it, I will do something which I will tell you. We'll put some objectives and we will optimize it, and then we will re-rank it based on that, and we'll give out. And so we are still in the realm of real-time inferencing and ranking. Okay. Now, okay, this has some equations, but it's like super common sense. I mean, even without these maths equations, that's exactly what we will do. Okay. So now let's say this Tij is I stands for the ith. Okay, it should have been ith customer and jth restaurant. Sorry guys, here it's ith customer and jth restaurant. So now and Pij is the probability of clicking. Basically, we had some two numbers, right? I is actually, say, we will normalize that SLA between 0 and 1. That is going to give us one set of numbers according to which we could rank. And then Pij actually gives us the PCTR, which we already computed. That gives another set of ranking, which also will help us sort those restaurants. And so we have basically two types of ranks, two lists which are ranked differently. Now we are trying to ask, now the Uber objective becomes that you want to maximize, this is a TSIJ, we want to maximize the Tij, that is your time or your SLA you want to reduce. And then you also want to, okay, why is it a maximization? Without loss of generality, we can do 1 by T or 1 by SLA or 1 minus that. So basically what we want to do is, there is already one ranking with respect to the SLA, which we want to optimize. There is also another ranking with respect to P-click, which we want to optimize, okay? So now, for this particular problem, what we will do is, we have, and also that this Xij is what I'm telling, like, no big deal. It is just, it takes a value 0 or 1, wherever I had those green blocks, that's it. So basically here, X11 will be 1, and X12 will be a 0, and X13 and so on and so forth. So this is something like a selection variable, the decision variables, okay? And then it takes a value between 0 and 1, and for this particular problem, we want that we are taking 3 of them, okay? So now what happened, to solve this particular problem, what we have is, I mean, though it looks like something is happening over here, it's super simple, because what we really want to do is, for each of the customers, if we want to solve this problem, then all that we want to do is solve at an individual user level. Okay, that is what I would say is a local optimization problem, as in, that is, to solve this optimization, to solve for these two constraints at a platform level, you just have to solve it at an individual customer level. See, we are still in the real-time inferencing part. We will get one query each time. There is a list of restaurants. Solve for that list. Don't worry about other customers and their list. We're just locally solving this problem. For one query, we are solving this problem. So if we were to solve for one query, then the solving at a platform level itself is like solving for each of the individual users. So basically, we are going to decompose the problem itself, decomposes such that we can just solve it for an individual customer, and you would like, it is so amazing, or it is so beautiful, that this problem is like what we would have thought like 3 slides ago. Just combine them. What are we going to do? This lambda is a value between 0 and 1, and then you'll just take some share of this, some share of that, put together, whichever gives you the higher score, take that constraint. I mean, I think that's what we had thought of even initially. Just combine the 2 scores, right? And in fact, what is the beauty about it is, for this particular problem, okay, for this particular problem, in fact, that is an optimal solution. Wow. I mean, I think no brainer. Yeah. So now we will actually have those, peak leak for the customer restaurant where we will have our, sorry guys, I think TI and SI, I think I've kind of interchangeably used, excuse me for that. Yeah, basically you get it. It is a second, a ranking between 0 and 1 because of the second objective that we have here. So now we just combine these two, and then what we will do is we will take the top 3. In fact, that's exactly what we were doing here also. We were taking the top 3 based on peak click. Now combine the two ranking scores and then take the top 3 based on that. And the beauty of it, for this problem, this is actually it is a optimal solution. But now the trouble comes, I mean, it's like hiding somewhere, the trouble. Where is the trouble hiding? Because here we are doing a local optimization and we are not doing the global optimization. As in, okay, each query came, I just, for that particular guy, I combined these two in some way, and then I chose the top 3. Next query came, I combined again this SLA and peak click, I combined these two and then took top 3. I did that for a whole bunch of customers, okay? But doing this way, there is absolutely no guarantee on what was the decrease in my overall number of clicks. So we are doing a trade-off here. If we didn't have that SLA part coming in, then we had the highest number of clicks that we could possibly get, at least for this example, right? And true when we extend to the system. Now, what will happen is if we do this local optimization, we are like happy in our own world, solving query by query. But at a global level, we don't even know what's happening. Did we actually get lower than that? Did we get 10% less than the topmost number of clicks that we would have got? Or did we get a 20% less than topmost clicks that we would have got? We have no clue, and we have no way of controlling it also here. So now what we'll think about is, okay, somehow this locally solving for query by query is, I may very well put it in the system, but somehow I will have sleepless nights now, because I will always be thinking today how many clicks came. I don't have any guarantees on it, right? So now what we will do a global optimization, as in, if you put in all the queries together and we will select those customer restaurant pairs such that while I will maximize for the relevance, while I will also maximize or say minimize vice versa for the SLA, I will also be guaranteed that I'm getting some amount of clicks, right? So now how do we do that? See, now this global optimization, how did this actually problem come in is, this constraint was not there in the earlier problem. If you just note it here, that global optimization, that is, you can do whatever you want with your selection variables. These X's are the decision of the selection variables here. You can do whatever you want at a query level, no problem. But when you actually have to combine at the entire, all the population level, so that you can give some global guarantees, then we don't know how to solve this. Because tell me, one query comes. Now I have 5 restaurants to sort. Now will I know what restaurants will come for other queries? How do I know what my selections should be? Or like say for one particular customer, what the selection should be? Will I wait for other customers' queries to come? Will I collect some more queries and jointly optimize? What do I do now? So now what, yeah, I mean, here the basic fundamental is the problem is not going to decompose because we are kind of putting all the selection variables together to give us some global guarantees. Now what happened, what we can do over here is, as I said, so this truly is, what's happening here is, I cannot keep waiting for other queries, right? I'll do one thing. This online doesn't look like in this situation, this real-time inferencing is going to work for me, because in real-time inferencing, for each query, you have to optimize and send out the result, right? So now what we can do, okay, looks like the only solution is, we have to rank all the customer restaurant pair. Maybe we'll run a cron job at night, and we will rank all the customer restaurant pair, run this mega optimization problem, okay? So which will kind of solve this global optimization problem where we are maximizing for SLA for each customer, we are maximizing relevance or maximizing as in minimizing, and then we are also optimizing for the click, and we are also selecting some top 3, and the selection is such that we will give some global guarantees. So if that mega optimization problem, I hope it will run within the night for Swiggy kind of scale, or it should be like I should just give, yeah, I mean, even maybe the best of the best solvers for such high scale, it may not complete within, I don't know, a few hours at least, right? I mean, even if you want to run it at night, so that we have all these ranks and re-ranks and everything ready by next morning, I hope it will work, but that may not be the case for the kind of scale that we see. I mean, if it doesn't finish, it will almost be like, you know, put the problem for optimization and it may take 3 days. Maybe we can go to Goa and come back, by then it will be done. So basically now what's happening here is, if we want to real time is anyway like out of question here for this scenario. Now batch inferencing has come into picture. Batch inferencing also, I'm hoping it will finish the job. So we already know that I'm seeing some trouble coming in, right? The other thing what's happening here is, just think about the customer restaurant pairs, the blow up in the cardinality that we should score and keep, right? So now I already see some troubles coming by, right? And of course, if we are actually able to do this, like score all the customer restaurants, get their ranks, do the global optimization, put it in the DB, and like complete this whole job within a reasonable amount of time for the huge scales that we generally see these days, then at the time of scoring, what do? Normal candidate selection. The scoring is just going to happen from the lookup from the DB. The candidate will come. I mean, there's a candidate selection for a given query. The ranking lookup will be there. I mean, there is no model run and all is already done here. So it will just do the lookup, and we will get the scores and we will output. And this has solved the global optimization problem, and it has solved the multi-objective law. That is, 2 objectives we had, that you have to optimize with respect to SLA, you have to optimize with respect to the clicks. But as I already told you, even the best of best LP solvers it may take a very long time, and also it may be like the computation cost and the storage cost is definitely going to blow up. So I don't think this is the way forward for us. So now it again boils down to, can I do something at real time itself? Doesn't look like this batch inferencing is going to work for our situation. So what I really want to do is, I want to infer real time, but somehow it should have calculated that global minima and kept for me, so that even if I infer real time and if I actually choose those values at real time, but it is some kind of pre-computed and optimized before and kept for me. So if you just think about this scenario, I think the best way to actually do that would be, if we can somehow put all these additional objectives that we wanted to solve into the loss function or into the time when we are actually building the model itself. Because at the time of scoring, the model is ready with your global optimized problem, and it will give the score, and we will have some global guarantees also. So now you see that this, I mean, that's exactly why that, real-time inference and this whole production related stuff, I'm putting it upfront, because that's only when you will be able to appreciate why we need to do, or why we need to put these additional objectives into the learning problem. Because you could have definitely done it outside. I'm not saying it cannot be done. Definitely it can be done. But we already saw what is the problem because of that. And that's exactly the reason why we are thinking of some method where we can combine these objectives, global guarantees, global constraints into the loss function, into the model's loss function, so that when the model is built, at that time itself, it is kind of training with respect to multiple things, and it is learning with respect to multiple loss functions, and it is ready with the solution, or it's ready with the value or the inference, which is kind of solving a global optimization problem, right? So now this is like, this looks like doable, possible as an idea. Yeah, I think maybe we can put those objective functions or optimization into the model building algorithm itself, right? So now, the question is, how do we do that? Now, if we were even to do it, how do we do it? How do we exactly do it? Say, what we will do is, the different objectives, right? Whatever we wanted to maximize, whatever we wanted to minimize, we will actually put it as part of the loss function. Now, if you just think about intuitively, what is the loss function telling the model? There is a set of weights or there is a set of parameters that the model is trying to learn. And based on these parameters, it is going to give you the final inference or the output, right? So what is this loss function telling? Loss function is a guiding force to tell the model, hey dude, you're making mistakes, change your weights this way, right? Now this, if there are two loss functions, I mean, it is like mom and dad, right? Mom will tell dude, you're doing mistakes in these things. Dad will tell you're doing mistakes in these things. Then the child is going to align to both of them. So that is what is happening over here. Before, there was one loss function with respect to which the model was learning, with respect to which the model was trying to learn and update its weights. Now there are two loss functions, and it has to align with respect to both. Of course, yeah, sometimes even mom's and dad's requirements can be conflicting. Similar thing will happen here also. But I mean, we will have some, it's like, listen to this loss function as long as you don't violate this loss function by this much amount. That is a constraint we can put. You satisfy this loss function, but you don't make too many mistakes with respect to this loss function. And that is how the model is going to learn its parameters and update its parameters. Now, if there are two loss functions, we need two labels. Yes, very well. We can put the extra SLA related values as, we can put it as labels. So now, how has the problem turned out into? Before, what we used to have a feature vector, we used to have one label, and we used to have one loss function. It will try to get as close as possible to the label, and it will be guided by the loss error it is making with respect to the loss function. Now there is one feature, and there are multiple labels, there are multiple loss function. Okay, it has to see, with respect to this label I'm making this error, with respect to the second label I'm making this error, and then I have to adjust the parameters accordingly, right? But now let's see, now we are actually having two new setups coming into this, our original learning problem paradigm, where we used to have only one things, right? So now what is that? Additional labels have come into picture. The other one, additional loss functions have come into picture. Now, what can we do about this? In fact, these two different varieties give us different variety of models. One of each I am going to take you through today. Okay. So one thing is, how do we combine? The other separate category is where you can actually build different multiple models itself, like say one with respect to SLA, one with respect to your p-click, and then combine it. That can also be done. But then again, that the next level of trouble will come, where you have so many more, like say you have with respect to diversity, with respect to fairness, with respect to SLA, then some other cost function, then we can build, see, in theory we can do everything, okay, but the question is, will it work in production? That is a fundamental question. Even here, I will build 5 models, no problem, okay? But then in production, with latency requirements that we have today, like we should be getting the results within like less than 100 milliseconds, then will all this work in production? I doubt it. So now, let us not consider this multiple models in the picture. Let's go back to the place where we can actually build the models combining the loss functions, okay? Now, this is nothing new to machine learning, okay? This is like, I don't know, very, very old, normal optimization problem, where whenever we had multiple objectives to solve, what would they do? Pretty again intuitive. You combine them in a linear way. That used to call that you combine them to form one objective, as in, like if there are 2 things, just like how we did previously, we had two functions or 2 objectives. You would say, I want to maximize this, I want to maximize this. Then I will say, maximize the combination of the 2. Right, so that you have now one thing to maximize because you already combined them. So combining those 2 so that your ultimately the loss function with respect to which you solve the problem is called scalarization. That's a scalarization method where you combine the multiple loss function so that you will solve ultimately the objective function, the finally what you solve, it will be 1. Okay, that is basically the output of will be a scalar. So now I think the most intuitive way people have done, like historically, is you will, and we also saw in that earlier problem, is where we combine the loss function. See, mind you, the earlier slide that we saw, the solution to the problem is where we got that alpha into clip 1 minus alpha, but that need not be the solution every time. For that particular problem, it was so, right? So each time we do this, it is not like the solution will turn out to be alpha of each of them. That is not going to be so because of the global constraint. Again, I'm repeating the same things. See, so that you'll be able to appreciate the problem here. Okay, so now, now we have this weighted sum method where you will actually weight each of the loss functions and then and solve this combined single loss function. That is one way to do it. The other way to do it, and mind you, these are not techniques which is new to machine learning or something. It has been like done for ages in optimization theory. Okay, so then just that now we are trying to put this into the framework of learning. That is like, I wouldn't say that is pretty new. Okay, maybe 10 years, last 10 years. Okay, so now one way was that. The second way is where you have. There were multiple things, right? This is the dad and mom problem I was telling. It is like, listen to your mom, but don't, go so much away from what your dad is telling, right? So it is like that. So here it is like, minimize this loss function as long as you are not making you're not making too much errors with respect to the other loss functions. Like there, you are going to put a constraint. And then now this multiple objective problem now became a single objective problem because the objective that you solve with respect to is one loss function. Here you combine them. In the other cases, you took a primary loss function and put everything into the constraints, right? So now those are the 2 ways which there are many more ways. These are the 2 ways which are popularly used. Okay. The other trouble that we had is combining the labels. Now, what we can do is, I mean, this is a very interesting paper. I've shared the sources in the end, but this is a very interesting recent paper by David Carmel, where he says that now in the original problem, we had one loss function, and that one loss function was with respect to the labels and the model output, right? So now somehow, I mean, you have multiple labels, convert it to one label. No, then the question is, how do we convert it? Okay, you can maybe you can add some deterministic rules, like you can if y1 plus y2 you can do, or lambda y1 plus y2 you can do, or you can have some more complex rules. Basically, you want to somehow take all these labels and put it as one label. Now, if you put it as one label, like super good, right? We are back into the original machine learning problem setting where we have one label, one optimization. Like that's a very, very clean approach. But now the question comes, there are possibly like all possible ways to combine them. What is the optimal way to do it? Then, I mean, there is a nice theory and proof where he actually shows that stochastically combining, which means to say that Sometimes you take this Y1, sometimes you take that Y2. I think I'm just realizing this mom and dad example is turning out to be pretty good. Now it is more like, there it was with respect to the loss functions. Here it is like some of the data samples you take from mom, some of the data samples you take from dad. Then you optimize with respect to that, optimize with respect to this. So here, what is the difference between deterministic and stochastic combining is that in deterministic combining, you would have had a set rule which will tell how it has to be combined, and for each training sample, you will combine it in exactly that rule way. But here what is happening is, the stochastic label aggregation, that's why the name stochastic, because I mean label aggregation is obvious, basically we are aggregating the labels. So the stochasticity is coming because for some data samples you're going to take Y1 or whatever, if you have two, so for some labels you're going to take Y1 and some labels you're going to take Y2. Now there is an actually important concept which I kind of deferred bringing until now, that's called as Pareto optimality. That's basically because when we have these multiple objectives, how are you going to tell this is the most optimal solution? Basically because if we had a single objective, I think things were pretty clear. Whichever is the whichever solution or whichever whatever output or solution gave you the least value for the cost function, that is the optimal solution, or that is the solution of that optimization problem. But now we have two loss functions with respect to which we are trying to solve. See, mind you that these are the things we are kind of doing to fit it to our original machine learning algorithms. I mean, like, we are used to single objective, single loss function. We are kind of trained to that. We have seen only those kind of examples. So we are trying to fit these multiple objectives into the problems that we know. But original problems remains the original problem, right? And the original problem was that you have to optimize with respect to two loss functions. Now, in such a, you may solve for whatever. Inside of the hood, you may do whatever you want to do, which you are comfortable with. You want a single objective, single label, do whatever. But still, when you report back, you have to tell how is it doing with respect to the original problem, and the original problem's optimality. How are we going to see? How are we going to judge which was the optimal solution? Say for example, I did one way of doing. Say I did a way where I combine. This was the original problem. Say we had two loss functions, and one way I did is done stochastic label aggregation. I did. Then I got 1 point here. Now what is this point? Basically, this is the loss function 1. This is the loss function 2. And obviously, I want to reduce both. Say if it's a minimization problem, I want to reduce as much as possible. If it is not a minimization, if it's a maximization problem, then I want to maximize both. Okay. So now what is happening is, if I want to minimize the loss function, with respect, say for example, one method I tried and I got a point here, which means to say I achieved this whatever, let's say x1 y1 with respect to this point. So this much L1 loss I got and this much L2 loss I got. Now my teammate is doing epsilon constraint method, and she may come up and say, I've trained another model, I've used this other method that I've used, but on the original problem I've got this L1 and this L2. Now the question is, which do we put in production? Which is the better model? The problem is, in multi-objective optimization, there is no way that you can tell that one point is the solution to the problem. And that's exactly what we call the Pareto optimality, as in, if the solution does not improve in one while making the other objective bad, then they both are like as good as equal. Say for example, this, if I want to improve a solution here, and if I have to reduce my L1, then I actually have to increase with respect to L2, and vice versa. Here, if I have to reduce with respect to L2, somehow I cannot come here, right? I'm not able to come here. I mean, this exactly shows what is the limit, until where, what is that solution, or rather, what are the loss functions that can be achieved? What are the loss function points that can be achieved? And if two solutions do not improve on each other, or do not dominate. Okay, I don't want to use some more jargons here. Let's intuitively understand it, that if you have to improve one and if you have to compromise on the other, then you are both fine. But suppose if you had a point over here, okay, let's say if you had a point here, then definitely I can come to this point, right? I can come up with some build some model which will actually reduce my L1 and reduce my L2, and then I can achieve this point here. So all these points which are sitting here, all these points which are kind of achieved by the models, that would be called, I mean, this would be called as a Pareto optimal frontier. So which means to say that if you want to improve on one thing, then you will obviously have to compromise on the other laws. And why all this katha I told is basically because it has been shown that if you do stochastic label aggregation, then the solutions that you get are actually on the Pareto optimal front. I mean, that's like a very powerful result, right? That if you, because that's the doubt I had. I mean, I can do deterministic label aggregation, I can do whatever I want. Now the question is, if I do stochastic label aggregation, like what do I get with that? Then they have shown that Pareto stochastic label aggregation actually gives optimal solution, which means to say that those models which actually use Pareto stochastic label aggregation are giving solutions which are sitting on the Pareto frontier, right? Okay, so now we had two methods. We wanted to stay in real time. We thought we'll bring the whole optimization into the modeling framework because we wanted to stay real-time inferencing. And once we brought in these two functions, what did we have? We had two loss functions, multiple loss functions, multiple labels. We saw that there could be different methods to combine the labels, to combine the loss functions. Now, I will take you through exactly how we will do this epsilon constraint method, which we call as multi-objective gradient boosting tree. And then we will also look at some example where we have done label aggregation. Okay, let me just check what am I doing on time. Okay, that's about 15 minutes. That should be good. Okay, so now, yeah. Okay, this has a lot of text and a lot of equations also, but yeah, MOGPT is like very, very intuitive. And I mean, let's take a look at how was a gradient boosting trees built. One tree would be built, the next tree would be built based on the error that it was making. Now, how did it find it was making an error? By checking with using the loss function, right? Same thing. Instead of using one loss function and making the changes with respect to that to build the next tree, make the changes, put both the loss functions together, combine the loss functions together, and based on the total error that it is making on the combined loss functions, build the next tree. Intuitive enough? So, I mean, though maybe the equations may seem like there is a lot of things going on over here, at a very intuitive level, this is all that's happening. How are you going to build the next tree? I will build the next tree based on the previous error. How are you going to find out how much error you're making? The loss function is giving me. How am I going to get the loss function? In the original case, we had one loss function, one set of labels. Now we have multiple labels and two loss functions. I will correct with both of them, with respect to both of them, and that's what we're going to do. So here, I'll just take you through so that you'll be able to appreciate this technique here. We have multiple loss functions, and we have one primary function. This is an epsilon constraint method, like how I told you here. There's an epsilon constraint method. That is a method by which we can do a scalarization, as in come up with one final objective function, and that we call as a primary objective function. And then what we have is all the other things, all the other objectives that you had, just put it as constraints. Okay. Now, what happened here is, and I think people like who are well versed in optimization theory, you would know that whenever you have such a problem, this is like a standard optimization problem where you would convert this into a Lagrangian, and then you would maximize whatever, if it's minimize with respect to the primary variables, and then you will maximize with respect to your lambdas, right? So now there is one more beauty in this technique is as to how we are going to update this lambda multipliers. Okay, so that is the way they've used this augmented Lagrangian method, which is also the penalty method, and this is also very, very intuitive. See, if you just think about it, there is some constraint that is given to you. Okay, Now, if you are making a lot of error with respect to that constraint, you will start correcting with respect to that constraint, right? And then as you start making less error with respect to that constraint, then it looks like you are on the right path. So you will start concentrating on minimizing that primary constraint. Now, minimizing the primary constraint, again, maybe you'll go off track on the other secondary constraint that were given to you. Then again, probably you will try to make some adjustments so that you will, as far as possible, try to minimize the primary constraint, but be within the track for the secondary constraint. That's exactly what is happening here. This, what you will do here is, at the end of building each tree, okay, you will find out what is the loss that you have incurred. Now, how much of the loss that you will consider for next tree building will depend on how much mistake you are making with respect to the constraint. More mistake you are making with respect to that, basically the difference is what they will take. See here, for example, this CFS minus BP, right? This is what you got now. That's the cost that you got now, and this is the constraint that you should have been achieving. That is what you should have been within the boundary with which you should have been. So now this is what you should have got. Now, larger that value, say that value is large, then actually it will act as a larger correction factor for building the next tree. Now, as you start building the tree, and with respect to which you start satisfying these constraints, then this value will start going down. That is, you don't need any more correction factors. You are doing pretty fine, and then you will only be trying to minimize the primary constraint. Okay. So I'll just take you, this is exactly what I kind of told you already. So now what happens is from one iteration to iteration, you will be building on errors, not just with respect to first one objective or one loss function, but with the combined one. And this alpha factor is that's the one which is kind of telling how much weight you should give to the secondary constraint or the secondary constraints over here. And very, very intuitively, even without knowing all the mega optimization theory, anybody would tell you are making a lot of error in that. You have to correct with respect to that. Say, for example, let's take a very, just to understand this. Say I am always getting say 100 in English, but I was doing very poorly in maths. Definitely, I will try to put in more weight or put in more time into the subject where I'm making mistakes or I'm not doing well, right? I have to learn in that direction. So this alpha actually tells me whether your learning is over or some more learning is required. So this alpha actually, first it is 0, that initially you will build a tree or whatever. Next time onwards, when you actually have a solution and find out how you did and with respect to the constraint how you are doing now, then if you are very much far away from what you are expecting, I mean, say for example, my mom would want me to get 100 in everything, okay? So now if I got a 50 in maths, then there will be a large alpha, like there is a lot of correction required, do it now. So then the alpha will start, initially what happened, that's exactly why the alpha is growing actually. So now initially you will, and alpha, to not make it very jittery, as in unstable in the algorithm itself, we can actually select what is that step size. I mean, the usual machine learning techniques that you would put. We can also select what should be the step size in updating alpha itself. Okay, now what will happen is alpha will start increasing, and then once you start meeting the constraint, it starts increasing. It's like, okay, some more correction is required, some more correction is required, lots more correction is required, and then finally you met the constraint, the alpha drops. That means you say, okay, you're good with respect to the constraint. Now you can start optimizing the primary objective. So then, and the small jitters that you may see is basically because once you start aligning with respect to the primary, once you start moving away with respect to say minimize with respect to the original or the primary loss function, it's like you're going to try to move away and you're going to try to come back. Here, I mean, in the actual production code, we would like stop it once it reaches there, so that we will not have this jittery behavior. I mean, the tree built from a jittery behavior, right? So now, this is what it is. So the primary loss function, we put a constraint. The primary loss function was here, okay? And definitely you cannot get everything. So you will have to compromise. The primary loss function will start increasing, but only to the extent that you will satisfy the secondary constraints. So now based on this, the trees have got built, and the beauty of this is, as you may like go back to the some third or fourth slide, that all this, these constraints are pretty generic constraints. They can be global constraints, because now just think about it. We have put all the data together, all customer restaurants, as in we have taken, what I'm trying to say is it's at a global constraints that we're talking about. We are building the tree from a global constraint, but it will achieve this global constraints at inference time. And I think that's the question most of you would have had, that very well we may have built this based on the training set. Will all these things hold, rather really generalized, whether it will hold in our test and production? But yeah, there are some results in this direction which will tell us that these things will generalize well. Okay, so now, so the basic intuition here is, I think, is clear, that you will just modify the loss function and then update the tree accordingly. And the technique that they are using is your augmented Lagrangian method. Now, using this technique, I mean, these numbers are not sample numbers. This is real numbers, and you can see that as we kind of increased originally, like when we had a very large constraint, like absolutely no constraint with respect to the SLA, then we had a particular AOC. But then as we make that constraint tighter and tighter, I mean, it is almost becoming random, like with respect to, you could have selected anything with respect to peak length. So now what is happening is, and that is kind of obvious also, right? You want to have a perfect selection with respect, or you want to minimize your SLA, then obviously you have to compromise on the relevance. And this example we saw before. The numbers that I'm showing now is what we see in Swiggy data. Okay. This was about one technique where we are using epsilon constraint method. The next one is, okay, just to summarize here, definitely what we can have here is, we can modify the loss functions, and since it's a pretty generic framework, you can have any loss functions. And and the only problem that you may face is, and this I'm telling from like our experience of building this, that many times you may have infeasibility, as in I think that's also true, because you will want the best of everything. So that may not be possible, and you may have you may run into infeasibility, as in some of the constraints will just not be met. So maybe then you have to actually loosen the constraint and rerun the algorithm. Yeah, so that's again that's the challenges that we saw. And yeah, this algorithm, right, of having the GBT being built from using multiple objectives is actually from a paper from Amazon by Michinari Moma, but the implementation as such will be open sourcing it soon. Like we have implemented in Scikit, and then I mean, you guys can make use of it. Okay, so the last technique here, this is pretty simple. I mean, because as such, there is nothing happening from the learning paradigm perspective, right? Only we are doing a label aggregation here, as in multiple labels are getting combined, and then that is being given to the model. And once that is given to the model, we are safe. I mean, we are in a realm where like we are champions. This multiple objective we got a little bogged down, but now if it is single objective, single label, I think we are all happy. So that's what happens once you have these multiple labels combined using the label aggregation method, then you will you will build whichever GPT model or whichever model you want to build. So now the only what do you say, the question that might arise again here is, see, when you want to build one model, you will actually take from the training samples, like you will sample it only once. Now the question will come, whether this will generalize well enough. That is, I actually took one set of labels, like first 10 samples was Y1, and then next one was Y2, and so on and so forth, stochastically. But you build one model based on one set of training data, right? So now the question will come, would it depend on how it was sampled or something like that, or am I safe in the sense that if the samples are large enough, It will generalize well. It wouldn't matter which set of sample, which set of samples I actually took to build the model. Like whether which Ys I took, Y1s I took, and which Y2s I took. Would it matter? That's the question you may. That's a doubt you may have. But then, if the samples are large enough, it shows. I mean, it generalizes pretty well. Okay. So and for this problem actually we took not only a single what do you say, single model. What we did is we tried to combine it at a second level, as I said earlier that we had a fusion model, as in we built two separate models. One was optimized. This is not with respect to SLA, this is with respect to click and with respect to order, as in a person who clicks. Now the question is, does he also order? I mean, this is more from the perspective of, this is the partner's interest coming into picture. Like restaurant, very well he may explore, but it like, dude, they're not ordering. What's the point? I'm not getting any business from Swiggy, right? So in order to protect the partner's interest as well, we not only want to have clicks, well, good, explore, but we also want the conversions to happen, right? So now this is kind of, and these two might not always, be correlated in the positive. As in, it does not mean that those restaurants who got higher clicks also, I mean, those who click may, to make an order, you will click, but that does not mean that whenever you click, you will make an order, right? So now to protect, to include those interests as well, we have kind of two objectives now. One is with respect to clicks, the other is with respect to orders. Now we built out two separate models, and definitely, yeah, here again, if we build out two separate models, we have to be careful when we take it to production. Okay, so now here what we did is we have two scores, one S1 and S2. One is with respect to the click, the other is with respect to the order. And then we have the two labels. I mean, these two are feeding as features to the next layer, and this layer is actually the one which is getting trained from stochastic label aggregation, right? So now we have these two combining. Stochastically, it will pick one of the labels, and then that is fed to the model as input, and then we get the score. Now, as you can see over here. Here, if you start off with a model which was like high on AUC with respect to the click, where you would not compromise with respect to the order, but as you start making more, as you start choosing that your orders is more important, or say for example in case of GPT, as you start telling that as you start putting more and stricter constraint with respect to the order, then you will get higher AUC with respect to the order, but then you will start compromising on your clicking itself. Okay, so yeah, and I mean in any multi-objective scenario, trade-off is there, but the question is, what is the optimal trade-off, and whether such trade-offs can be made at real time in production system. That's the question we are trying to answer. Okay, yep, I guess that's it. Okay, on time. Yeah, so the key takeaway here is, when you have multi-objective optimizations which have to satisfy some global constraints and you want real-time inferencing, then you better well put the optimization within the learning paradigm. Okay, and we also saw that in case of MOGBT, we combine multiple loss functions into one and build the model, build the trees based on that loss function. In case of stochastic labeling, we have multiple labels getting combined into one, and once you have single label, you will build that one model. Okay, so, and we also spoke about the optimality and the trade-offs that are kind of inevitable in this scenario. All right, here are the references for the papers from where we have explored these techniques. And yep, if you want to contact me, any doubts, you can reach out to me here.
Thank you so much, ma'am. This was very informative, and then that highlights in the comments also. It was as if I was sitting in my class, like classroom. It was so clear and simple.
Okay, cool. Yeah, I was super excited.
But definitely more interesting than my college lecture.
Thank you.
Thank you so much, ma'am.
Yeah. Okay. Thanks, guys.
Next we have Miss Nitali Agarwal. She's a data scientist at Infosys and community member for Co-Learning Lounge. She'll be telling us on the topic data science and supply chain management. Welcome, ma'am.
Hi. Thank you. So, uh, thank you guys. Thank you, WITS Mysuru, for giving me this awesome opportunity. And today I'm here to discuss a quick brief on data science in supply chain domain, because this we have heard about retail analytics and your sports analytics and so many things, finance, risk analytics and all those things. But supply chain analytics is also playing a very crucial role nowadays. And since I am working, as mentioned, with the Infosys as a data scientist in supply chain domain, I would like to bring this topic to your notice. Along with that, I am a community member with a co-learning lounge. So we are most engaging AI community. Our mission is to open source the education by bringing like-minded and experienced professionals together. We are working in collaboration, contribution, and to create and consume content by community itself. To know more about our community and join our community, please do check this link out, and you can search for Co-Learning Lounge and go ahead and be part of our community. So moving towards SCM, or supply chain management. First thing is I would like to tell this thing that data science has, as I mentioned, data science has entered each and every field. There's no field left, or there's no page unturned where data science is not there. So data science is part of each and every domain right now. But coming to SCM first, let's quickly understand what is supply chain management and why is it so important. So SCM is important because it increases competitiveness and customer satisfaction. In this day and age, is SCM plays an integral part of a firm's success. Efficiently running supply chain allows firms to quickly deliver products to the end user for a low cost. So in a simple term, I would put it like this, that it is a game of demand and supply. If a company, if a firm is able to maintain that gap, or it's able to do this thing briskly, maintain this demand and supply curve, then that company will get out utmost revenue out of it. And it is very important to check what is the inventory. You have to do inventory management so that your products their shelf life is not over, because for everything there is a cost attached to it. At what time you are getting your shipments delivered, what time you are getting your shipments delivered to your customer, and all these things comes under supply chain management. So it's all game of demand and supply, in short, for SCM. So now, why we need analytics in supply chain domain? If you have any problem, then only you would be able to solve it. So first, identifying what are the problem areas. So what are the main problem areas in SCM? I have listed down few of them, but there are way more to it. Everything can't be listed down. So let's have a quick look over here. First of all is lack of synchronization between planning and execution. So definitely any business, you need to have a good synchronization maintained. Otherwise, things will not move. There are like two wheels of a vehicle that needs to move together. One is your planning and another is execution. So that's the foremost problem, not just in SCM, but in every domain. And SCM being primary, these are two pillars for SCM. So definitely it faces more challenges. Now, second one is lack of real time data visibility, as data is increasing massively. So that's one of the reasons that we know how data is growing. It is growing like means leaps and bounds it is growing. So to maintain that data, it is very, very necessary to get the visibility of that data, get data, drive insights from that, and then further process from there. So that's one of the things. Second is irregular reviews of safety stock levels. So definitely in supply chain, you have to check. I'll give you an example. What happens if you have any customer who is asking you to ship one product to another product? That also comes under supply chain. Now, if that product is hazardous material, what you will do? You have to get extra. You should be paid extra for that. You have to cover that, or you have to insure that part also. So that's one of the reasons that reviews are not done properly, pricing is not done properly, and that's where the problem comes. price volatility. So as I said, it is in continuation to the third point itself. Production line imbalance. Production line imbalance means how many you are adding. Means what your inventory, how many you are what is the amount that you are dispatching, what's your demand, what's your supply, how you are maintaining all these things. That's another question that comes into picture when you have supply chain management. And with every inventory there is a cost associated, so that needs to be reviewed very thoroughly before generating that huge amount, or before producing have the production done for that huge amount of material or product. So how data helps, or how data science helps in this field, listed down again, few points to it. Quick ones: revenue growth. Definitely, when your production line, when your production or planning or execution, your inventory, all are well versed, all are coordinated together. That okay, this is the forecast. How much inventory I will need in the next time? How much I should produce? What should be the pricing for that? Definitely, you will have a good revenue, because your debt would be reduced, your unnecessary cost would be reduced, and your revenue will increase. So that's first point. Second is margin optimization. You are pay any business works on the basis of profit and loss. What is this profit or loss? This is the margin that you are having. So any company, any firm who is supplying their goods or who is producing their goods, that's a margin associated from production till supplying that to the user. Now over there you have to maintain, over there everyone has to maintain, or any company has to maintain the margin. So data driven insights or data science helps you over there to optimize your margin, to get the best out of it, to forecast in the best range, and based on different parameters, different aspects of parameter, it is decided. It is not just one parameters. Might be it is the holiday season, or might be it is some what kind of material it is, who's your shipper, and all these other requirements that might be there. You have demand forecasting, a very important thing. If you are able to forecast what is your demand, you will be producing that much. So again, linking it back to the first and the second point, all are interlinked. Your revenue will increase, your margin will increase if you are forecasting your demand correctly. Correctly isn't, there would be some error margin. I'm not saying it would be 100% accurate, but you have to reduce that error margin and do a better demand forecasting, so that you don't have less inventory also, so that you are losing your orders. You should not have great inventory also, so that you are not able to means unnecessary things are piling up in your stock. Logistic analytics, if you are on the in supply chain, if you are supplying any goods, so what are your logistics, what are the maintenance vehicle charge, what are the charges for your vehicles maintenance and all these stuff. So they are not just any small vehicles, they are huge tons of vehicles that you would be having. So all these things again come into picture. What are my carriers available, whom I can send it across, what is the price that I have to pay to it. Again, linking it back to revenue and margin. All these things add up to your margin. It will increase or decrease your margin, and hence it will increase or decrease your revenue. Last but not the least, working capital improvement. Definitely, what is your intake of the capital, how much you have in store, and how much you should keep in store, so that for the situation like this pandemic, you are able to uh, uh, I would say you are able to forecast it correctly, and you are able to use that capital. So means what are your resources available, what is your in terms of money, how much capital is available with you. So all these things are very important to understand from the point of view that how supply chain works. So supply chain analytics in short is not just getting forecasting the demand. It is not just forecasting your revenue or margin. It is way more than that. You have to join all these elements together. You have to come up with something on each side. You have to forecast demand, along with that you have to forecast your revenue, you have to optimize your margin, you have to see how much resources you are using, you have to get best out of those resources, you have to see logistic management, what is the what are your origins, what are your destinations, how what kind of material that you are producing, what kind of material you are supplying. All these things you have to use. This is complete supply chain analytics, and it's way more than that. So this will help any company grow if it is data driven in the sense, if you have historical data, you get historical data. Now what was the demand previous to that? Now in this pandemic situation, if you see, every and all model is going to fail because you are not able to forecast what are the demands, what how much you should definitely you might be having a lot of inventory, might be you are not having that lot of inventory because of this lockdown situation. If we see, people were buying stuff in bulk, so many things were out of stock also. Why it happened? Because all these things were not being forecasted. This situation was not being forecasted. So that's very important to understand that how data driven insights are necessary to make your model or make your firm or business work or run smoothly. So that's it from my side, guys. Over to you.
Thank you so much, ma'am, for this informative session and for sparing time on a weekend. Thank you so much.
Thank you.
Next we have Ms. Altanai Bisht. She is VoIP and telecommunication software engineer at Airtel. She will be going on the topic ML implementation on VoIP. Over to you, ma'am.
Thank you. Is my screen visible?
Yes, ma'am.
Awesome. Hello, everyone. I'm Altanai Bisht. I will be talking about machine learning in voice over IP. We've seen that owing to the last disruptions, the pandemic situation, there was a huge boost on VoIP field due to remote learning, work from home, other unified communication collaboration systems came into rapid use because people were trying to communicate intra-team, inter-team, inter-company, etc. So I have been in this domain since the last 10 years. And I have worked on many real-time communication systems, many CPaaS, communication platform as a service platforms, their SDKs. I have also authored a book called as WebRTC Integrators Guide, which talks about integrating WebRTC with different kinds of landscapes, IoT landscapes, CRM landscape, e-learning, augmented reality landscapes. And I have also worked on a couple of open source projects like Ramu Droid. It's a project where I use robotics to pick up litter from the roads. And WebRTC Dev, it's an open source implementation of WebRTC protocols, which are updated as the new RFC is released by W3C and things like that. And I'm also an avid freelancer and a blogger. And coming to what we are going to discuss today, we are going to see the three major parts of a communication system. The front-end part, which is the WebRTC part, which is hosted on a web server. The intermediary VoIP service provider part, which is mostly comprised of SIP servers like Asterix, Camilio, FreeSwitch, and the backend telecom carrier part, which is the telecom providers like Airtel, there's Jio, there's Vodafone, British Telecom, AT&T, Sprint. These are all the telecom carriers. All right. So ML in the first part, the front-end part. It's almost already part of WebRTC stack, like echo cancellation, noise suppression, jitter control, image stabilization. These are built inside the WebRTC stack, ready for us to use. And then there's voice activity detection, like this is the waveform for yes, okay, and audio fingerprinting, which is actually a supervised learning approach, which identifies the speaker based on a pre-trained classifier. Echo cancellation. So whatever I'm speaking should not be fed into the microphone of the listener. Otherwise, it'll create a never-ending loop, right? So this will create echo. So that way. And face detection. So this has been around for some time. And background substitution, voice modulation, it has actually come into mainstream use recently with social media apps. And let's talk about the telecom carrier side's implementation of ML. So subscriber churn, very, very interesting area and of high concern since Jio entered the market in India and South Asia. There was a lot of churn from service providers like Vodafone and Idea and towards Jio, which also kind of benefited other providers like BSNL and Airtel. But if we use the open data set from Kaggle, we correlate and do some exploratory data analysis. We see that among the features which are negatively and positively related with churn are short-term and long-term plans. So long-term plans indicate less churn, and short-term plans tend to go towards high churn. And things which are not related are gendered. All right. So actually, from a telecom provider's perspective, it's more economical for them to retain their existing subscribers than to onboard new subscribers. All right. So they are consistently trying to do some feature analysis and identify subscribers that may leave, and they will try and give freebies like Netflix and Spotify subscriptions to them to stay put. All right. So other areas are basically around call quality monitoring. So of course, user satisfaction is driven based on call quality. So we need to do a lot of predictive analysis in real time as the call is going. So various features are can be used to do that. Interestingly, language is also a factor. So the MOS score from let's say English language to French language to Thai language will differ for for the same call setup. And so E model is an application standardized by ITU, which is international body standardizing almost all telecom processes. And in parallel to that, there could be interesting applications of machine learning models which can predict MOS score well in advance, and they can be used in real time to, let's say, modify the buffer length, all right, or modify the network parameters in real time to try and countermeasure the disruptions in the call that may be happening. And so yeah, like I was saying, since MOS is such a defining factor for a call, it's very important to see the effect of different features on MOS score. Like this particular graph is mapping different audio codecs and some video codecs with respect to packet drop. All right. So here you see that some codecs may not be performing that great when the packet loss is 0, but they perform relatively better when there is high packet loss. All right. So this blue ILVC performs better on high packet loss, whereas it may not be performing as nicely on 0 packet loss. And so similarly, so on the like how we discuss the telecom carrier perspective, we come towards VoIP service providers. So VoIP service providers are in a very tough position because they have to balance the revenue from telecom carriers and provide a lot of security interactive features to the front end providers, right, and bridge the calls, and also give a lot of cutting edge features to keep the front end users and developer and these SDKs happy. So these are some of the mind you, this graph is from 2011, so it's not very relevant right now. But earlier, these protocols were using, these platforms are using their proprietary protocols. So their, like as we saw in codecs, their performance was also greatly affected with packet loss because of the underlying protocol and codec that they were using. So the effect of that on MOS score. And yes, anomaly detection. So VoIP providers face a lot of fraudulent calls, a lot of them, and mostly people are trying to exploit the local and international calling rate differences. So there are rapid calls, there are malicious calls routed exactly to find out. Let's say there are premium rate numbers which VoIP providers use to find out that premium rate number, or to find out that perfect IVR flow to target or initiate some kind of an action. So anomaly detection systems are specifically designed to detect these malicious system call sequences and intrusions. And other interesting applications are prioritization of calls. So for example, a robocall is not of as high priority as a genuine user-to-user call. And geographical routing. So look at this call. So this call originates from somewhere in Europe and goes to Australia. So it's routed through somewhere in Taiwan. So this is all right. But this call, if you see, it originates and is destined to South Asia, but it is routed by a server in Europe. So this is a hairpin scenario. This is wrong. All right. So these kinds of geographical routing to find out the nearest media server or relay point or proxy for this call, they are also driven by machine learning in real time. And yeah, call pattern mapping is an interesting area as well to have high response time of the calls, to remove the additional overheads and latency that comes with a lot of authentication and background checking. You know, when I call user B, there are a lot of background checks that need to be done, whether I have account balance, whether it's a genuine call, whether it is whether it's a permissible call, whether I am meeting the call counters. So they can be bypassed if it matches a pre-specified pattern, so which increases the response time. Some unexplored areas like etiquette analysis, regulatory analysis, like how the call should be started from with greetings, should be ending with courtesy remarks, which directly affect the sentiment analysis of the user, reputation of the brand, and regulatory analysis like how the customer care executive should not be asking for pins or passwords. So they can also be built with speech engines and transcription services and automated. So that's there. Telecom fraud. So sort of related to intrusion in a way that so fraud is basically revenue gains. All right. So the fraudsters make scripts to initiate calls via the VoIP provider systems, and that is connected to, let's say, a high cost destination, the country where the call rates are high. So in this kind of a call scenario, the VoIP providers actually loses money in routing these kinds of calls. All right. So what the VoIP providers need to do is identify such fraudulent sources of calls or such destinations and try and block these numbers, but which are trying to exploit its premium numbers or SIP trunks. But fraudsters are way ahead. They implement something called as multiple transfer or blind transfer, where they switch the numbers, destinations or sources rapidly. So it's very difficult for the voice service provider to identify or block such users. And that is why it needs to have an intelligent and self-learning algorithm which does this for it. And other kinds of areas like one ring and cut. So this is like giving a missed call where the user thinks that I've got a missed call, so I need to call back to this number, which in turn generates revenue for the fraudster. Blind call transfers, like we talked. Call cards vishing. Vishing is phishing attacks, but for VoIP. All right. So somebody tries to impersonate a bank employee and tries to get data. And vomit attacks. So it sounds gross, I know. It's like replicating some pre-accumulated call, records into another call to make that sound genuine. All right, spit attacks. It's like basically spam calls. These are the areas where ML can be tightly integrated in VoIP. All right. Some areas which are actually actively under research are countermeasures to these fraudulent attacks, like call signature assessment, risk assessment. So before releasing a new feature, a lot of VoIP providers do risk assessment of how this particular feature can be exploited by hackers, for example, and noting that most of the hacks actually occurs in off hours when they are less likely to be actively monitored, right? So, for example, on weekends, so they know that it will probably go unnoticed for a little longer than it would on a weekday. And Similarly, using the same backpropagation neural network to detect how they detected mail spams, similarly to detect spam calls. All right, honeypots. So very interesting. So instead of routing an application to a block list, all right, they can be actually routed to a honeypot. Honeypot is a VoIP server which responds to a call by an attacker as a genuine user, like using pre-recorded messages and PCAPs, and this will basically analyze the behavior of the attacker so that we can have a better a response next time when it's a similar attack. So this is a very interesting area of recognizing attacks using ANN and countermeasuring it, and that's brings us to the end of the presentation. Thank you so much for giving me this opportunity to speak here. Over to you.
Thank you so much, man, for being a part of this. And I have to thank everybody to be a part of this on a weekend. Like we have to be there in the office for the entire week and then joining us for on the weekend. Thank you so much.
My pleasure.
Thank you. Next up, we have Miss Savi Jain. She is founder and CEO at Kofiato. She'll be going on the topic myths in AI. Over to you, ma'am.
Hello everybody, nice to have you all here. I'll be sharing my screen just a second. Okay, so welcome to the session, and my session is going to be all about what people think is machine learning and what people think is good to have, but actually that does not really work. It is going to be about myths in data science. It is going to be a bubble buster for all of you, so stay tuned. Okay, so you might have done some online courses, self-paced, tutorial courses like Andrew NG course on Coursera, or specializations on Udacity or any other online MOCs. But that does not really make you a data scientist. You have to like work on a lot of you have to really work on a lot of hands-on exercises on some real-world examples that would like actually enhance your experience in the machine learning field. Courses they make you aware about whatever there are concepts to learn, but research, math, and practice that will make you like actually stronger in your work. You must be like, since you are already here and you might be inclined towards machine learning and stuff, so so now I'm going to cover all the myths related to what predictive modeling process has. We might assume like whenever we practice stuff on Kaggle or some readily available data set, we generally get clean data sets. So that is never the really case in actual industry cases. You have to do a lot of churning, you have to do a lot of data wrangling parts to improve the quality of data. There might be there might be missing values, there might be random undefined terms, there might be some useless columns. So you have to do a lot of data wrangling to like get the actual clean data set that you directly get on Kaggle. Okay, so this is the kind of inference that I wanted to make. This is like if you like potatoes, you might so imagine that potato is your data set. If you have potatoes, you might churn out something after processing to make French fries. You might even make potatoes, like you might even make potato chips, but your data is only as good as you like clean it or provide it. It is never going to actually churn out gold if you provide a bad data set. If you go on like Python, R, TensorFlow, Hadoop, Spark, everybody in the industry would tell you, you need to do this, you need to do that, you need to learn, you need to know every kind of thing. You have to be an expert in something. But reality is, rather than actually being the master of tools, or maybe PyCharm or TensorFlow or specific tools, you should really like aim to become a problem solver. If you are a problem solver, then technology does not like really matter. You might like just you'll be able to mold yourself into any kind of technology. Example, if you like see this, let me know in the comment section if you know what this formula is all about. If you're like, you might have heard of linear regression, gradient descents. So in theory it all looks good, but do you really know the math behind of it? Because scikit-learn calling is a 2-line process, 4-line process, but that does not really solve any of the problems. You have to know the math behind the algorithms and to actually make the projects in real world. You have to like have domain knowledge. You have to identify what is important respective to your specific use case, and only then you will be able to actually know what your data needs and what you are going to churn out of it. If you like are specifically interested in Ubuntu or Linux platforms, so, and you are like really a fan of terminal, data science is not just black and white. It is all storytelling. You have to like create the entire story out of your data. You have to present it in the right kind of use case. The input surely can be grayscale, but your outputs can be colorful. That is what I meant by like data visualization. Let's talk about the important skills in data science. Uh, so communication is mostly for project managers or people who are stakeholders, but that is not really the case. Even the data scientist folks or even the developers should be able to communicate what they're really trying to tell, so that the people who form the bridge between the data science and the outer world are able to like connect to it. You have to be good at communication, your verbal communication, your visual communication, your writing, the sense of code quality, everything. You have to be like a good communicator person. Your data set, like you can so mostly visualizations we consider it is for marketing bluff, but it can be like verbal fancy marketing bluff. It is not that. It's communication is a must skill to have. If you like, you might have seen a lot of people writing in blogs, a lot of people making in content, but you might feel intimidated about it. But it's not that just the case that only PhD folks or people very experienced can write the blogs. You should always document your work. If you document your work, you know what all you are like doing, and it's step by step. If you are able to explain it to somebody else, that is the only way you can feel that you are doing your best work. So all of these years, what has changed all of these years? There was like same math, there was same machine learning, same concepts before, but now it like people have more access to faster computation. The open source community, you have like access to anything at a click of your search engine. You have like online communities, you have local open source communities to like reach out to wherever you need help. You can like connect with people, you can talk to your communities and get your problems sorted. You can even get internships, you can get jobs, everything through the community. So that is the easiest access you get to like solving the problems. That has changed all through the years. That brings me to my end. I like, if we need, we can take any more questions.
Thank you, ma'am. As of now, there are no questions, but definitely this was a Mythbuster session. Like I am the one who goes into that loop of learning through Audacity, Coursera, and Udemy and other MOOCs. And now I realize that I'm just at the I'm on the surface level. So I'll definitely try to implement all those and definitely try to document the work. Like that is what I've been working on things, but I don't document it. So I'll keep all those points in my mind. Thank you so much, man. Next, we have Miss Shilpa Garg. She is the lead AI consultant at Magic Software. She'll be going on the topic Dialogflow's beta features. Good afternoon, ma'am. Excuse me, ma'am. Can you unmute yourself? Uh, yes, ma'am. Sorry, ma'am. It's not audible.
Am I audible?
Yes, ma'am. It's audible now.
Okay, thank you. Hi everyone, this is Shilpa from GDG New Delhi and WTM New Delhi. Today I'll be talking about Dialogflow customer experience. So you guys must have heard of Dialogflow earlier, right? So today we'll be talking about Dialogflow customer experience. What is the difference between both of them, right? So we'll be talking about that. So there is a new Dialogflow. I would say Dialogflow CX. We call it Dialogflow CS, which has been launched recently, and it's in beta right now. And most of the features are in beta. But we'll be talking about that so that we can get a glimpse of it, right? What is Dialogflow ES? So ES is the initial Dialogflow which we were using. We call it Dialogflow Essentials. Now it has been renamed to Dialogflow ES, which is Dialogflow Essentials. So it is, as we all know, it is NLP based system, and it is powered by Google AI, and it is supportive of like plus to 20 plus languages right now with a single click and you can even integrate it with multiple platforms like Google Assistant, like Twilio, like Facebook, and there are many other platforms which you can I would say integrate it with. Apart from that, there are multiple single click integrations. Apart from that, there are SDKs available in multiple languages, right, which are available in Dialogflow. But what is new in Dialogflow CX? Why they have launched Dialogflow CX? I'll be talking about that right now. So I'll be just giving you a glimpse of Dialogflow CX console over here. So as you can see my screen, okay, let me just. Can you guys see my screen?
Yes, ma'am. It's visible.
Okay. So as you can all see on my screen, there is this Dialogflow CX console. Earlier Dialogflow console was so if to log into Dialogflow, you just need any Google or Gmail ID with it, right? So this is the earlier Dialogflow console which is opening right now. This is the earlier Dialogflow console which you can see, right? But what is different between both of these? So here you can see all your GCP projects. I'm just opening one of the GCP projects from or which I have uploaded my agent, right? Major difference between earlier Dialogflow ES and CX is in Dialogflow ES, you can only have one agent per project, but like Dialogflow CX gives us a capability to have more than one agent, like up to 100 agents for a single project. That was the biggest, I would say, backstab of Dialogflow ES, which was initially when people were not able to build multiple agents in a single project and don't integrate it, right? Over here, we can integrate multiple agents, like up to 100 agents. So here, if you click on this pre-built agent, you'll be able to see 6 pre-built agents, right? Out of this, with just one click, you'll be able to import any of the agent, right? I'll just go to my dashboard again. Here I have taken out this flights intent already, flight agent. So this is the main thing which we need to focus on. We see, so this is majorly based on the flow of intents. Dialogflow customer experience, as we see, is majorly focused on the customer experience who is using your bot, if your bot is in production, right? So earlier we cannot, we need webhooks to collaborate between multiple intents. But as you can see my screen, and as you can see over here under start intent, there are multiple intents which have been collaborated, right? If I want to see between these intents, what I just need to do is I'll just go back to my left menu. Here you can see multiple, there are two options. One is build and one is manage. You just need to click on manage and you'll be able to see all of the intents, the entity types, the webhooks, and even you can see the test cases. You can build your test cases on the platform only, and you can directly test them from the Dialogflow console. You don't need to build any test case using any other testing tool, right? Even you can validate your use cases over here. Apart from it, you can see the analytics, like whosoever is using your agent, what type of questions has been asked. All this is present over here in the analytics section. The major feature of this Dialogflow CX is this one-click telephony. It is now compatible with Avaya and audio codes. In Avaya, what you can do is, as you must have seen, there are IVRs available in multiple companies, in customer experience, in customer support, right? So right now, what you can do is you can directly connect your agent with this IVR, and now people will be able to, if you have connected your agent will talk to people on IVR. That's what the major, I would say, the wow factor of this Dialogflow is. If I go to these intents, you'll be able to see all the intents, and under these intents, everything is same. Like you just need to give the intent name, and then you just need to give the training phrases, and you just need to enter those training phrases, right? And you can just do some agent settings from here. So if we go to this agent settings is very similar to the Dialogflow earlier agent settings, as you can see over here, right? So what we can do over here is we can change our agent name. We can even enable or disable the Stack driver login. We can even choose what type of NLU we want to use. As we all know, in NLP, NLU is the most powerful feature whenever we are dealing with like chatbots or something like that, right? So there are three types of NLU available: standard NLU, advanced NLU, and custom NLU. You can choose any of these NLUs, and you can train your agent accordingly. You can choose a threshold which you want to keep for your intent trigger, right? You can even select if you want to auto train your agent or not. If I go to speech and IVR, you can enable or disable the speech in adaptation, which means that people will be able to talk to your agent directly or not talk to it. You can choose that, right? Even if you want to share your agent with multiple people and give them different kind of access, you can just give them that access. As we all know, whenever we are coding or whenever we are doing any kind of coding, we maintain versions of that code as per our releases, right? Now we can do that in Dialogflow CX as well. You can maintain the versions of your agent. You can also choose the environment for your agent, environment like prod environment, dev environment, UAT environment. All the environment you can keep it over here, and your agent will act accordingly to that environments. And in the advanced section, there is sentiment analysis. You can enable this. Right now, this is in beta. Let me tell you again, right? But these are the very powerful features of Dialogflow CX. Sentiment analysis give us the sentiment of the user. When the user is talking, it tells us that what is the sentiment of that user. The sentiment is positive, if the sentiment is negative. So that is what sentiment analysis initially is. If I come back to this general, this is a very basic settings. You can just set on your time zone and all that stuff over here. So if I come to these, so this was all about the settings portion, right? You can create new intents from here, right? That is very similar what we do, which we used to do earlier. Even if you want to test your agent, it is similar. The console panel over here is the same. You can choose the environment. Right now I'm working on the draft environment, which means dev environment, right? I have not published my agent. That's why it is showing me draft. And you can give your intents over here, howsoever you want to test your agent, howsoever you want to talk to your agent. In that way you can do that. And you can there are multiple features available. You can turn on and off webhooks from here. So webhook, as we all know, there is a, I would say, a single channel to connect to a code. In that case, if you want to give some custom things to your code, in this way you can give it through webhooks. And you can save any test cases. If you save any test cases from here, you can directly see all those test cases in this console. right? And again, webhook portion is the same, which was earlier in our Dialogflow ES, right? Coming back to the build portion over here, just taking a 2 minutes more as time is going up, right? So this is totally based on the flow, right? If I just see this flow at once, I'm starting here. If say I have taken this flights agent where I want to book a flight, right? I have taken this from start. I say hi. The bot will say, okay, I can do this. What do you want to do? I'll say I want to book a ticket for me. So this flow will come over here in the find ticket. So there are multiple intents which are given over here under this, right? There you can even give your conditional conditions over here. You can even set the parameters, that which all parameters you need for that. Here confirmation number is there, what is the name of the passenger, what is the email name, right? So everything you can give. Apart from this, there then say you have given all these details, then it will ask you, do you want to book a one-way ticket or a two-way return ticket as well? So then if you want to book a return ticket, it will go to here, collect round trip ticket information, right? If you want to book a one-way ticket, it will display your one-way ticket parameters. It will check out for the available flights and the available airport from where you want to board your flight. And then you can it will show you the chosen ticket it has chosen for you. You can even change that. If you're okay with that, you can directly do the payment. Here we can just take all the parameters of the card and then use a webhook for that to give the final payment, to pass it to the final payment gateway. Then our bot will ask us, is there anything else which you want to do, and then the flow is ending, right? So this I would suggest you guys should try it. Whosoever has worked with Dialogflow ES will find Dialogflow CX a very, very powerful tool. Every limitation, I would say, of Dialogflow ES has been overcome in our Dialogflow CX. So that was all from my side. Thank you guys. You can connect me over here on LinkedIn or Twitter, right? Stay connected. Thank you.
Thank you so much, ma'am. I am
Thank
sure
you.
they'll get connected on LinkedIn. Thank you, ma'am.
Thank you. And if anyone has any doubt for Dialogflow, they can just ask me over any channel, LinkedIn or Twitter. They can ask me on any channel. So I'll be happy to answer. Thank you so much. And thank you guys for
Sure.
giving us this opportunity. Thank you.
Thank you. Next up, we have Miss Priyal Jain. She is front-end developer at Bugo, and she'll be going on the topic community building. Good evening, ma'am.
Yeah, thank you for introducing me. Now, hello everyone. So, here I would like to introduce myself first. I Priyal Jain and I am representative as Human Techmakers Indore and co-organizer of GDG Cloud Indore. So, today I will be going to deliver my session at community building. This is a very interesting topic. Like, what do you think about? What do you mean by community? Community is all about people, all about we get to learn, share, connect. When we grow together, when we build a team, when we share the knowledge, when we organize the sessions, workshops. So how we build the community, the most important point is, like, as we see the many of the communities is not about is I belong to the women tech makers, so I'm talking about women tech. It's about any of the technical community. So for building the community, there are certain steps which we need to follow to build and grow the community. Like, the first is most important is goal. A goal is very clear. What is the purpose of the building the community? And your purpose is clear. Do you know that you have to reach that particular level? What are your plans? Have you taken all the steps and measure to grow, to share, to build the particular plan to the community? Then the construct. How to build the community to the next level? Construct is something like building to grow the networks and the connections. Have you got the particular recognition? Are you encourage and motivate to the people? Because a community doesn't work without the people. As we have the lot of connections, lot of networks, lot of appreciation, it would need to grow the net, to grow and nurture the community. So building the community is not very easy. Like if we want the people, we want the team, we want the networks, where a purpose is very much clear for building the community. As I'm talking about my journey, I am also organizer of WTM Indore. It's a community of GDG Indore. So how I become the part, how we do, how we grow. So we organize the events. Our purpose is clear. What are the themes? A plan is clear. What steps we are going to take? What are the networks we have to reach to the next level? So here are some glimpses which I take the hands-on workshop as we organize the workshop in the WTM Indore and share the knowledge to the people. Like the various event like technologies, like the various mini technologies that which we are working on, like Java, Android, and so on. So community is very important, and without the building the team, without the people, we can't grow. The most important thing as purpose is clear, and you have some very good leadership skills as well. Thank you. You can reach out to me on LinkedIn, Twitter, and GitHub.
Thank you so much, ma'am. And definitely they'll reach out to you. And thank you for sparing time on a weekend. Like, this is the
Thank you
most
so much.
precious weekend. Okay. Thank you, ma'am. Uh, we'll have a brief pause. We are waiting for the next speaker. Stay tuned. Next up, we have Miss Nidhi. She is the founder, CEO, and data scientist at Factual AI. She'll be elaborating on the topic AI in telecommunication.
Hey guys, I hope you all are doing good and keeping safe. First of all, I would like to thank Women in Data Science Master for giving me this opportunity to speak in front of you all. I hope you find this session informative. Um, a little about me. I am Nidhi Gangrade and I have been into technical education for more than 12 years and worked as a data analyst in an IoT based product company, Zephy. Currently, I'm heading my own startup, Factual AI, in edtech space and pursuing my PhD in machine learning in 5G cellular networks. As the duration for this talk is really short, I would like to give you an intuition on how AI and ML can be applied in telecommunication domain with some use cases and the research work or ideas. Um, in my previous organization, I have worked on the projects on recommendation system and predictive maintenance for the cold chain systems in retail domain. It's worth to mention that predictive maintenance has got a very major use case of AI and ML in multiple domains like healthcare, retail, core engineering domain like mechanical, civil, uh, telecommunication, and so on. Predictive maintenance is basically the process which helps us to predict the remaining useful life or the fault status of any device or equipment well in advance so that we can proactively fix the problem in order to save the time, inconvenience, resources, and the assets from any big loss or issue. We can predict the failures status of the devices by using the machine learning classification algorithms, and we can predict the remaining useful life by using the regression techniques. In our project, we had built an ARIMA model on the time series real-time sensor data to detect the anomalies in the freezers or the chillers. which were responsible to hold the perishable food items and medicines worth of thousands of dollars, and we helped industries in controlling the wastage of the food items and the medicines. Moving on, when we talk about the latest technology stack, we talk about the big data, IoT, artificial intelligence, and 5G cellular networks. Apart from the RFID tags, the social media network data, and the IoT data, cell phone tower and the wireless sensor network devices are also considered as the huge sources of generating the humongous amount of data, namely big data. Let's discuss some of the technologies which are predominantly used in 5G cellular network, which are the heterogeneous multi-tier networks, namely millimeter wave, a massive MIMO, small cell, beamforming, non-orthogonal multiple access, and mobile edge computing technology. Millimeter wave technology uses the millimeter wave band, ranges from 30 to 300 gigahertz, and this band supports really larger bandwidth and thus very high data rate in the range of Gbps, but it comes with certain limitations or drawbacks. That it supports only the line of sight communication, suffers badly from the attenuation and blockage, and it provides you the very limited coverage, and thus uses the concept of small cell technology with the low powered cellular radio access nodes, which provides the limited coverage of about 10 meters to few kilometers. It uses the massive multiple input, multiple output antenna technology, which essentially groups together multiple antennas at the transceivers to provide the better throughput and better spectrum efficiency. Beamforming is another promising technology which is used by the 5G cellular networks, which uses an array of antennas that can be steered to transmit the radio signals in a specific direction, unlike the omnidirectional antennas. So user A, B, and C are served with the beamforming patterns, and thus this leads to lesser interference and less energy consumption, and thus the high data rates to the end users. Non-orthogonal multiple access technique uses the non-orthogonal carriers with permissible interference, where each user operates in the same band at the same time, but they are distinguished by the different power levels. Mobile edge computing is another concept that enables the cloud computing capability and an IT service environment at the edge of the cellular networks. So here you can think about applying the unsupervised machine learning algorithm, namely the clustering algorithm, where the different users coming up with the different data rate application requirements can be clustered together and accordingly could be served through this mobile edge computing technique. The users coming up with the very high data rate application requirements like video conferencing or augmented reality. They can be clubbed together or clustered together and can be prioritized high compared to the users coming up with the low data rate application requirements, which can execute the computational task locally. However, the users coming up with the high data rate application requirements, they can be assigned to offload the computational task executed at the edge server. This is how the 5G heterogeneous multi-tier network architecture looks like, which divides the whole architecture into the multiple layers of multiple tiers, starting from the macro cell till the device-to-device or vehicle-to-vehicle communication model. So 5G is coming with a lot of potentials and the possibilities. In all of the 6 technology what we just discussed, you will find huge use cases of AI and ML. Briefly, the machine learning provides the smart and fast decision making for improving the system performance, including reliability, energy efficiency, dynamic resource allocation, mobility management, power control, and the quality of service. So when we talk about the different tasks where AI and ML could be applied in the 5G cellular network, broadly you can categorize as network design and planning task, which includes the intelligent cell site planning, network intelligence for improved cell capacity and coverage, power management, traffic prediction and management, network optimization task, where you talk about the dynamic resource allocation, interference estimation, self-healing or self-organized networks, which use the concept of reinforcement learning or Q-learning. Network operation and maintenance task majorly focus on the failure detection, the predictive maintenance, the root cause analysis, and so on. Talking about some of the use cases of AI in telecommunication industry, the very first use case is about the churn prediction model. For any telecom business analyst or decision maker, they put more focus on retaining the existing customer rather than attaining the new customers, which is a costly affair, and they want to do the required behavioral analysis of the customers which are likely to churn. They want to find out the reason why, the reasons for the churn, so that accordingly they can improve the marketing campaigns or recommend the relevant offers or the promotions to the group of customers who are likely to churn. Another very promising technology which is used by 5G heterogeneous network is cognitive radio, which basically talks about using the underutilized TV spectrum or the white spaces for the device-to-device or vehicle-to-vehicle communication. And it uses the spectrum sensing technique for the same, where the carrier is being continuously sensed by the secondary devices. When the primary user is not using the radio link, then the secondary user can pitch in and use the link. But once the primary user reappears, secondary user is supposed to leave the radio link. So this is quite challenging in the multi-radio environment because it has to discriminate the several different radio systems, and auto-encoded neural network can be used for the automatic feature learning in this case. And the machine learning classification algorithm can be used in order to classify the input signal as a primary user or the secondary user. In vehicular communication or applications where you have the low latency or the reliability as the main requirements, AI and ML can be exploited here with the help of the supervised machine learning algorithms. We can predict the latency requirements, whether it is getting fulfilled or no. We can predict if a packet can be delivered within a desired latency window. And when we talk about the vehicular ad hoc networks, which are the next generation transportation system or autonomous driving vehicles, we find the ML use case widely because these networks need to intelligently adapt to the uncertain radio environments rapidly and efficiently with the reduced complexity and the latency requirements. So this is it from my end, and you can get in touch with me. These are the contact details, and have a nice day. Thank you.
Thank you so much, ma'am. Next, we have Miss Dikshita Desai. She is the founder at DataDen and also the ambassador for WiDS Goa. She will be going on the topic AI and astronomy. Good evening and welcome, Dikshita.
Thank you. Thank you so much for that lovely introduction.
I skipped the honorary on your request.
Thank you. Okay, so let's get started. The topic for today is dark sky mysteries with ML. So it is about how machine learning is being used in the field of astronomy. We're particularly looking at the use case of what the Google Brain team did, especially Chris Shalou, of how he managed to come up with an artificial neural network that was able to detect exoplanets in space. So let's get started. Not so long time ago, but far, far away, Alan Turing said, what we need is a machine that can learn from its experience. Today, machines can see, hear, and learn. Welcome to the future. The thing about astronomy is it compels the soul to look upwards and leads us from this world to another. And you cannot help yourself from thinking that, are there more planets? Is there more life on other planets? And thousand other questions that these twinkling stars can, ignite in our minds at night as we gaze them. So what would happen if we were to combine the two of the most interesting topics, that is astronomy and machine learning? Let's say we could create magic, because astronomy as itself individually is like magic, and machine learning or AI itself is like the new magic that we have. So together, when you compile these two fields, there's actually some crazy magic that's happening. So let's have a look at it. But before we get started, I said that we're talking about the discoveries of new exoplanets. But what are exoplanets, right? So we have sun. Around sun, we have our planetary system. So those are called planets. Any planet which is not belonging to our solar system, that's called an exoplanet. So planets that don't belong to our solar system or are not revolving around the sun. The way we are going to go about with this is the data that is needed is coming from the Kepler telescope. The Kepler mission was aimed at discovering new exoplanets, and hence the telescope was serving the same purpose. Training is being done in this model with the help of convolutional neural network. And later, once you have the predictions, the astronauts or the scientists or researchers, they go ahead analyzing this, and that is when you have the Jadoo Mil Gaya moment. Let's have a look at this particular animation. It's really interesting. So you see there is a star at the center, and as the planet is coming in front of the star, the graph is about brightness and time. So the brightness is maximum, the planet blocks a certain amount of light, and then again the brightness goes to maximum. So this is what happens when a planet comes in front of the star. What we are going to do is we are going to observe stars, and we're going to understand the flickering or the dimness of the light, of the intensity of light, or the flux. The flux changes is what we're going to monitor, and this is what our data set is going to look like. So the data set is graphs like this, and we analyze that the intensity of flux which has either dropped or has increased, is it because of a planet, or was it because of some extraterrestrial object, or was it instrumental fluctuation from our side? So all these things also have to be taken note of. Initially, this observation had to be done manually, and it would take a lot of time. But once this entire process got automated, through this one model itself, there were 3,000 new exoplanets discovered. So that's a huge number. So that's the magic about this particular model that we'll be studying today. But when we're talking about how machines see and how we see, it's very different. So for a human, it's going to be like a star, and the brightness has changed, and we would record it like that. But or we could see the graph that's changing, etc. But when it comes to computers see this as zeros and one. We already know that. So the convolutional neural network, so the data that we are feeding here is for the convolutional neural network. What actually happens is that, let us have a look at this here. Where is my pointer? Yes. So you can see we have created a 5x5 window, and this is like going to be scanning. So suppose this is my image. So this is like a full image, and now I've created a window of 5x5. So first we are scanning this, and I can take either the average, or I can take the lowest value, or I can take the highest value. And this entire thing I've converted into one block. It goes further and it would skip by 1 unit. So next is this, and it goes on scanning horizontally. Later on, it's going to go down, shift by 1, again scan horizontally, shift by 1, again scan horizontally. So this process keeps on. Happening. So you can see here there was 3. Then the next time we have shifted it here, and it's become like this. So this red part can now actually become this, and this green part actually becomes this. So we see with every step, or as we are going through every layer of the convolutional neural network, we're reducing the size also, and we're also studying the properties better. So for example, let us see here we have done max pooling. Max pooling is when you take the maximum value and you pull it across. So in this case, we have 6 as a maximum value, which is here. Next maximum value here would be what? 2, 3, 6, 8, 8, right? So that's here. And 1, 2, 3, so 3 and then 4. So that's how this is happening. Sometimes you might ask, so Dikshita, what if we were just scanning and it reached this particular point, but you still, you have nothing here. So how are you going to scan this one? If cases like that occur where your window size isn't fitting very accurately, what you can do is you can have zero padding, because zero is not having any value here, right? So you're just creating some zero values around. So you're adding like a frame or a zero padding, and that way you can go ahead scanning the next values. Okay, so we just understood that, okay, it's something that goes window wise sideways and then it goes down. So this is happening. But now next, how are we detecting a particular shape? Right. So if I said that I wanted those U-shaped dips, which we saw earlier in the animation, if those are the dips that I want to detect, what should I do? I create a filter. So just like we have filters on Instagram, so something very similar here too. So here, instead of going for a U shape, let us think of this line. Okay, this line is actually the little bum of this little rat. So I want to detect if it's a rat, and I'm going to detect it based on the bum of the rat. Okay, so what I'm going to do is I'm going to create a filter which is like this, and those values where this curve lies will take some value like this, and rest everything is 0. So if you see, this is actually the pattern of Mr. Rat's bummy, right? So this is my filter, and I'm going to convolve it. That's how the word is coming, convolutional. It's very simple. It's just multiplication and summation. Okay, you'll get it. I'll explain it. So what we are doing is this filter is convolved with the image that we are testing. So what we're going to see, what we are going to check is if this particular thing that is here is similar to this. Yes, so we are going to be checking that. Now, once this is convolved, two things can happen. If there is 0 values here, so 0 multiplied by anything is going to give me 0 value, which means it's going to give me a very small value. Otherwise, if it was exactly fitting this, then it's going to give me like a large number. So when we convolve here, we are going to see that, we get a very large number. On the other hand, if this wasn't the shape, and if I was seeing the filter is of the bummy, but the section of the image that I've taken is from the eyes section or the ear section of the rat. Here, what has happened, if you see, go away. Okay. So here what happens is when you convolve, you see the answer is 0. So it's 0 because it's not, the filter is not matching, and then we're not getting a value, right? So that way we can, you go on convolving and you get to understand if your filter is matching your input image. Now this convolution isn't like one layer. It happens in multiple layers. So here's how it would look like. So, the simplest example of handwriting detection or digit classifier, etc. That's there. So the same logic is being used. Here is your alphabet, and it's going to go through different layers. We have like, convolution, subsampling happens, then again convolution, subsampling, so etc. etc. till the end when you get like a Gaussian surface, right? So when you train this particular model on TensorFlow, this is the output, or this is how we could see, and the model had around 96% accuracy. Two of the important planets exoplanets that were discovered initially at the launch of the model were Kepler 90I, and okay, I've not mentioned the second one. Okay, one of them was Kepler 90I, which now the problem is this is 30% larger than the Earth, and the surface temperature is also about 800 Fahrenheit. So larger than Earth is good because humans have already polluted the normal Earth size. So 30% larger might take a little extra effort to pollute, and maybe we could survive there longer. However, the temperature isn't really supporting human life. That's 800 Fahrenheit, so that won't work. Also, the good news is it orbits the star every 14 days. 14 days means that you get to have your birthday after every 14 days. So that's a really good news. To wrap it up, there have been many exoplanets that have been detected. Some of them also have the potential to support life. But the problem is that even if you take the current fastest rocket by my favorite Elon Musk, that's the Falcon Heavy, even in that particular rocket, the human lifespan is not enough to reach that particular planet, right? So it's not only about whether a planet can support life, it's also about can humans cover the distance and reach that particular planet in a given amount of time. So that's the trick, and that's something that's not happening very easily. So the question that whether there is life on other planets or not still remains very debatable, but I'm of the opinion that yes, it is possible because there are so many stars and every star has its own planetary system. Also, did I mention that Kepler 90I, after our solar system, which has the maximum number of planets revolving around it, because the other stars have around 2 to 3 planets only, Kepler 90I became the second largest planetary system. So that had a decent number of planets revolving. That star has a decent number of planets revolving around it, which is an interesting thing to note about this particular planetary system and what made it even more special for us. So that is it. If there are questions, please leave them in the chat box and I would be answering them through chat because I'm not taking questions here in the live, but I am present and I'll be answering them in case if there are questions. Last but not the least, the universe is beautiful and it is under no obligation to make any sense for you. Expect miracles. Always try to think out of the box and go ahead exploring and work really hard. That's the only thing I would like to say. Thank you so much. Thank you for joining in for the session. I believe you all are having a wonderful time at this amazing event that is being hosted. Thanks, Usha, for having me here. It's been a really good experience joining all of you all today. Thanks to the organizing team too. You all have done a fantastic job. Thank you. Thanks a lot.
Thank you so much, Dikshita. It was definitely a fun, not interactive, but definitely fun and attention-grabbing session. I would regard this as the Jadoo session of the day.
Yeah, that's a really interesting topic. Thank you so much.
And then my co-anchor and me were discussing about those really cute miniatures on your desk.
Oh, one is Captain Marvel, and the second one is Black Widow. Okay. Let me give a quick shout out. Both are female superheroes. I'm really waiting for Captain Widow. Okay, Marvel film.
Yeah, all of us
I'm
are
waiting for the release of this particular movie. Let's hope that it comes soon. Because of pandemic, it's got delayed, but they are saying November is the time that we can expect it to be in theaters. So maybe watch from home. But really waiting for Black Widow to be released.
We could also be volunteers for Marvel if Marvel wants us to promote its Comic Con. No issues.
Oh,
Thank you so much.
Captain Marvel. I'm glad that you noticed them.
Yeah, definitely. We were talking about it.
Yeah, because see, it's a WITS event, right? Women in data science. So we need more women superheroes. Not that we're against the male superheroes. I think Iron Man is also one of my favorites, and so is Hulk. But for today's session, I think I want to put the spotlight on Black Widow, Wonder Woman, and Captain Marvel. Wonder Woman is in the other room.
They are mascots for today's session.
Oh God! Thank you.
Thank you. Next, we have Miss Geeta Kakrani. She will be telling us elaborating on the topic AI in healthcare.
Hi everyone, I'm Geeta from Gwalior. I'm organizer of GTT Gwalior. Today I'm here to talking and discussing about the AI in healthcare. So let's start. First of all, we introduce to myself. I'm Geeta Kakrani from Gwalior. I'm the CEO of Kanishka Information Technology. I have experience of 10 plus years. Actually, I have 15 years experience in technical area. I'm the organizer of GTT Gwalior and brand investor of the Domestic Maker and data scientist. Why I'm the data scientist? Because I'm doing the research in data science. But before it, I'm the web developer and mobile developer. AI in healthcare is today's topic. So today, first of all, we have discussed about the agenda. So now today we are going to discuss on this topic. What is AI? AI in healthcare, case study, and my research. What is AI? Obviously, AI is a very, very important part. Very AI is important technology. It's just not a small technology. It's not just a topic. It's not just a language. It's a very, very important technology because it's already playing an important role in our life. It's a technique which depend on the machine learning and deep machine learning. It's a technique in which computer make very smart and create ability to take decision smartly. AI is a very big technology, big subject in computer science, and but available in all our lives and all our topics in all our normal lives. AI depend on the machine learning and deep machine learning. So what is the machine learning? Machine learning is based on the data. Machine learning is a technique which used to analyze data and predict some result for future and for forecasting and for present. It's only available for particular tasks, but it's not suitable for large data set and dynamic data set. So we go with deep machine learning. Deep machine learning is an advanced form of the machine learning on the base of the neural networking. In the machine learning, we have algorithm supervised, unsupervised, but deep machine learning is depend on the neural network and use layer system. It's a man used in the image processing. It's a divide multiple images in the multiple layers and analyze it in each layer, so its production more accurate and it can work huge data sets. What is data science? Data science is a science. It contains all these terms: AI, machine learning, deep machine learning. Data science used to analyze the data. Data science is used to understand the data, relation of the data, then get the decision for particular task in a particular field. It's used in the healthcare, education, e-commerce, etc. But we are going to discuss AI in healthcare system. There are a number of examples of AI already used in the healthcare system because AI playing important role in the healthcare system. Why? Because for the AI, we use machine learning and deep machine learning, so it's need huge data sets. Yeah, huge data. So in AI, in healthcare system, we can get data in easily form because all medical educations, institute and hospital keep their medical history, they keep their data in a proper way, and using AI or machine learning or deep machine learning, we can get data easily. But if you have multiple data in image format, in other format, you have a large huge data set, then how can you manage? So using the AI and machine learning, we have number of apps, soft application which can manage data properly. Second, analyze of many reports like X-ray, MRI, CT scan, less than time in the human brain. Obviously, if we talk about the MRI, it's get image in thousands, and what is how is it possible for human it can analyze in a short time? So using some application, using some machine, we can analyze this report in a short time and more accurate. Its accuracy 81%. It's fast. Drug discover. Obviously, if we want to discover any drug, any vaccine, so we have to analyze patterns, virus pattern. We have to analyze symptoms pattern, number of data we have to analyze for discover new drug or vaccine. You know, this is a crucial time, corona, and still we are trying to discover vaccine. So, but we can expect then it can fast, more than fast. Because if we discuss about the old vaccine, then it can take time, 2 years, 3 years, 4 years, 5 years. But it can fast because AI is more and more powerful nowadays. So we can expect it can come in the last of the 2020 and starting of the 21. Second is the next point is a predict disease on the time and save life in earlier stage. Obviously, there are a number of applications. They can detect your problem. They can predict your diseases on the time. Otherwise, we always ignore small symptoms. But using these apps, we can predict diseases in fast way and save our life. Virtual nurses is a very, very important, because many companies are developing virtual nurses because virtual nurses are more impactable in the important person's life, like a grandfather, grandmother. They are very important in our life, but obviously we could not be always there. So if we keep some nurses and same some assistant, but human can mistake, they can sleep, they can ignore, but virtual nurses always watch them. They have medicine on the time, they are having diet on the time, proper diet, and they are doing exercise or not. So virtual nurses, we can watch them and we can check. Surgical robots, they are also contributing important role in the operation. It's not a means a robot are doing operation. No, doctors are doing operation, but robots are important. Robots are there with them. They are very providing smart instrument with they help to doctor, and operations are more success with surgical robots. Analyzing or genetic energy issues, it's very, very big problem nowadays, because in last many years doctors and practitioners are diagnosis and give treatment and medicine on all medicine all over person, same medicine to all over person on the basis of the symptoms. But it can very, very harmful, because each one have some different genetic issue, some allergic issue, so it can very dangerous. So if we keep for genetic history, allergic history, so obviously diagnosis can a proper way. Smart medical training, you know, AI is available in the training system also. Using the VR, virtual reality, you are modeling training, so you can you can train new medical student in a proper way. So it's available here also. Case study. Actually, I want to talk about my research, and I'm doing the research in the medical line. First of all, we go to some problem in the medical line. So according to WHO, it's a very, very big problem. Medical errors, wrong diagnosis, prescription, wrong diagnosis. So according to WHO, more than 138 million patients are harmed every year by doctors' error in the diagnosis, error in the medicine, prescription and treatment, and the inappropriate use of the drug are the three main reasons. Why? So this discussed by Neelam Dhingra in a press conference. It can solve. We can AI based instrument can check their symptoms, they can check their allergic issue, so we can give a proper treatment and right medicine, so it can reduce this dangerous condition. In India, case study 2 in India, because India is a many diversity, and obviously India is a developing country, and discovering many medicine. We have a qualified doctor, but only in metro city. And what is the condition in the rural area? What is the condition of the unconnected area? They still depend on their local practitioners and trust on the local practitioners. They have no enough knowledge. They have no they could not tackle the and identify such serious situation, so they can go in the danger. So record has already available 65% of deaths in rural area with small diagnosis, small problems, and they are dead because they could not take right medicine, they could not take right uh, medicine or treatment. Why? Because they are not they unknown about that, and they could not reach right the hospitals and right doctor. So how can we do this? In my research, obviously, technology almost reaching in a rural area and connected area also, mobile technology, internet. So if technology and medical line are do together, they can take help to each other. If we create some application, if we create some gadgets, so by virtual ways we can provide right guidance. They can aware about their serious problem, they can know about their situation. So obviously they can require also our help from government, from state government, from NGOs. So if we do together, then we can convey them what they should do and how can they understand their situation and how can they take help. So in my research, so if you have any suggestion about that, if you have any idea for that, then please share with me, because still we are doing research since last 2 months, and me and my team doing research. But obviously your idea, your suggestion can play big role in our research. You can connect with me, my LinkedIn ID, my Twitter, and my email. Thank you so much to listening me, and thank you so much, Usha, and entire team of WIDS for providing me this opportunity that I can share my research, my knowledge with all of you. Thanks a lot.
Thank you so much, ma'am, for being a part of this. Next, we have Monica, ma'am, on the topic creating word cloud in Python.
Hello everyone, good day. Welcome to Women in Data Science Conference Day 7, and thank you so much for taking time from your weekend and listening to our sessions. And yeah, before starting into the topic, let me introduce myself. This is Monica. I'm working as a systems engineer in Tata Consultancy Services. Uh, I have been with the community from more than a year now, and I'm also part of the JDG Cloud Bangalore organizing team. Yeah, that is pretty much about me. So let's get into the topic. So today I have taken a topic word cloud. Uh, why I have taken this topic word cloud is like when you hear the word data science, the first thing you have to be very um, the first thing is data visualization. Like first of all, you have to visualize the data, then only you can analyze the data. Uh, so for that, there are like mostly if you when you say that data visualization, scatter plot, bar charts, and the all other graphs will come. Word cloud is very less used, you can say, but it is also having its own advantages actually. Uh, when you want to uh, portray something to your customers or something, it should be visually uh, appealable, right? So for that I feel word cloud is a best visualization thing you can do with. And when you say that you're you're starting your journey with data science, so mainly three things will come. The first one is programming language, and the second is statistics, and the third is the domain knowledge. In these three, mainly the domain knowledge plays the main role. Programming and statistics, if you are having a basics, then you can Google them, and then eventually you can learn them. But when it's come to the um, domain knowledge, it's not basics won't basics won't be sufficient. You have to be a bit more uh, you have to have a good knowledge in that domain. Then only you will be able to analyze the data, and then only you can you can draw some output from it. So if you're starting your journey with data science and thinking which domain I should start, there's a lot of domains out there, banking and uh, this customer uh, uh, sales kind of thing, and there are a lot more things. But what I feel is like the domain which you select, you should know more about it, right? So what I felt is like, why can't you, start exploring yourself? Because who knows better than you? No one knows, right? Um so so that thought came into my mind, and I started thinking like what to know about me more. Actually, I'm a foodie. So what I thought is, why can't I see my food behavior, like what sort of cuisines I'm liking, or which time I'm consuming more, or why I'm ordering, a lot of questions. If you start think about the thing, it will, it will go on a the questions list will keep on going. So what I did, I thought to analyze my food orders behavior. This was happened before pandemic. Now I'm not ordering any food outside. So I thought of web scraping, and but I couldn't find any, good web scraping. I mean, actually, the web scraping. Actually, these food apps are not having permissions to web scrape. So what, like mostly in a day, maybe a maximum 4 to 5 times I would have ordered, right? So then what I thought, okay, let me manually, write down all the data. So I started um, I started opening all the apps, and I started writing down all the things, which I want mostly. So that's the start of my journey in data science. So I so wanted to share in this conference that there is no need to have a domain knowledge out and all to start your journey in data science. You can start your journey in data science by exploring yourself. Okay, so without further ado, let's get into the code and see how we can implement the word cloud and all. Yeah. Here already I ran the code because my internet is not that stable. So here these are the common libraries which everyone knows: pandas, numpy, and matplotlib, and c1. And here the new library is word cloud. So from word cloud, import word cloud, and I'm having my data in the drive. So I mounted the drive using these commands, and then I have read it. It's in my Excel file, and if you see the columns of my data, like I have captured a lot of information: app, item, original price, I paid, date, time, delivery location. This all are like how much ever I can, and I have taken, so that we can extract a lot of information from it. But in this session, I'm not using all these columns. I'm just using the restaurant column over here, and just printing the restaurant column. And I'm having a 79 records, like I have taken 3 months of data approximately. So I have done a little bit of cleaning process over here. I manually have taken data from all the apps which I'm using, like Zomato, Swiggy, and all. And I have created that database kind of thing. So while I'm entering manually, obviously some mistakes will happen. So and every data also you have to clean, because data is raw, right? So you have to clean it before processing. um, and just to explore what all things are there, like count and unique value counts and all. Just count will say that how many entries were there, and then n unique is a function where you will know that how many unique restaurants I ordered from. Um, and so there were like 39 restaurants I ordered uniquely. And value counts is a one where you will know how many times that corresponding data is repeating. If you take A to B, it repeated in the data 8 times. If you take Udupi Park, it repeated in the data for 4 times. So it's like that, the frequency. And this value counts is the main thing for us in word cloud. Based on that only we are building a word cloud. So for that we have to store this value counts into a dictionary, and then we have to pass the dictionary into the word cloud function. So this is the word cloud, and this is the basic things with height, repeat, pattern, color and all. And this is the main function we are using, generate from frequencies. So here we will give the dictionary which we store, where we store the value counts. And yeah, now we are good to go to plot the word cloud. So this is the word cloud. As you have seen that A to B is repeated 8 times in the data, that's the reason it is in a big font. And the other, if you see the stoner, flavors of India, this and all, their frequency is very minimum. That's the reason they are looking very small in the word cloud. So yeah, this is how you show the word cloud. And also one more thing, sorry, you can store back this word cloud into a file, like word cloud.to file, and give the path. Yeah, this is pretty much about word cloud. Thank you so much for your time and listening to my session. Thank you so much. And I wanted to thank the Women in Data Science Mysore team for giving me this opportunity. Yeah, have a great day. Thank you so much.
Thank you so much, ma'am, for taking out time on a weekend. Next, we have Miss Ramya. She'll be speaking about containerization and how it is used in Pokemon Go.
A very good evening to you all. I am Ramya, currently working as a software engineer at Oracle India. I also represent Women Techmakers Nagpur as an ambassador. Today, I am going to share with you all a very interesting and exciting topic called containerization. This session basically goes in two phases. In the first phase, we will be having a generic overview of containerization, and in the next phase, we will be looking into the application point of view of containerization. So, without any delay, let's get started. Firstly, when I say containerization, it essentially means packaging an application along with its requirements. It can be libraries, frameworks, configuration files together so that it can be run in various environments efficiently. It can be understood as a concept similar to encapsulation in object oriented methodology. Many of us have a general query on the difference between containerization and virtualization. The main difference between them is in virtualization, you can run multiple operating systems on the hardware of a single server. But when we come to containerization, we can deploy multiple applications using the same operating system on a single server. The next question that obviously arises is why many people are interested in this concept. This is because ultimately all we need is portability and efficiency, both which is provided by containerization.
It's portable because it is truly write once and run everywhere. And it's efficient because we use fewer resources and reutilize them. Kubernetes is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to cloud. Kubernetes groups the containers that make up an application into logical units called pods for easy management and discovery. Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized applications using Google infrastructure. The Google Kubernetes Engine environment consists of multiple machines grouped together to form a cluster. So when you run a Google Kubernetes Engine cluster, you also gain the benefit of advanced cluster management features like load balancing, automatic scaling, automatic upgrade for clusters node software, logging, and monitoring. Coming to the architecture of Kubernetes, Kubernetes follows client server architecture. So we have master installed in one machine and node on separate machine. Coming to the few components of Kubernetes, we have also known as a minion. It can be a virtual machine, physical machine, or a cloud instance. We have a pod, which is a collection of containers, and it's a part of Kubernetes cluster node. It is possible to create a node with a pod with multiple containers inside it. There can be two types of pod. The first is a protocol controller manager, which runs multiple kind of networking is a central part of Kubernetes. Kubernetes is all about sharing machines between applications. Typically, sharing machines requires ensuring that two applications do not try to use the same ports. Coordinating ports across multiple developers is very difficult to do at scale and exposes users to cluster level issues outside of their control. So, if we use dynamic port allocation, it brings a lot of complications to the system. So, in order to avoid these, Kubernetes takes a different approach. There are many implementations of Kubernetes networking model. For example, a few of them are Cisco Application Centric Infrastructure, Azure CNI, and AWS VPC CNI. Now, as we have gone through the concept of containerization, let's get into a detailed example in which it is highly used. Pokemon Go. Pokemon Go is a augmented reality mobile game launched in 2016 by Niantic in collaboration with the Pokemon Company, connecting us to the world of Pokemons. I think many of us had this fantasy to get into the world of Ash and battle with the trainers when we used to watch Pokemon. The game Pokemon Go is nothing less than a fantasy world. So, how was Pokemon Go world created? Firstly, not everything was a smooth sailing at launch. When issues emerged around the game's stability, Niantic and Google engineers braved each problem in sequence, working quickly Google Container Engine or Google Kubernetes Engine to create and deploy solutions. Pokemon Go's popularity quickly surged player traffic to 50 times the initial target, which is 10 times the worst case estimate. By these statistics, you might have understood the scale of the application. Beyond being a global phenomenon, Pokemon Go is one of the most exciting examples of container based development in the world. The application logic for the game runs on the open source Kubernetes project. Niantic chose Google Kubernetes Engine for its ability to orchestrate their container cluster at a planetary scale, freeing its team to focus on deploying live changes for their players. In this way, Niantic used Google Cloud to turn Pokemon Go into a service for millions of players, continuously adapting and improving. Niantic and Google engineers worked in concert to replace the network load balancer, deploying the newer and more sophisticated HTTPS load balancer in its place. The HTTPS load balancer is a global system tailored for HTTPS traffic, which is secure, offering far more control, faster connections to users, and higher throughput overall, which is obviously a better fit for the amount and types of traffic Pokemon Go was seeing. So, in this way, the creators were able to reduce the traffic and increase the scale. Pokemon Go was the largest Kubernetes deployment on Google Container Engine ever. Due to the scale of the cluster and accompanying throughput, a multitude of bugs were identified, fixed, and merged into an open source project. Coming to the networking, Google's global network helped reduce the overall latency for Pokemon trainers inhabiting the game's shared world. Game traffic travels Google's private fiber network through most of its transit, delivering reliable, low latency experiences for players worldwide, even under the sea, due to which multiple players were able to access the game at the same time and were able to play against each other. After getting to know all these facts, it's definitely a celebrated success worldwide. This is the overview of containerization and how it is used in Pokemon Go that I wanted to cover in this particular session. If you have any queries or want to know more about containerization, please feel free to reach out to me through Twitter. This is my Twitter handle. Also, I would love to know your feedback on how the session went so that more concepts can be introduced. Finally, I would like to thank the entire team of Women in Data Science Mysore for having me. It's a pleasure to be here and share my views with the amazing people who are taking out time to watch the sessions. Have a great week ahead. Thank you.
Thank you so much, ma'am. Next, and the very last session that we have scheduled is for Miss Purnima S. She'll be talking about AI in logistics.
Everyone, I'm Purnima. I'm working as a business executive manager plus software engineer at GlobeTech. First of all, let me thank Ms. Usha for this wonderful opportunity. I'm the Google Developers Group organizer of Kozhikode and WTM ambassador and an I'm remarkable facilitator. I'm working as a part of a global ERP solution product called Bridge LCS. So, as a part of Bridge LCS research, I came across some insights about how AI can be applied in logistics. This is a field where a lot of research need to be done. So, I'm sharing this insight with you. I'm expecting most of you are data science or AI enthusiasts, so you can do the further research in this field. So, let me first explain what is logistics. Logistics is simply saying logistic is the management of flow of product from one origin point to destination. Logistics is one of the fastest growing industry around the world.
Even in this pandemic situation, logistics cannot stop working because we need logistics to import and export medical equipment, sanitizers, masks, and all. So, as an important industry in this world, it has a lot of challenges to face. Like nowadays, uh, the amount of shipments is increasing. Customer is expecting fastest delivery of product in minimum interval of time. Also, a lot of e-commerce business are coming, so competition in this field is increasing. So, in order to withstand in this circumstance, logistic industry need to implement new technologies. So let me show you a graph that how AI can be implemented in logistics. From the starting stage, like when from the manufacturing stage of a product to end stage when the product is delivered to customer, each stage AI can be implemented. Like when we are manufacturing the product, we can use demand prediction method to know whether a product has demand in the market. Even regional ways, there will be difference in the demand of a product. So we can plan the business according to it. We can reduce the cargo charges, transportation charges by peak hour prediction method, by knowing the optimal route for the transportation. Even at the end stage, we can use drones to deliver the product to the customer. The next important thing, or the most important thing in a business, is experience. So, even an experienced person cannot remember all the things that happened in the past, like all the transaction and business that has happened with a particular customer or supplier. So, big data can help you for this. Big data can keep track of all the past concerns. Big data can identify the repeated trends. There will be some trends, regional ways, seasonal ways in business. So, big data can help to identify or keep track of these things. And also, if you are businessing with a particular customer for years, you will not remember all the transactions that happened to a particular customer or supplier. There will be thousands of customers that is businessing with you. So, using big data, you can choose a particular quotation with a particular customer by analyzing the past business that we have that with that particular customer or supplier. Big data can help you to make decisions, corporate decisions. It can prevent the unforeseen circumstances. Also, it can help to lower the operational cost. It can help you to apply the contextual intelligence, all those things. The next important field area of technology that can help in logistics is robotics. Robotics can also help from the start stage, from the manufacturing factories to end stage. We can use drones to deliver the product. I'm just showing you an example like how robotics can help in warehouse. In warehouse, we use standardized containers for loading and for transportation of products. So we can use loading and unloading of containers. We can use robot for this purpose, like arranging the things in the vehicle. All those things are very time consuming. So if we use some robots for this, it will reduce a lot of man effort. Also, we can use stationary piece picking robots or mobile piece picking robots to arrange the products of a particular order in warehouse. A stationary piece picking robot will pick the entire shelf for you, like according to order. If a product is in some shelf, the entire shelf will the robot will pick the entire shelf and give that to you. If you are using mobile piece picking robots, they will identify the product and they will pick the particular product and give that to you. Even we can use custom or co-packing robots, robots that can work with humans. This is an area a lot of research need to be done because the safety of co-workers is very important. So it should be safe to work with a co-packing robot. The next thing or the next technology that is applied in logistics is computer vision and augmented reality. Computer vision, using computer vision, we can
analyze the damage of the product. We can read the thousands of barcodes in a single shot. Using image processing technique, we can identify the damage and classify the product according to the damage. So this will help you to reduce the time. Also, augmented reality. Augmented reality is superimposing the computer generated image to human vision. So this thing can also help to identify the order and product. Like if the employee is using some specs, he can identify the product for a particular order. The next thing is autonomous vehicles. There are self-driving vehicles, but still there is a lot of research going on this area. Even now, we can use human and machine as a strong team. Like a machine should know where the where the truck is going, and machine will take care of all the rules, all the traffic rules are followed, or it will keep an eye of traffic. Like it will have sensors and cameras in all sides, so it can keep track of all the things that happening in the road. Also, it can find the best routes or reduce the fuel consumption of trucks. The next important area is customer service, because logistic industry needs 24 to 7 customer service. So we can use chatbots for this purpose. It will also reduce a lot of human time. Chatbots will chat with the customer. If some negative sentiments or emotions is happening from the customers, chatbots can identify it and and then pass the control to some humans to handle it. So these are the some areas where AI can be implemented in logistics. Most of these things are very expensive and some of them are complex. So our duty is to make it less complex and less expensive. And if you want to connect with me, I'm sharing you the LinkedIn profile and my Twitter profile with you. Thank you.
Thank you so much, ma'am, for the very informative session. With this, like this was the concluding session for the day. But the thing is, all of these sessions run because of a hardworking organizing committee behind all of this. Let alone, like definitely thanking Usha ma'am for all of this, and other members are also involved. The other core committee members are involved with the scheduling to the broadcasting of the entire session to you guys. So with me, I have a couple of core committee members who would like to share their experiences, their journey with you guys. So first up, we have Prithvi. Hi, Prithvi.
Hello, Ritu.
Yeah, Prithvi, could go on.
Yeah. So, hello everyone. I'm Prithvi, and I'm currently pursuing my computer science engineering from JSS Science and Technology University in Mysuru. So, I have been a part of WIDS for the past 2 to 3 months, and it has been a wonderful experience. I have got the opportunity of hosting many events and speaking to so many wonderful women who are so passionate about their work in the field of data science. Also, Usha ma'am, not to forget to mention her, she has been so wonderful and she has been so supporting towards us. I thank you for that, ma'am. And yes, it has also made me realize so many things and so many aspects about data science myself. And I feel fortunate enough to have got this opportunity to talk and meet so many people in this industry. So was
Thank you, Prithvi.
thank
Next
you.
up, we have Arya.
Very good evening to all of the viewers and people who have participated today. I hope that you all have enjoyed the event that we had today, as well as all the events which you all have been a part of prior to this. Um, I am Arya, as I mentioned, and I am a student at NIE, and it's a pleasure that now I am a part of the core team of WiMLDS Mysuru. And it's been around 2 to 3 months since I've been a part of this, and I can say, well, it's been quite a thrilling journey till now. We have got a lot of experience with a wide strata and aspect of things, be it organizing stuff and getting speakers for the event, or it could be the marketing part, which plays a very, very important role for any event. It could be designing the posters, marketing them, getting a audience, getting it to reach so many people like you all who are interested into events like this. So, covering a wide variety has taught us a lot, and obviously, data science is taking a big boom of late, and getting to know what amazing and innovative things people are doing in the world, and seeing that all of you all are being aware of such innovations is a really good thing and a good cause that we are working for. So I feel blessed to be a part of this. And yes, as all of this is happening, very importantly, I would like to mention Usha ma'am. She has been a backbone. She has worked hard throughout in ensuring that everything goes at pace without any hustle or bustle. And we are really indebted to her for giving us this opportunity and the experience which not everyone gets. So thank you to Usha ma'am, and also a big thank you to all my other core team members, because without them, again, we ourselves wouldn't be able to put up a good show. So a big applause to all my team members and Usha ma'am. So thank you so much.
I gladly accept your thanks, Arya. Next up, we have Apurva. She'll be sharing her experience with you guys.
Okay, so hello to all the viewers who are listening for today's session. I am a student of Vidyavardhaka College, and talking about my experience, it has been a wonderful experience getting to know like 10 speakers a day, connecting with them, networking with them, and just getting inspired by what work they are doing. It's truly commendable. So my journey in Vimality is not very long, but I've been a part from 4 to 5 months now and conducting these events. And as you can see, it's 7 hours, 8 hours. We given a lot of hard work behind it. Hope all the viewers, they are loving the show. And all the speakers, a big thank you for coming and sharing your experience. It's the learning which you share to us will inspire us and the viewers. So overall, it has been an amazing journey till now. And watch our videos, and a special mention to, of course, Usha ma'am for bringing it all together and having our back always. Back to the anchor.
Definitely, Apurva. So, all thanks to Usha. Ma'am. Next, we have Bala Chandra. Bala.
Hello, hello guys, hello listeners. So I'm Balchandra, currently pursuing my third year engineering in NI College, Mysore. So my experience with the WiMLDS team, so it has been actually a good journey. So it all started when we started we started our first datathon event. We started our first datathon event in NI. So I had the biggest thing I've learned from working with WiMLDS is it's how important it is to like connect with other people and learning from their experience. And I also want to thank all the team members who were able to pull off this big conference. As Apurva said, it was like an 8 hour event. So I thank all the team members and always Usha ma'am for getting all this thing done. And yeah, that's it. So I love working with WiMLDS. Yeah, thank you.
Thank you, Balchandra. Next we have Prahasit. He's also a core team member, but he couldn't join us due to some circumstances. But he has put up a recorded message for us. I'll be playing it.
Hi guys, this is Prasit from WiDS Mysuru. I am a volunteer in the WMLDS, DFUG and GDG Mysuru chapter. Firstly, I hope you all enjoy this month-long WiDS event. And coming to my experience at WiDS, it was just fabulous. Firstly, like all of you would have expected, I joined here for the WIDS, TFUG, and GDG tag. But later on, I got to meet with technical speakers all over the world. Not just speaking, I got to interact with them for a long while, and hearing to their sessions also educated me at different aspects that I probably hadn't had even uh, little knowledge about. And also it is a wonderful experience working here, and gives me more network and reach out as well, being in WIDS, and it was great. Like, it's not been even 6 months, if I'm right, and within 6 months, if I could have a wonderful journey, then I'm just expecting how good it could be in the future. So that was it, and it was really, really amazing to work with such people at WIDS. And I hope you all enjoy the month-long session, and looking forward to work with WIDS in the coming days. Bye, guys.
Thank you, Prasit. This more or less concludes everybody's experiences. I was the host behind the camera for the entire day today, and I do have a speech prepared for sharing my experience. Good evening, all. I am Rituraj. I'm a CS student at JSS Mysuru. I have been a part of GDG, TFUG, and WMLDS for in the. I started in early weeks of July, and then since then I have worked with so many talented people from different, who are responsible for making posters, who host the event, who get in touch with people, who bring such strong collaborators to this all and organize such sessions. Nevertheless, Usha ma'am has been behind all of this. She has made all of us into a team, made us into a team, made us comfortable with each other, and then that is how we are able to put up such events. And then this journey has been rewarding, not just because of the technical topics that we touch, but also in terms of the things I learn from different people, the way I communicate with them, the way I improve by each going on session, each event. So that the journey has definitely been very rewarding. And I would like to thank Usha ma'am and the entire community for having me. Thank you. Also, definitely we did reach to an end, but we have really good sessions lined up for the entire for the next weekend too. I would I would suggest all of you to stay tuned and then check out our YouTube channel, check out our meetup pages for all the further events. We do have an event tomorrow. So tomorrow is a Sunday, which is another weekend. So we start off tomorrow at 12:20. We have very informative sessions again tomorrow too. Do stay tuned. Check up our meetup pages for all the different topics that we it will be covered in tomorrow's session. Thank you so much. Thank you all the core committee members for sharing their experiences. I would like to thank my co-anchors Harshita, Arya, and Isha for all of their support. Without this wouldn't have been a success. Thank you so much.